No problem, ma'am, please. Namaskar and good morning, ladies and gentlemen. I, Anchor Manhar, on behalf of ITU-APT Foundation of India, take a great pleasure in welcoming all our distinguished delegates, subject expert speakers, senior government officials, guests from overseas, and friends from press and media to day 2 of the 4th India Spectrum Management Conference 2024. I hope you all had an amazing time yesterday witnessing and hearing from our eminent set of speakers. Ladies and gentlemen, prepare to be swept away by the immense gravity and magnitude of the subject expert speakers, leaders, and networking opportunities. Ladies and gentlemen, without any further ado, may I have a pleasure of inviting on stage Mr. Bharat Bhatia, President IAFI, and request him to do the honors of welcoming all our guests with the chief guest by presenting a floral bouquet, starting with Shri T.R. Dua, sir, Chairman IAFI. So may I request you to please join us on the stage. Inviting Mr. Hiko Ross, Director Sales and Marketing, LS Telecom, to please join us. Mr. Hiko Ross, Director Sales and Marketing, LS Telecom. Welcome, sir. Professor Rolf Katz, President, Telecom Advisory Services, LLP, USA, and Visiting Professor, University of San Andres, Argentina. Welcome, Professor Katz. Thank you so much for gracing the occasion. Ms. Revati Mannepalli, Joint Wireless Advisor, WPC Wing, DOT. Welcome once again, ma'am. Welcoming Mr. Forhadul Parvez, Program Officer, APT, Bangkok, Thailand. Welcome, sir. Inviting and welcoming Mr. Alexander Kuhn, Netza, Germany, and Chairman, CPM WRC 27. Welcome once again, sir. Ladies and gentlemen, please join me in welcoming our honorable chief guest of today, Ms. Isabelle Moro, Director General, Global Satellite Operators Association. Welcome, ma'am. We are honored to be having you with us today. Inviting Dr. Satya N. Gupta, Secretary General, IAFI. Welcome, sir. Ladies and gentlemen, let's begin with today's proceedings. I request Mr. Bharat Bhatia, sir, President IAFI, to please give the opening introduction and agenda introduction. Sir.
Last की slide डाल, last वाली slide जो बनी थी, कल वाली. Very good morning to all of you, and thanks for arriving on the second day also. Yesterday we had an excellent day, I think. I know the room is not so full today, but I think we have all the right people here. And today we are going to have very good sessions. Actually, the first session is more focused on organizational aspects, how the Indian spectrum management works, how the APG process works, how in Germany they look at the CNPN kind of networks, and we have friends from LS Telecom, which are going to project some futuristic ways of spectrum management. So this session is going to be very important and interesting for the future of spectrum management. And this we will follow with the very important subjects, broadcasting, PMSC, and radio astronomy. Some of these services, we always talk about 4G, 5G mobile services, but these are also very good radio services, and I think we need to take account of all of those services. So that will cover the second session. And the real fun will begin in the afternoon when we have a session on the satellite spectrum immediately after lunch, both for GSO and non-GSO. And the last session of the day is going to be a workshop on 6G and how India can take leadership role in the 6G R&D development and the work that we are doing in ITU Working Party 5D on defining the 6G roadmap and 6G parameters. So we have a good program chalked out for today, all the best experts from all over the world. And hopefully everybody will learn something, gain something, and will be able to interact more fluently, and we will be able to share our thoughts, our processes, and our way forward for growth of the ICT industry in the world. Thank you very much.
Thank you so much, sir. Ladies and gentlemen, I would now like to request Shri T.R. Dua, Chairman IAFI, to welcome the gathering. Shri Dua has over 35 years of experience in the telecom sector, including product development, business development, telecom licensing and regulatory issues. He has held prestigious positions as director in leading telecom companies like Bharti Airtel Limited, Sham Telecom Limited, and COAI. We welcome him.
Good morning, ladies and gentlemen. A very warm welcome to all panelists on the dais and my colleagues off the dais. As Bharat rightly said, when you go to international workshop, conference, conclave, you start dot at 9 o'clock, irrespective. But here we have certain issues which come up every day morning and again late in the evening. But all this said, as he rightly said, you have the right people here. Thank you so much, Bharat. Further, I'd like to convey on behalf of AIAFI heartiest welcome to Mr. Mario Menikar, Director R, RTU. Mason Kondo, I suppose, is not here. And all our honored guests who have come all the way from abroad, and we are delighted to have them here. Besides, welcome to all my industry colleagues, senior member of the DOT, and most importantly, our WPC friends who have really provided the insight and very clear thoughts for the roadmap for the spectrum and challenges. Yesterday, we have very exciting sessions there which addressed whole sort of issues regarding spectrum management, pricing, roadmap for various services, planning of 6G, and beside that, what was the learning from WRC 23 and what is the roadmap for WRC 27. As rightly said, frequency spectrum is one of our nation's most important resource to promote leadership in the wireless technologies. And thanks to Indian administrators, Indian administration, Government of India, WPC, is committed to careful planning and cooperation among government agencies and private sector. Digital transformation in telecom refers to the process of using digital technologies to fundamentally change the way the telecommunication companies operate and deliver services to their customers. This can include, and does include, the adoption of new technologies such as 5G, 6G, Wi-Fi, 7 data centers, SATCOM, and the use of data analytics to improve decision-making, the implementation of virtual and automated customer service. The goal of digital transformation in telecom certainly is to improve efficiency, reduce cost, and increase the revenue by leveraging, this is very important, by leveraging the power of digital technology. This can involve a wide range of activities such as automated processes, using data to better understand customer needs and preferences, and developing new digital products. To improve access to technology, the government launched various initiatives to increase the availability and affordability of the digital services, such as laptop, smartphone, internet connectivity in rural and underserved areas. The government does invest in improving and helps to improve the digital infrastructures, such as building out the high-speed broadband networks, data centers, establishing policies, and support the growth of the tech industry. Now, to promote the adoption of digital tools and services, the government works with various stakeholders, like businesses, educational institutions, other organizations, to provide training and support for the use of technology. This also includes initiative to encourage the development of local technical and also the startups. Let me tell you, digital transformation is often the brainchild of disruption. And the Indian telecommunication sector is no stranger to such event. From an operational standpoint, if we look back, we saw the disruption in telecom with the advent of the mobile phone, which were priced very cheap, and the customer and the consumer who could otherwise not have been able to operate the luxury. Now, spectrum is very important, be it digital public infrastructure. If you look back COVID-19 and COVID time, the mobile networks also helped people to work from home, and the way of working solved one of the end problem and created another for the industry to solve. In all sincerity, the TSPs, the IPS, the aggregators, the DCs, the OTTs well stepped up their product offerings, thereby enabling the subscriber to have the word and the livelihood within the power of their. As a result of the ongoing innovation in wireless technologies, the demand for spectrum is growing rapidly. In the private sector, the next generation Wi-Fi networks, large satellite constellation in low orbit, rapidly increasing space launch cadence, aggregated data transfer, 5G, 6G broadband, private wireless network, autonomous vehicle, and other advanced system drive demand. Spectrum sharing, trading, leasing is one of the key to meet all these growing demand. And India is uniquely positioned to embrace the whole of the nation approach to advance. What is happening and what India and our spectrum regulators are doing, a very comprehensive strategy to modernize spectrum policy and make the most efficient use of the possible of this vital national resource. Thank you so much.
Thank you very much, Mr. Dua, for the warm words of wisdom and sharing your viewpoints with all of us. Ladies and gentlemen, may I now have a pleasure of inviting Ms. Revati Mannepalli, Joint Wireless Advisor, WPC Wing DOT, for special opening presentation on Spectrum Management Organization in India. Ladies and gentlemen, please put your hands together and welcome Ms. Mannepalli.
So very good morning. Yesterday we talked about general topics. Now today I've been given the opportunity to talk about the Spectrum Manager in India, the Spectrum Management Organization. That is the organization Wireless Planning and Coordination Wing, where I belong to. It's a part of DOT, but it's a dedicated Wireless Planning and Coordination Wing. Can you go to the next slide? Yeah, if you see it, we come under Ministry of Communications. In the Ministry of Communication, we have two departments. One is Department of Post, another is Department of Telecommunications. In the Department of Telecommunications, this dedicated wing is there. It manages all the inter-spectrum management, including orbital resources. And TRAI is also independent regulatory authority under DOT. And TRAI provides recommendations on introduction of various services, including spectrum assignment for that services, predominantly commercial services, both telecommunication and broadcasting. They're of recommendatory nature. As you go on, you will see what is the functions we'll be doing, what TRAI is doing, what the other organs of the DOT are doing it. This WPC wing is established in 1952. In line with that time, at ITU, decision has been taken that every country administration should have a dedicated spectrum management wing to take care of spectrum management activities without causing interference. Then it is, of course, I already told, it's a nodal agency for the Government of India for management of radio frequency spectrum as well as satellite orbital resources. ITR activities, our wireless, it is headed by wireless advisor, Mr. Christopher. Yesterday he was here. And he is the nodal for all the ITR related activities at ITU. Then WPC wing is a ministerial office. We do this policy planning and licensing work, spectrum licensing. And we have a subordinate office. It is called Wireless Monitoring Organization, which is a network of monitoring stations for enforcement, other planning and management activities. Jointly, of course, jointly responsible for spectrum management in India, and WMO is the eye and ear of WPC wing. If you see this chart, what is, where do we stand? Organizational interaction of the spectrum manager. And if you see here, the TRAI will be sending a references how to assign the spectrum for these commercial services. And TRAI provides their recommendations. They are of recommendatory nature. They do open consultations, open house discussions with the detailed justification. They come up with the recommendations. The final authority rests with the Government of India, the Ministry of Communications and the WPC, which assigns the spectrum. And as part of our work, we will be interacting with so many major departments, especially with MIB, and if it's related to any of the telecommunication services, an entity who wants to provide any telecommunication services in India, they need to obtain one service authorization from the DOT, that is another service licensing wing. Then that service license requires a spectrum assignment. They'll be approaching to WPC wing to get the spectrum assignment. Similarly, if it is a broadcasting service, we have another department here, Ministry of Information and Broadcasting. And that Ministry of Information Broadcasting gives the service license for broadcasting, like TV broadcasting, DTH, teleports, so many things we have. Then they apply to WPC wing for the spectrum assignment. These are major things. And we have a continuous interaction with the Department of Space, ISRO and InSpace, because all the satellite orbital filings, coordination happens through WPC wing. We are the nodal agency. And apart from that, we'll be supporting all these frequency assignments for all telemetry, tracking, remote sensing, extraplanetary, interplanetary operations. We have a Mars lunar missions, Adityan and all. Major are these, and of course we have all domestic, terrestrial and space services users, both captive, commercial, safety, and major user is of course Department of Defense, Ministry of Defense. And we have yesterday also I touched it upon, we have a national study groups and national preparatory committees, national study groups corresponding to ITUR study groups for contributions to ITUR as well as APT, and similarly NPC, National Preparatory Committees for WRCs and APGs. We have, with the wider stakeholder consultation, we have established a mechanism, we work and come out, give the contributions there, and we try to get a consolidated, coordinated contribution and submit it. Then we have a MITI, of course, Ministry of Electronics and Communications, because we do a lot of certain frequency bands we exempt from the licensing purposes, that is called D-license bands, based on the device ecosystem, and that is also being done by WPC in consultation with the various user ministries along with the stakeholders. So of course this TDSAT is a appellate tribunal. All the telecom related issues is being handled by this TDSAT. Then go to the next. Oh, sorry. This national legislative framework for spectrum. See, national law, we have been issuing the license. Even today, we are issuing the licenses under 2 acts. I'm talking here purely of the spectrum licenses. Of course, telecom service license also under this act only it is being issued. The spectrum is delinked from the service license. So this currently the laws in force is 1885 Act and another act, Indian Wireless Telegraph Act 1933, which have been replaced by a single act recently in the December 2023, that is Indian Telecommunication Act 2023, and certain provisions have not been brought into use as on date, because we are making the rules under those acts. Once everything is ready, we will be shifting over to those act. Certain provisions of that act have not been even brought into force as on today. We are continuing to give the licenses under this act as on date. We'll be switching over to the tax maybe probably within 2-3 months once our rules are finalized. Then the TRI Act 1997, with amendments and all, it is still there. TRI and TDSAT functions under that act. When come to policy and plans, we have a national telecommunication policies, NTPs we call, and last one is NDCP, National Digital Communication Policy, that is 2018. It gives a policy objectives and goals, what are that, including for the spectrum management. And the next is the National Frequency Allocation Plan, which is equivalent to Table 5 of the RR. I told yesterday also, we are in the process of revising the current National Frequency Allocation Plan in line with RR 2024. You will be seeing in shortly, maybe in a matter of 3-4 months, you will see 2025 out NFAP. And this NFAP, apart from, you can see the India-specific footnotes where we are, that policy decision, certain frequency bands for what purposes we are using in India, apart from whatever is been taken in the RR. So major functions of WPC wing, as you already know, we do that spectrum allocation, that is nothing but NFAP. We try to give broadly what are the bands allocated for different services, then dive into spectrum assignment. Within that, what is that spectrum assignment to each user we are going to do, and of course international and national coordination we do with for these frequency assignments and ITUR and ITUR related activities at regional level and at global level. Apart from that, we have auxiliary functions like SACFA, that is Standing Advisory Committee for a tower clearance. Whenever any fixed tower is installed, wireless tower, for the aviation and EMI, EMC interference analysis purpose. It is an interministerial committee. We clear it. We do that work as well. And of course, another work is the certificate of proficiency examination. That is for radio telephony restricted for the pilots and for the mariners, Global Maritime Distress Safety Services. Almost every month we conduct this exam. An average around 12,000 to 13,000 candidates, or more than that, we conduct in a year across India, all the centers. For the communication side, one paper is on the communication. Of course, others in coordination with DGS, Director General of Shipping, and in coordination with DGCA, Civil Aviation, respectively. So this is a pictorial representation. What are the coordination we do with national and international? As I already told, it has been represented here. And you can see one more color there. It is ITSO, IMSO, and IMO, ICAO. These things also our people represent through concerned nodal agency, nodal ministry in the India. Like DGCA is a nodal ministry for ICAO. There will be a spectrum expert from WPC will be participating in those meetings. Similarly, DG Shipping IMO, spectrum expert from WPC will be part of that. And we have a lot of satellites. I myself participate a lot in ITSO and IMSO. This is the licensing and WPC, what it does, I said. Then we have a field organization which supports with the monitoring and inspection and compliance. That is WMO, Wireless Monitoring Organization. I don't know whether it's clearly visible. Yes, it is entire India has been divided into 4 regions, north, south, east, west. Under each region we have a monitoring stations, some of international monitoring stations, some are normal monitoring stations. You can see them in the picture next. So if you see in that violet colors are international monitoring stations. We have a total 28 monitoring stations spread across India, and most of them are physical monitoring stations with the mobile facility we have. Among them, 5 are international monitoring stations. They are registered with ITU. There is a difference between normal monitoring station and international monitoring station. When you say international monitoring station, they are supposed to have some facilities in case of any international sort of monitoring you need to do. ITU or countries can ask for that help, and we can do it. Predominantly, they will be in HF frequencies and MF frequencies, and you have a direction finding facility to find out. That's why they are located at a strategic all the locations, Delhi, Mumbai, Chennai, and Kolkata, one at Nagpur, at the center of the place. Apart from that, of course, all these 27 monitoring stations are terrestrial. We have one satellite monitoring station at Jalna, that is near Bombay, Maharashtra it is. That facility we can monitor only GSOs. Currently, we are planning to upgrade it to have a NGSO monitoring as well through mobile platforms and all, mobile transportable monitoring setup. And of course, these are a 2-tier system. We have a regional headquarters, handles under each monitoring station, and national level, one headquarter that is placed in Delhi. What do they do basically? See, from the WPC, you give the spectrum. Then people started using, in the field you go, you give with a keep of distance and protection. Still on the field, because of different geographical terrain and all, we experience on and off lot of interference issues. So majority of the time, they will be resolving these harmful interferences. And in India, we have another peculiar problem of this boosters. This mobile signal will not be reached at the cellar or underground or in some places where the towers are, sometimes they don't put proper towers, or sometimes it is not reaching. So people are forced to buy a bidirectional amplifiers and put them. They started malfunctioning if they are not putting proper standard one, which cause interference to all the licensed users. That's a big headache for us, and regularly on and off, our teams are on the job to find and remove them. Apart from that, we have to protect all safety frequencies. Similarly, this search and rescue frequencies, air traffic control, ATC frequencies are very, we have to ensure if there is an interference, we have a quick response team. We should be able to resolve within 4 hours. At least we should be able to identify what is that. Some of the interferences are intentional, some are unintentional. So unintentional also very difficult to locate, and especially in congested areas and high-rise building areas, it's a tedious task, but with the limited equipment and limited manpower, we are able to do it, pooling all the resources on the priority basis. Then, of course, for introduction of the new services, we'll be again monitoring the frequency bands, and when predominantly most of the bands were used by the government users earlier, we do periodical monitoring to find out whether the spectrum is being used, or spectrum, sometimes we do for 3 months at a stretch to identify certain frequency bands are vacant, and we can go for it before taking up for spectrum reforming process. Then we do that spectrum audit as well. And another function is to ensure adherence to the license conditions. Space emissions to protect authorized satellite transmissions. Of course, we have a KU band facility with other monitoring stations also we started establishing now. But with the Jalna, we can monitor only GSO things. And another problem is we have a cross-border interference and cross-border coordination. We have equipments to monitor, and we try to do that. And assistance to foreign administrations. Sometimes we get for, especially in this MFHF and all, to help to find out whether there is an interference, from which direction it is coming, and all. Our international monitoring stations will help to do that. So main spectrum usages, if you see in India, so we, unfortunately, in the meetings, we generally talk about only either broadcasting of public broadcaster or telecommunication, IMT, and now we started talking more about satellite because of NGSO. Otherwise, we have so many users, so many usages here. If you see out of 41 radio communication services, you see in the satellite itself, we have earth exploration, we have radio navigation satellite services, our NAVIC systems. We need to protect those things, and we used to give proper frequencies to them. And we have a deep space missions, that is space research services. We have a station at Bailalu, we need to protect it. We have a radio astronomy. Yesterday, the professor is here even today. We have one facility at, Pune. We need to protect. If they are experiencing interference, we collaboration with other existing users, we try to find out that keep off distances. This all will be done through our WMO. And defense, aeronautical, maritime, and science services, and of course telecom services and broadcasting and public safety, all our police organizations, and for the transport systems, metros, all these things, variety of uses, variety of frequency bands. People sometimes think, oh, so much of frequency band, we are only using, why these people are not giving? Because nobody will be happy with the WPC, because everyone was asking the spectrum. And the public will see only, oh, only IMT is the spectrum, or broadcasting is the spectrum. There are so many other, everyone is vying for the same spectrum. They are very critically important. It is not visible, like. So I have one slide I can show you. I just want to show our difficulty in 1 or 2 slides. If you see here, these are all airport, they need dedicated frequency bands, and people must have heard of ultimate issue in India. 5G we are doing, and that is safety issue. Then there is a GMDSS, Global Maritime Distress Safety Frequencies. Those frequencies we need to protect, we have to give them. And we wanted smart cities, smart villages, and they need frequencies. We are giving, we have to give. Then of course ISM and medical implants, all those operates in the wireless. You have to, and you should ensure that your pacemaker should not get interference if it is coming here. It's your life and death risk. So we have to ensure that. Then we have RFID, we have in-flight connectivity, we have a multitude of users, and they should coexist also. This is space communications, and we have a science services, remote sensing, airports, metros, weather, police, and of course, ship, all the ports also they need frequencies. So how do we do this spectrum licensing? Once we determined what are the frequencies, how much spectrum we are going to give each operator or each entity, and we have determined the method of assignment, and we also determine the charges and what charges it has to be assigned. Then there is a process. People have to apply on the portal. The portal is developed by in-house, our BSNL. We call it a Saral Sanchar portal of DOT. Everything spectrum licensing is made end-to-end online, and that is administrative module. We can see it is in the DOT website. Then technical module, whatever we were having earlier, it has been condemned and we are trying to use standalone modules. Now we are in the process of purchasing another technical analysis module, that is automated spectrum management system. It is in the process. With that, I conclude my session. Thank you.
Thank you so much, ma'am, for your insightful words and sharing your expert views with all of us. Ladies and gentlemen, I'm delighted to introduce you all to our next speaker, who's here all the way from the US, Professor Raul Cards, President, Telecom Advisory Services, LLP USA, and visiting professor, University of San Andres, Argentina. He'll be giving a special opening presentation on economic study of Wi-Fi spectrum. Ladies and gentlemen, he is also a director at Columbia Business School, where he focuses on digital strategy. Previously, he had led the telecom practice at Booz Allen Hamilton. Dr. Cards is an expert on the economics of digital technologies, particularly unlicensed spectrum. He holds a PhD from MIT and degrees from the University of Paris. Ladies and gentlemen, please join me in welcoming Professor Cards with a thunder of applauses, please. Sir.
Well, good morning. What I'm going to try to do here is present some basic tenets of a way by which we can value spectrum, not from the perspective that traditional economics does it in terms of if spectrum is licensed. As you well know, one could assume that the value of spectrum that is being auctioned and for the private use by an operator, its value is driven by the amount of money that the licensed operator is paying for that license. And you could say, well, the value that that spectrum would imply is whatever money was paid at auction. When you have spectrum that is unlicensed, you cannot do that because by definition, that is open to anyone that can use it as long as they follow certain rules of interference, usage, and the like, which is why assessing the value of unlicensed spectrum is trickier than one might think. Let me start by stating why unlicensed spectrum is important, because if we're talking about, let's say, 6 gigahertz band, which is one where governments are considering to use it for unlicensed use, essentially, why is it important? And there's a paper that was written by the 2020 Nobel Prize, Paul Milgram, whom we might all know because he's a key developer of theory of auctions, where he said the dichotomy between licensed and unlicensed is unreal. In fact, spectrum has to be licensed, but some portions of the spectrum have to be assigned for unlicensed use. And why is that the case, he said? Well, because in fact, unlicensed spectrum is critical as a factor of production, particularly in terms of a technology that is complementary. How do we define complementary technologies in economics? It's basically a technology that allows other technologies to actually accelerate its adoption by lowering its cost. And is essentially what is going on, particularly in the case of Wi-Fi, where Wi-Fi is helping the development of licensed networks to reduce cost and therefore increase its affordability. More importantly also, unlicensed spectrum is critical because the portion of the spectrum is a site for innovation. And some of you might know the term of the tragedy of anti-commons. The tragedy of anti-commons says that if you assign spectrum only for private use, whoever owns that license establishes a barrier to entry to whatever innovation might occur. Either you abide by my rules defined as me being the owner of the spectrum, or you cannot actually innovate. You cannot develop new products. Well, if you have a portion of the spectrum being declared as unlicensed, anyone that comes up with a new innovation and it abides by those rules, they can actually introduce it into the market. And that's what the tragedy of anti-commons is eliminated, because basically what you've done is you reduce completely the barriers to entry. So this is why this is important. And I'm not talking about an either or. As Milgram says, what we have to think about it is an ecosystem of spectrum where both methods of assigning spectrum have to be considered. So how do we value spectrum when spectrum is unlicensed? As I said before, if we were to auction it, that would be pretty simple. But when we have it in an unlicensed fashion, we have to proceed along two dimensions. On one hand, what we do is we look at three areas of value. And those three areas are the contribution that that unlicensed spectrum is going to have on the GDP by virtue of the fact that you're reducing the cost, or you're creating the ability for some people to develop products that rely, let's say, on Wi-Fi, and therefore they can sell it in the open market. You have producer surplus, which is the reason why, in some cases, an enterprise that relies on Wi-Fi doesn't have to spend money in terms of purchasing wireless broadband plans, because it's essentially free. And consumer benefit in the sense that sometimes it generates value to consumers. The interesting thing about consumer benefit or consumer surplus is that you don't see that value in the national accounts, because that's the value that we derive ourselves by getting access to Wi-Fi. I'm going to talk a little bit more about that. And if you look at the sources of value, the way we approach it in our methodologies, we look at these 5 areas. Sometimes Wi-Fi is the enabler to provide wireless internet access for free, either because we're going to a Starbucks or a government facility or a hospital or a university. And therefore, I access the internet and I don't have to pay for a wireless plan. Secondly, residential Wi-Fi. Residential Wi-Fi is very important insofar that it allows us to provide all the connectivity of devices that are within the household to be connected and therefore finally access whoever is providing the access for broadband internet to the household. Those are the printers, the laptops, the TV set, and the like. Enterprise Wi-Fi, as I mentioned before, is a reduction of telecommunications costs for the corporation. ISPs, insofar that they are a portion of wireless service providers or the internet service providers that rely on Wi-Fi to offer service, the well-known WISPs. And finally, you have a whole range of ecosystems, manufacturing of devices that are being produced that rely on Wi-Fi, going from speakers, wireless speakers, to alarm systems, and the like, that are generating a margin, are generating a profit for corporations that are manufacturing those. So what we do is essentially we look at these 5 sources of value and we try to estimate, well, how much value is being generated by those 5 and what is that having in terms of an impact on the 3 categories: GDP, producer surplus, and consumer surplus or consumer benefit. And in terms of the sources, and pretty much along the lines of what I explained before, we have the benefits to consumers by having Wi-Fi hotspots. On residential is the economic impact for accessing all those devices within the household without having a congestion. The enterprise, the WISPs, and finally the ecosystem. I'm not going to belabor the point because I already explained them in my prior slide. Let's talk about the first. Let's talk about the wireless ISPs. Why is Wi-Fi important? Essentially what you see here is conventional architecture of a wireless ISP, and what you see is that you have pretty much access points that are linked by a point-to-point infrastructure, and finally linking to the internet. If you assign 6 gigahertz band to a wireless ISP, what you're doing is you improving the point-to-point connectivity. You're improving the number of users that can access each of the access points. So essentially what you're having here is a way of increasing the performance of that wireless ISP in order to serve more consumers. And think about it, in India, for instance, by our count, there are roughly 830,000 connections that are served by wireless ISPs. So if you assign to them the ability to rely on the 6 gigahertz band to improve their performance, you're increasing that ability, you're increasing the number of users. My next slide is somewhat complicated, but essentially depicts the way we've approached every single area of impact in our report, in our study. And basically what it says is that on the one hand, if I assign a 6 gigahertz band to a wireless ISP, the speed of access of each consumer improves by the fact that the number of channels are increasing, and therefore that has an impact on speed, because speed has a benefit to consumers. We're actually, our delay, our latency, our ability to access information is improving by having this additional spectrum. But in addition to that, and that's my lower side of the slide, is basically what you're doing is that you can improve affordability. Because if I go from 32 users per access point to 60 plus users per access point, by economies of scale in serving those consumers, I can keep my costs down, and therefore my affordability improves, and therefore I increase the number of users being served by wireless ISPs, which ultimately has an impact on the GDP. We've done a number of studies that show that the more connectivity you have on the internet, the higher the impact on the economy as a whole. My second effect. Typical household, I have pretty much a fixed line of some sort accessing the household, a modem, and a router enabling the connectivity for a number of devices that go within the household. What happens is essentially that router, if that router has only access to 2.4 and 5 megahertz bands, there's a limit as to how much quality of service can be delivered to each of the devices. In fact, what occurs is that by having only 2 bands in that router, what we have is a congestion point. So when I'm increasing the speed of lines that are getting to my home, if I don't increase the amount of spectrum that router is handling, I'm going to have a bottleneck effect, a congestion effect. Now, what is that threshold? 150 megabits per second per line. If my speed of line increases by, let's say, 200, 300, and the like, and I don't increase the amount of spectrum that router has, then my quality of service diminishes. And in fact, what happens is I might be paying for a 200 megabit line, but in fact, what I receive at the device level could be 100 at best. So that says that if I need my 6 gigahertz band to eliminate that congestion effect. Now you might say, well, how important is this in India? Well, in fact, it is important, because if I look at the percent of lines that are in excess of 150 megabits per second, is increasing. In fact, while India is a little bit lagged relative to what is occurring in other countries like, let's say, Brazil, obviously the United States, but you see, when you extrapolate the trend that is occurring in terms of the number of lines, that's moving. We project that by 2030, for instance, close to 25% of lines in India is going to be in excess of 150 megabits per second. So this congestion is real. It actually exists. And that affects the mean speed that occurs at the download level for fixed broadband. You can see the 2 scenarios. If I don't have the 6 gigahertz and I have a congestion, that's the yellow line. If I have the 6 gigahertz, obviously it keeps on increasing. So this is critical. This is real, and it has an impact on quality of service, but not only on quality of service in terms of us being happier by getting a faster line. The quality of service in terms of the applications that we might have access to that require higher speeds at the device level. It is our sense that, in addition to this, what I focused before, is that Wi-Fi is becoming a critical component of access networks, of telecommunications networks as a whole. And what you see here is a distinction that is very important to retain, which we call the consumer-initiated offload and the carrier-initiating offload. And in those two areas, Wi-Fi is becoming increasingly important. Now, let me tell you a little bit about this. When I have the consumer-initiated, user-initiated, this is the syndrome where when we get home, we immediately switch our smartphones to Wi-Fi because we don't want to spend money on a wireless plan. Well, essentially right now, for conservative purposes, we've assumed in India that 30% of our traffic in a smartphone is going through a Wi-Fi network. And we stay there. We believe it's conservative because, in fact, there's some data that indicates that these could be reaching 50%. And by the way, there was just an open signal study published in the United States that shows that in the United States, that percent is 85. 85% of our smartphone access goes through a Wi-Fi signal, consumer-initiated. That's our own behavior. That's why Wi-Fi is important, but not only at the level of consumers, but also on the carrier initiating. This is how much carriers are relying on Wi-Fi to reduce the amount of spending, the amount of CapEx, while traffic is growing. You know by now that traffic is growing at 30% per annum. Everyone knows that. So how do I hold that? How do I control my CapEx spending? Well, Wi-Fi is becoming important. Now, again, conservatively, we assume that in India, that carrier-initiated offloading is 8% of traffic, which we believe is reasonable, except that we are getting some indications from some carriers that could be much higher. That is roughly around 65%. Again, these might be too high, but since we stay within the 8%, the numbers that I'm going to provide you stay within the range of reasonability. But this could be higher. So this is what I'm saying, that telecommunications networks have to consider Wi-Fi as being a critical component on what is going on in terms of either user-initiated or carrier-initiated. 5 minutes. We sort of like stipulated 3 scenarios to ascertain the effect of Wi-Fi in India. The first one is whether we were to allocate the entire band, the 1200 megahertz to of the 6 gigahertz band to Wi-Fi. The second alternative is to just stay within what's being used and desired by many countries, which is just 500 megahertz, the remaining 700 megahertz to the mobile operators. And the third case, which is 1100 megahertz for Wi-Fi and only 100 to the IMT, to the wireless service providers. And we calculated the economic impact of those 3. How do we do that? By going through all these range of effects and looking and developing models for each of the areas and coming up with a total value on the 3 categories that I was mentioning before. And these are the numbers for the first case, the 1200 megahertz. And what you see here is pretty important numbers because we're talking about 328 billion in terms of consumer surplus, 157 on producer, and GDP impact of 3.5 billion. Again, these numbers are derived, and you can see it in the detailed report, are calculated for each of the areas that I'm mentioning before that are being considered. Next, we move to the next case, and that is, let's just go for 500 megahertz for Wi-Fi, the remaining to the service providers. And here what we see is that basically what we have is, we have a haircut in the amount of spectrum that Wi-Fi receives, which in turn has an impact on its ability to fulfill the benefits that we had quantified before. For instance, in terms of free Wi-Fi, we have a negative impact of 41%. 41% of the effect in terms of the users that would benefit from Wi-Fi cannot benefit from them. And so on and so forth. It happens with residential Wi-Fis. It happens, for instance, on the impact on Internet of Things. 30% of Internet of Things sensors are supported by Wi-Fi. If I give them less spectrum, there's a limit as to how much sensors I would be able to deploy for an enterprise, and therefore that has an impact ultimately on GDP. And with, again, the numbers calculated, and the areas that are highlighted in sort of like a yellowish are those where we see an impact, a negative impact by assigning only 500 megahertz, with a total reduction of the $1.1 billion. So if we had, you remember, around $3-4 billion, we get a pretty substantial haircut if we were to go for only 500 megahertz. And now, to be fair, we needed to compensate this by saying, well, the IMT providers are getting 700 megahertz, and therefore they're going to generate some value. Otherwise, we wouldn't be comparing apples to apples. So we had to quantify how much the internet service providers are going to generate by receiving 700 megahertz. And we relied on data from the GSMA. We stipulated what the value would be for India, not only in terms of the value they are generating on the applications that I mentioned before, but how much the Treasury would benefit by the money, receiving from the auction itself. So again, we use that value to increase the total economic value of going 500 megahertz for Wi-Fi and 700 for the IMT. I'm going to wrap up. In my final case, which is just 100 megahertz for the IMT, and what you see is the decline is not that important, but nevertheless, there's some decline in terms of the aggregate economic value. And this is the bottom line. The bottom line and my conclusion is that, as you see, if I were to go for the full assignment of the 6 gigahertz band to Wi-Fi, the total value would be $4 billion. If we were to go for the conventional way of assigning the spectrum, which is 700 to the mobile industry and 500 for the Wi-Fi sector, I get an erosion to $3.1 billion. Obviously, if I were to the one that is a little bit in the middle of the road, I get less of a negative impact in the aggregate. But clearly, when decisions are being made, you've got to look at these numbers. You've got to look into the assumptions and the studies that validate which way to go. And by the way, these are not abstract because, just as a concluding statement, what you see, for instance, in cases such as the United States that make this decision of the 1,200 megahertz in 2020, you can see already the value that was generated. Therefore, we have somewhat of a before and after impact that would support, that would substantiate a decision of going for the entire band for Wi-Fi. Thank you very much.
Thank you, Professor Cards, for sharing your expertise and gracing all of us with your presence today. Ladies and gentlemen, we extend our heartfelt gratitude to our next speaker for taking the time out and being with us today. He is going to talk about the role of APT in preparatory activities for WRCs. Mr. Forhadul Parvez, Program Officer, APT, Bangkok, Thailand. Ladies and gentlemen, he has extensive experience coordinating regional preparations for major ITU conferences and developing common proposals. He has also contributed to APT's wireless group, SAT-RC action plans, and APT frequency information system. Mr. Parvez holds a master's degree in telecommunication engineering from AIT Finland and a bachelor's degree in electrical and electronic engineering from Bangladesh. Ladies and gentlemen, please welcome Mr. Parvez. Sir.
Thank you, Madam MC. And first of all, good morning to you all. Thanks to ITU-APT Foundation of India for inviting APT in this fourth Spectrum Management Conference. Before I start, I'd like to mention two things here. First of all, if you look at the ITU-APT Foundation of India, the name, whenever they have any event, actually, we are having our advertisement. I think Mr. Mario will agree that whenever they have their event, ITU and APT as an organization is advertised. So that is one thing. And then the second thing, whenever you come to an ITU-APT Foundation event, you can see a lot of ITS experts, so former and the current experts. So that is a good opportunity as well. So every time I come to any event of ITU-APT Foundation of India, I like to meet all those former and current ITS experts and professionals. So it's actually a good opportunity to meet all of them. And actually, they are very much professional and experts in their areas. So today, in 10 minutes' time, I would like to introduce to you how, as organization, APT are involved in the process of the preparation of WRCs and how you can contribute to the work of that preparatory activities for WRCs. Next slide, please. Okay, thank you. So APT as an intergovernmental organization in the Asia-Pacific region, we do have many activities. One of the main activities is the preparation for the ITU conferences and assemblies. So APG, which is the APT Conference Preparatory Group for WRCs, is one of the largest work program and popular work program of APT. Basically, it is attended by about sometimes 900 participants. So as you know, last time when we had the final preparatory meeting for WRC 23, we do have over 900 delegates registered for that meeting. So it is becoming like a mini conference. And then we do have a lot of varieties in the region, as you know, starting from Iran, from the west side, and on the east side, if you go New Zealand or Cook Island, then the varieties of the proposals from different, and the needs of the proposal from different countries are quite different. So we do organize kind of mini conference before the WRCs. So when you talk about the WRC, two things we need to always remember in our memory. First of all, as you see in the slide, WRC is an administrative conference, so access to the conference are limited. The administrations can submit their proposal to the WRC directly. So no other way. Other than that, the conference has given some flexibility to some of the regional organizations to put the coordinated common proposals. So those 6 organizations, as you can see, APT, ATU, CPT, CETL, ASMG, and RCC. So these 6 organizations are the only 6 organizations that are actually allowed to submit coordinated common proposals with the signatory from the member countries. And this is actually an interesting figure to remember when you talk about the whole preparation of WRC, especially how the whole process oriented. So let me explain about 1 minute about this one. As you can see, the center is the WRC, and then it does receive proposals from the members. And then the agenda of an WRC, as you know, are decided by the previous WRCs. So suppose the agenda of WRC 27 has been decided by WRC 23 and has been confirmed by the council itself. So, and then when the WRC is completed, we did have the CPM, first session of the CPM, where they discuss about take into note those agenda items, and then they distribute the work for the preparation to different study groups of ITU-R. And then the study groups will continue their studies for 2.5 years, and then they will create their outcomes in the draft CPM report, which goes to the CPM second session before WRC. And then after finishing the CPM, then the members normally submit the common proposals or the proposals to the WRC. So that process actually pretty much a standard process for all the ITU members and the organizations. So when we do the preparatory process for WRC in APT, we need to keep in mind this cycle of flow. And then we need to organize meetings based on these flow, such as after the CPM 1, we do need to start our preparatory process. During the process of studies 2.5 years, we do need to organize some APT preparatory meetings. Then before CPM 2, we need to organize the preparatory meeting, and before WRC, we need to organize the preparatory meetings. So as I was mentioning, basically the mandate for the regional organizations are given in WRC resolution number 72, where those 6 organizations are involved in the process of the preparation of WRCs. So I put it in the slide, but I am not going to discuss what are the resolutions, what are resolved in the resolution 72, but you can have a look at that actually give the mandate to the regional organization for the preparation. In case of APG, the APT Preparatory Group for WRC, we established in 1996 with the objective of harmonizing the views on developing common proposal of the Asia-Pacific region in WRCs. The first ever meeting was held in 1997 in Bangkok, and for the preparation of WRC 97. And many of you know that the chair of this APG during the establishment time was Mr. R.N. Agarwal, who chaired APG until WRC 07. After that, we had a new chair and other chairs. So the main objective, as I was talking, that APG is to organize the coordinated regional activities for WRCs and as well as RA. So in that process also we do preparation for CPM and other related activities which are WRC related. So thus you can see our terms of reference that we do cover WRC activities, RA activities, and other related tasks. In terms of the office bearers of APG, we do have a responsible chairman. Then we do have 2 vice chairs support the chair. And then also we do have a steering committee and a chair of editorial committee. And then we do have the working parties. So every working party will have a chair or co-chairs sometimes. And then we do have the drafting groups on each agenda items. So these are the basic structure of the APG, that plenary consists of chair and 2 vice chair and the editorial chair of the editorial committee. Then we do have working parties, and under the working parties we do have drafting groups. In terms of the meetings, APG is having 2 types of meeting, the regular meetings of APG and the coordinated meeting. Regular meetings, actually in a cycle we do have about 5 or 6 meetings where we do organize in different countries. And then normally the meetings are varying from 5 to 7 working days depending on the workload of the preparation. And the other type of meeting we have is the coordination meeting, which normally we do organize during the WRCs and RA. So normally in the lunchtime or in the morning of the working days, so we do organize the coordination meetings to discuss the progress and look at the current stance on different agenda items and take a new approach to harmonize the views. So this is the general schedule of the APG meetings. As I was mentioning, we do have 5 or 6 depending on the situation. I think we have some typo here. It's supposed to be APG 3. So first of all, first meeting, normally as I was mentioning, we do establish the group itself. The second and third meeting, basically we do consider the recent progress of the studies in the working parties of ITUR. And then after finishing that one, when the draft CPM report is ready, we do organize the 4th meeting just before the CPM, 1 month before CPM. And then after the CPM is finished and the final CPM report is available, then before conference, about 5 to 6 months before the conference, so we do organize the final prep meeting, because we need to take into account the submission deadline to the conference. So, and then also we need to circulate the proposals for the voting to the APT members. So that's why we need to organize it at least 3 to 6 months before the conference. In terms of the structure, we do follow the CPM structure. We do have, as I was mentioning, we do have the plenary, and then we establish the working parties. The working parties are equivalent to the CPM chapters. And then under the working parties, we do have these the drafting groups. If you look at the current structure, the preparation for WRC 27, we just started this year in June. We had the first meeting for WRC 27 preparation. In that meeting, we were able to select the chair of the group, Mr. Nobuyuki Kawai from Japan. He is the new chair of APG 27. And I think many of you know him very well. He is a satellite expert and then chair of Working Party 4C, I guess, correct? Yeah. And in terms of the vice chair, as you can see, actually, this time very special cases. We have 2 positions and 4 candidates, so we have not been able to finalize the vice chair of APG 27. So next meeting, we plan to have the vice chair. In terms of the chair of the editorial committee, it's same situation. So that's the negotiation is going on among the administrations. Secretary General is conducting that negotiation. And then maybe by the next meeting, we will be able to finalize those vacant positions. As I was mentioning, we do follow the similar structure of CPM. So we have 5 working parties. Working Party 1 related to the fixed satellite and broadcasting satellite issues. Working Party 2 fixed mobile and radio location issues. Working Party 3 mobile satellite issues. Working Party 4 science, and then Working Party 5 general issues and future agenda items. In terms of the Working Party chairs, this time, as I was mentioning, that we do have a lot of interests. So even though normally we prefer to have only 1 chair for the working parties, but this time, because of the interest from the members, we did have a number co-chairs in number of working parties. So as you can see, Working Party 1, Madam Cheng Feng Hong, and then Mr. Patanaik. Working Party 2, Mr. Yamata and Mr. Long. In Working Party 3, Dr. Meditamo and Dr. Desabo. Working Party 4, Dr. Hasbi, and then Working Party 5, Dr. Lim. So we do have these chairs and co-chairs for the working parties for this cycle. And I think many of you know them, but they are expert in their relevant areas. In terms of the general schedule, as you can see, we did have the APG first meeting already in June. We are planning to have our second meeting in June, July next year. Yet venue has not yet been decided. APG 27-3, it will be in June, July 2026. It will be in Japan. APG 27-4 before CPM, depending on the date of the CPM. We do have in February or March 2027. And then APG 5th will be in July, August 2027. And then those 2 meetings will be held depending on the situation, either Australia or Korea, so we may switch it. So as you see that we do have host for APG 27-345, still a second one has not yet been decided. So we are approaching some administration. Hopefully we can have it in India as well. So the important part here is this one, the process of developing the common proposals. First of all, as I was mentioning, that we follow the 2-stage process for developing APT common proposals. The stage number 1 is that we do receive proposals from the administration, so working party considered those in the meeting, the regular meetings, and then they develop the preliminary APT common proposals. And then we do work based on the consensus. So the meeting need to agree those kind of preliminary APT common proposals. After the meeting agree to that those proposals, PACPs, then we do circulate it to the all APT members. We do have 38 APT members. We need to circulate those proposals, each of the proposals, to the administrations for voting. So they need to say either yes or no. And then we do count after, we give 6 weeks time for those kind of voting or endorsement. And after that, we do count those votings. So a proposal can be an ACP if it is supported by at least 25 of the members. So if we do have 38 members, so it has to be agreed at least by 10 APT members. And then it's not opposed by the 50% of those who supported it. So the two conditions has to meet, that 10 members at least need to support it, and then it is not opposed by the 50%. So 50%, if suppose a proposal is agreed by the 10 members and opposed by 6 members, then it cannot be. So the opposition need to be less than 50% of who support it. Correct? So that need to be understood, that this is the strict condition for becoming an ACP. In terms of the participation, APT members, affiliate members, associate members, and then international organizations and regional organizations are open to participate in any APT activities, in APT meetings. Online registration is mandatory. And then nowadays we are having in-person and the virtual attendance. But in future, maybe, yeah, virtual attendance could be limited only for once listening, the streaming only, but not to participate or make intervention. Yep. And then you can go to our website. All details are provided there. And then organized, as I said, APG coordination meetings are organized only in physical mode. We don't organize it in virtual mode. In terms of the submission of the contribution, please note that you have to submit your contribution at least 10 calendar days before the start of the meeting. And then being an administrative conference, the submission is open by the administration only, the affiliate members and the associate members. They can submit contributions if it is endorsed by the administration or as an information document only. So our information, so all details are available in the OPT website, so you can have a look at the website to get all this information. And then, as I was mentioning, APG always work on the consensus basis, so that makes everyone equally unhappy. Thank you very much.
Thank you very much, Mr. Parvez, for sharing your expert views with us. Ladies and gentlemen, we are truly privileged to have with us our next speaker, Mr. Hiko Ross, Director Sales and Marketing, LS Telecom. Ladies and gentlemen, he's a business administration graduate from Northeastern University. Started his career at LS Telecom in 1997. He has held various roles within the company, including product manager, regional sales manager, and now leads global marketing and sales operations. Mr. Ross is a recognized expert in radio communications and spectrum management. Please join your hands and welcome Mr. Ross for a special presentation on tools for spectrum planning and coordination. Welcome, sir.
Okay. Good. Well, first of all, a very warm welcome and a good morning, everyone, to this fourth Indian Spectrum Management Conference. For those of you that were here yesterday, including myself, it was quite interesting to see what the WRC 23, 27, what kind of impact it has on India, but not just on India, on Indian telecommunications market. Also the discussion afterwards about the roadmap towards 6G, and we saw the different stakeholders, you know, their interests, and also, you know, sort of a fight for spectrum. And when you look at all of this, you know, WRC, when you look at spectrum roadmaps and so on, you also need to have tools. You need to have tools, especially with the regulators, that are responsible to allocate, to plan spectrum, and that's in the end exactly what we do. Nowadays, and that's maybe also something that's quite interesting, when you look at spectrum management, you primarily think about regulators, but believe it or not, what we see nowadays is that more and more also Ministry of Defense, that they also apply spectrum management within their operations, because they're obviously having a large chunk of the spectrum, and even more so on a micro level, we see in more and more, especially in Germany, companies that are doing spectrum management for their operations on their premises, on their sites. So spectrum management actually receives a wider application than it used to have in the past. Now, my name is Heiko Ross. Just one sentence about us. I'm from LS Telkom, German company. What we do is we do exactly spectrum. We provide spectrum management systems and radio monitoring systems to regulators. We do that all over the world. And just recently, we also opened up our office in India. That is, by the way, also a gold sponsor of this event. Next slide, please. Good. So, yeah, why has spectrum planning and coordination become so important? If you look at these, if you look at that slide, I think it nicely, actually, well, that's okay. If you look at that, there's one spectrum plan from 1975, and the one below is from 2020, but you could also put one there from 2024, and you can nicely see how spectrum plans, allocation plans, how it changed. You know, back then in the 70s and 80s, there was lots of space. Of course, yes, there's some planning needed to be done. But if you look at the spectrum allocation plans, spectrum plans of today, you can see it is congested, it is tight, it is full. And because of that, it's so important that you proactively plan and manage your spectrum. Otherwise, you will run into trouble. Next slide. Now, we've talked about some of that already. So, you know, radio spectrum is a scarce resource. Yeah, we all know that. Demand is greater than available supply. Yes. Important, I think, is also to understand that over the last decades, but also years, that demand originates not just from the traditional stakeholders, but we see also additional new stakeholders. We have, of course, the MNOs, you have the commercial operators, you have critical communications, also mentioned yesterday in one of the presentations. You have defense still having a good chunk of the radio spectrum nowadays because of the political situation, even demanding more here and there. But you also have, and there was a presentation later on by Alexander Kühne, we have private networks that are also finding its way, and they are also demanding spectrum. And so all of that, you know, shows you that this spectrum is really a precious resource. Talked about also this already, you know, radio spectrum being a key enabler. I mean, we are, you know, if we don't have any spectrum, you know, all the benefits that we have from nowadays to communications would obviously not be there, neither for of today's, but also of tomorrow's society. And, you know, we must not just address a radio spectrum from a technical perspective. Radio spectrum, it was mentioned a couple of times already, also has an economic value. And believe it or not, you know, we have customers where the revenue that is generated in the country by licensing spectrum is the second highest revenue for a government. So that just shows you how much value there is with the radio spectrum. Yeah, so therefore, yes, we need spectrum planning, we need spectrum coordination tools, not just for the coordination and planning, but also for the overall spectrum management to ensure, yes, an optimal use of the finite radio frequency spectrum while minimizing interference. So there's definitely a need for that. Looking you know, a little bit at this from a historical perspective, yesterday there was also a slide about 1G, 2G, 3G, 4G, 3G, 4G, 5G, and 6G. Well, you know, when you look at spectrum management tools and spectrum management system, there was also an evolution. I remember when I started with LS Telkom in the 90s, you know, there were the first organizations that started to apply planning tools, you know, real planning tools. And so that also had to do with the introduction of computers, PCs, and so on. Then around 2000, it was obvious that it was not, it's not just technical planning tools that are needed, but, there were also administrative processes like the application processing, the license processing, invoicing, field degree, and all of those things that also needed to be integrated. And so this integration of business started also based and going along with the introduction of networks within the organization. So IT again played an important role. Then again, 10 years later, those processes that were established, organizations started to automate processes. Automate process by applying, professional workflow engines and so on. So again, it had to do with servers and all of these things, but another important step. And then around 2020, before, some countries for sure before, but we saw more and more of those of regulators supporting e-government strategies by offering online portals. It was also mentioned earlier, I think it was the first presentation where it said an end-to-end process by WPC offering an online portal. Yes, that has been happening since then, that there are possibilities to basically offer applicants to start the application process online and going beyond. And now what we see today, and this is new now, we see that AI starts to have an impact on this. And I will talk a little bit about that in a few minutes. I guess just one sentence about that. When we talk about spectrum management and we talk about starting from receiving an application until a regulator actually issues a license, there are huge, complex and processes behind it. And that's sometimes a little bit underestimated. But there is a process behind it that really involves different people, different departments, and that's really something that's a challenge that is not that must not be underestimated. Next slide. Good. What are the requirements today nowadays for tools for spectrum management systems? Of course, there's still the need for technical planning tools, technical coordination tools, and the first thing that these sort of tools need to be compliant with, they need to be compliant with international regulations. The ITU radio regulation provides the global framework for every regulator there is. Then, of course, if you go on a country level, you have national frequency allocation tables. National frequency allocation tables are the tables that used to be as a poster in everyone's office at a regulator. Nowadays, they're digitized in such systems, and only frequencies that are allocated to a certain spectrum band may then also be assigned to an applicant that's requesting the frequency for that band. Then, yes, we also talked yesterday about WRC 27 and what space communication satellites will have an impact or does have an impact on it. 80% I think is on the space communications. So these sort of tools, they also need to not just apply, broadcasting mobiles and so on, but these tools also need to be able to apply, to basically consider all the radio communications that a regulator needs to deal with. Propagation modeling, nothing I think I need to mention here. And then, of course, these tools need to be able to do technical analysis, not just coverage analysis, but also interference analysis and beyond. So these technical tools do form an important part of today's regulators. Now, I mentioned it before, integration of processes. When you look at an organization like WPC, and the presentation that we saw earlier this morning, the first presentation I think it was just like a draft or a template for my presentation, because it nicely shows actually what we do, but we provide system and tools to support those processes. And those processes at WPC, for example, those include monitoring, it was mentioned, it includes licensing, it includes spectrum planning, it includes even, invoicing. And so all these things, they need to be integrated within an organization. But then you have also other national stakeholders, again, MOD, public safety, and so on. They also want to be included in those processes. So these systems also need to provide access to external stakeholders to provide their input. And then, of course, you have international You have the ITU, for example, with whom you need to notify data with when it comes to satellite communications, for example. But you may also have regional treaties, regional agreements that request you to coordinate across your across the border. And these are things that will need to be considered in such business processes and need to be integrated. I mentioned it also, automation of business processes. When you look at these processes, until 2020 or 2010, they were all done manually, step by step. But what you want to be able to is you want to be able to guide your staff. We want to be able to provide tools such that processes are automated. And for that, there are nowadays professional workflow engines available, and all these processes that you have been following within the organizations, they are nowadays standardized, digitized, and enable then their staff to basically consistently follow certain application and licensing processes. Very important. And in the end, these sort of systems also then document the processes, which helps that if you want to trace back, for example, certain steps, and which is sometimes important. E-government, certainly something that's still a hot topic, and the need for government institutions to follow these e-government initiatives. Also for regulators, you want to make sure that you provide, for example, frequency allocation tables on the net. You want to make sure that you allow applicants to start the application process online, providing templates. You want licensees to access their information online, a little bit like Amazon, manage your own data, manage your own account. You want to see where an application currently is. You want to see how much I have to pay. You want to see how much I already paid. So all these things will need to be reflected by such systems or by such tools, such that e-licensing, online payment, and things going beyond that are handled. And what we also see nowadays is that besides the traditional spectrum management processes that will need to be supported, we also see what we call non-spectrum applications that are more and more coming into the picture, whether it's equipment type approval, infrastructure licensing, numbering management. And since I heard yesterday that India applied to become a host of the Olympics in, I think, 2036, major special event planning is also something that's quite relevant. We've done that, with customers at both football World Cups and Olympic Games, to really huge events. And I can tell you what's happening there within a very short period. That's really amazing. Few sites, huge number of applications that will need to be processed within a very short time. Also a requirement, also really a challenge for a regulator once such an event comes to a country. And now looking forward a little bit, what we see is that in many countries, regulators do face the challenge of finding the right people, finding enough people, finding skilled people. So what they're looking is, automation, what they're looking at is integration, but now it goes to the point where, or let's start the other way around. Until recently, an application was started by an applicant, but once it was about the frequency assignment, it was still the staff of the regulator that actually did the assignment. Nowadays, what we see more and more is actually that we have calculation engines running in the cloud, such that an applicant, when he starts filling his data, as soon as he has filled in the location, as soon as he's filled in the radio service that he wants, that a calculation is done on the fly, and that the applicant itself can select frequencies from the frequency list of the regulator. So there's no longer even the involvement of the regulator for this. The applicant himself can do that. And that's, of course, something that I think will also change quite a bit. And it means basically outsourcing of tasks that so far have been done by regulatory staff are outsourced to the actual applicants. Something I think that's quite interesting. And now Two more slides about artificial intelligence. Artificial intelligence is something, you know, that we experience more and more in our everyday life, but it also has already found its impact within the regulators. We see it for administrative applications, for example, by having internal staff using chatbots, you know, to request to get information regarding ITU regulations, you know, domestic telecommunications acts and whatever. So there's, especially if you have new staff, you have unskilled staff, you can use those chatbots to really get them going right away. But we also have in the meantime chatbots for applicants, which allow then people who start an application process simply you know, ask you know, what kind of application do I need, the form, what does it cost me. It may even go to the point when an automated application filing is done. So this is already there, you know, this sort of artificial intelligence on an administrative level. But we are also working there to apply artificial intelligence more on a technical side, where we, for example, train propagation models such that they, with AI, with deep learning models, such that they can become smarter, better, quicker, and more accurate, which again helps then to get the best result when it comes to assigning frequencies. And currently, just to give you an idea, we're working on roughly 20, I would say, AI applications for regulators. I don't think all of those will survive, but if there are only 8 to 10 that will continuously being then used by regulators, I think that's already a big step forward. And with that, I would like to come to the conclusion, and yeah, efficient and effective spectrum planning and coordination has become important, and it will be even more important than ever, I believe, because of that crunch, because of that congestion, because of that density. Tools are needed, professional tools are needed to cover that whole process from, again, the beginning of an triggering an application until the point where you actually get the license. And I sincerely believe that what we are seeing currently with AI within the context of spectrum management, but also radio monitoring, is just the very beginning, and that AI has the potential to become a game changer in this whole ecosystem. With that, I'd like to thank you for your attention, and that's it.
Thank you, Mr. Ross, for enlightening all of us with your expertise. Ladies and gentlemen, may I now have a pleasure of inviting on stage our next speaker, Mr. Alexander Kuhn, BNetzA, Germany, and Chairman CPMW RC27. He'll be sharing his views on learnings from spectrum assignments for private networks in Germany. Please welcome Mr. Kuhn with a huge round of applause, ladies and gentlemen.
Thank you very much, and good morning, everybody. Just to be very clear, I'm speaking now on behalf of my capacity as the head of spectrum management in Germany. And it's my pleasure to introduce you to a little bit to our experiences, which we have with private networks in Germany and their specific spectrum use in 3.7, 3.8. You all know that we've started in Germany with some kind of experiment back in 2019 when we first started with making available spectrum also for private networks. We saw then that we have Wi-Fi at that point in time in 2.4 and 5 gigahertz, and of course for fixed connectivity and standard power, how it is called now in 6 gigahertz. In 5.8 we have also for fixed connectivity for Wi-Fi as well. But it was then also the question that all the companies, and with the development of 5G, ask for different quality of service of the networks. And then was the question, is the 3GPP specification only applicable to public mobile networks, or do we see maybe some other possibilities as well? And the companies, and in particular the German industry, demanded in that one that we would like to make use of some other spectrum as well, in particular for 5G, and that they would like to have their own networks because of security, control, and specific application issues in order to provide then really the necessity capacity in their companies and manufacturing environments in a different way. And that leads to our decision in order to promote efficient use of spectrum So 5G rollout, for example, innovation in particular there to see if 5G is able to really provide this, what it is expected by the industry. And also in terms of competition, you see then a competitive case between the industry of the private networks and the public networks as well, because they would like to see in this case network slicing, which was not available at this case. Therefore, the agency decided then back in 2019 to make available 100 megahertz in the 3.4, 3.8 harmonized band for 5G only for private networks. On a localized basis, that was one of the reasons and requirements, and that they can ask only for 100 megahertz or even less. So we decided then also regarding the fees that it will be some kind of administrative incentive pricing. If you need less spectrum, you pay less. If you need more geographical space on your own territory, then you have to pay more on that one. So overall, it was a very quite balanced system which has been implemented, and we implemented a similar thing also for 26 gigahertz in order to be here also open for further developments. What we've seen then as well is that we've seen immediately from the public mobile network operators that they're providing slicing spectrum also to those industries, but we've seen that the grow up in the networks, in particular on 5G, in 3.7 gigahertz was definitely remarkable from our side. We've received hundreds of applications in that, and we've seen that we have a growth between 10 to 30 licenses per month, which could be provided. And by the way, our system there for administrating that one is coming from LS Telkom to make some advertisement for our German company here. So overall, we have now over 400 licenses issued in that band, and everybody is happy right now. We see them, but we've seen then also and received then there are still caveats with the technology, and there is already then some kind of further development. So what is better? Do we have then really the possibility of Wi-Fi? Most likely then also in 6 gigahertz. Do we have the possibility of 5G due to low latency requirements? This requires, of course, spectrum management also on the low level technology in order to coordinate also with your neighbors. And we have established in our decision to make use of this 5G spectrum then also some kind of collision regulation. So everybody is required to coordinate with its neighbors. And of course, there should be no interaction with the public mobiles at that point in time. So we have also set up a rule for use it or lose it, and this has not been used right now. So everybody who has really asked or applied for a license and the license was granted was really able to build up a network within 1 year. So therefore the use it or lose it rule really make it happen that this rollout of 5G on the industrial basis was really a success story. On the other side, we see then maybe a difficulty in 26 because of the lack of equipment in there. We have issued right now only 25 licenses. And those are mostly for experiments and academia in order to make further development in that field, in the technology, but not in a more industrial environment. So the protection of other services was also one element from the spectrum management perspective. In particular, we saw that in C-band we have still some satellite usage, teleports, and of course monitoring stations in there. And therefore we were more than happy that we have provided these 100 megahertz on a local basis there as well, because this coordination with satellite in that band at that point in time definitely ensured also the satellite operation there. Up to now, we've then managed to move up in the spectrum to 3.8 and 4.2 gigahertz, and that opened up new possibilities as well. So what's next then, in order to not take too much of your precious time? I see that we are running a little bit out of that one. So next slide, please. We just had, and I can say this, we just had the ECC meeting this week regarding a decision on the harmonized conditions for the use of 3.8 to 4.2. So one of the elements also from our experience was we incentivized also other European countries think about what could be harmonized bands in the future, and 3.8, 4.2 provided here to be a good option, because the industry is always indoors. We can power limit them to a certain degree. So therefore it was then the request on the European level to make a harmonized band available for medium and low power networks on 5G technology. And the ECC just took yesterday then the decision that they are moving forward in that direction, and this will be most likely also then a European band which is then harmonized and mandatory within the European Union. We have as well then a mandate on the harmonization of the upper 6 gigahertz band, and you heard a lot of discussions around this as well. So Europe is definitely undertaking here some further studies, and I hope that we can conclude them very soon and that we can really work forward also within the ECC on a good way forward for the European market on the opening of the upper 6 gigahertz band as well, in order to balance the thing. And maybe that's one lesson we learned as well. If you be innovative on one part, so for 5G on 3.7, 3.8, that creates maybe on the other side a further spectrum demand on other things, and 6 gigahertz may be the caveat and the price for that, but we've done in 2019. That could be not the only point, but at least one point from our perspective. We have at least also in that one then incentivized discussions on Wi-Fi or for a former Y-gig in 60 gigahertz or 66 gigahertz. So therefore, we would like to see then also some further development there. If you look into the newer spectrum bands or higher spectrum bands, in particular 26, 40, and 60 gigahertz, there we definitely have the chance to see maybe some development as well. And that would open up maybe new opportunities also for all the other communities. We see there, and this is one part I would like to stress here as well from the regulatory perspective, the competition between different technologies has increased as well, which creates a lot of innovation, and it creates also opportunities for new business models. On the Wi-Fi side, we saw already that the unlicensed provides then at least the opportunity to dive into something, but also on the other sides of new bands, this creates then maybe new opportunities in the future as well, which can overcome then the scarcity of spectrum and may ease a little bit the situation which we have already in the shared of spectrum. And you saw in Heiko Ross' presentation how the spectrum is already shared between the different radio communication services. And if you look into one, and in particular the mobile service, you can really divide up this one in different applications as well. So what we do as well is we are, of course, working forward to further studies, in particular on UHF, maybe not very good for the PMSE industry, but you will hear about that later on, but also for further work in 7 gigahertz and 8 gigahertz, and we are very critical in that one in order to see that we can protect also here the incumbents, but also we see then in 1.13 of the WRC 27 agenda regarding direct-to-device, that this may create also other opportunities, maybe also for the industry, in order to have connectivity between their different manufacturing places. So we see that there is a buildup of maybe new communication, a new communication ecosystem that may come up in the future, and with this availability of spectrum, we can further increase the competition and then also the benefits for the society. Thank you very much for your attention.
Thank you very much, Mr. Kuhn, for sharing your valuable views with all of us. Ladies and gentlemen, today we are indeed honored to have amongst us an inspiring personalities as our chief guest. I extend a hearty welcome to Ms. Isabelle Moro, Director General, Global Satellite Operators Association. Ladies and gentlemen, she leads the organization in showcasing the benefits of satellite communications for a more inclusive and secure society. With 25 years of experience in the telecoms and technology sector, she has held leadership positions at GSMA and the World Economic Forum. Please welcome Ms. Moro with a huge hand. She'll be sharing her views on role of satellite networks in connecting the unconnected and ubiquitous connectivity. Welcome, ma'am.
Thank you, and good morning or good midday. I don't know where we are, but we've heard a lot this morning in the last 2 hours, very specifically about spectrum matters, and maybe I'm going to give you a helicopter view rather of satellite, the role of the satellite industry, and why spectrum is so crucial and becoming so important to us. I see Mario Manevich here from the ITU Bureau. We have, as we look at WRC 27, which we've heard so much about this morning, I think 80% of the agenda items of WRC 27 are going to be about space and satellites. So I think, we are at a sort of an inception point. Just to give you, who GSOA is, we are the Satellite Association, Global Satellite Association, representing all the satellite ecosystems. We have operators in LEO, MEO, and GEO, so in all orbits, vendors, manufacturers, launchers, and of course a lot of members as well from the ground segment of the industry. Over the last few years, the satellite industry has really experienced a very rapid evolution, and I think it's fair to say that it has evolved probably more rapidly in the last 5 years than it has between the last previous maybe 30 years or more. And it's really gone a very transformative growth during those last years, and this has been driven majorly by two key factors. One has been really unprecedented technological advancement and innovation, and on the other side, an increased demand for global connectivity and for data. And this innovation has been paired by incredible levels of investments. We've seen investment go from around $300 million in 2012 to nearing $10 billion in 2022, according to McKinsey. But this is also expected to be a sector that alone will bring socioeconomic benefits of around $250 billion according to a study that we did with LS Telcom last year. And we are expecting to double the number of citizens connected via satellite, by 2030. So if we look at today, what are the satellites up there in space? We have around 9,000 operational satellites in orbiting around the Earth. And they play a vital role in providing connectivity, but also in monitoring environmental changes. And this is really fundamental as we see the, sort of the climate change changing so dramatically. And also, of course, offering life-saving services during emergencies, which sadly, as we saw recently in Spain, is becoming more of a sort of day-to-day issue we have to deal with here. So satellite communications technology has long been at the forefront of global connectivity, providing critical services such as internet access, but also broadcast, television, and as I said, disaster relief communications. And this role will really continue to expand as we work to close the gender, economic, and of course, digital divides globally. So as mentioned, in the last few years, we've been seeing major innovations across not only LEOs, we hear a lot about low orbit, but also GEOs and MEOs, which have really fueled expansion in broadband all around the world. Also in Earth observation, and also most recently in IoT services. And this integration of systems as well, satellite systems with 5G and the promise of 6G and other innovations are really further revolutionizing the communications networks. A range of new innovative solutions in communications or SATCOMs, such as direct-to-device, multi-orbit networks, inter-satellite links, software-defined networks, and in-orbit servicing are making communications more versatile and more cost-effective when we look at satellite. And these innovations will drive more efficient, more secure, and scalable services. Additionally, we're seeing breakthroughs in Earth observation technology, which also play a crucial role, as I said, in environmental monitoring and disaster response. But looking at the future, I keep saying that, we have 2.6 billion people that are not connected around the world. If terrestrial solutions have been able to deliver ubiquitous, universal access, everybody would be covered. Equally, if satellite services had been able to provide connectivity to all, we would have done it by now. So we really believe that looking at the future, the optimal solution in achieving global connectivity lies in using the right mix of technologies. We need to pull the strengths of all our technologies. We've heard about Wi-Fi, we've heard about satellite, about mobile. You know, it's really pulling the strengths so that we can create economies of scale, we can reduce costs, and we can collectively deliver higher resilience and greater access. And here, the integration of non-terrestrial and terrestrial networks is really opening doors towards a real network of networks, where we can create a connected world where everyone, no matter where they are, have access to high-speed, reliable internet. And I'm glad to say, for those of you who have been at the Mobile World Congress this year in Barcelona, that to this aim, to increase and accelerate this integration, GSOA signed a cooperation agreement with GSMA and with the European Space Agency. So if we look at coverage, reliability, and ease of deployment, SATCOMs are really crucial, especially in remote and underserved and unserved regions. Whether it's connecting remote areas, supporting industries at sea or in the air, or providing backup for networks, satellite technology has really become central to enabling an inclusive society. But none of this, of course, none of this innovation can successfully be implemented unless we have the right policy and regulatory framework. We need transparent, flexible regulatory frameworks capable of adapting to the very rapid changes of the market and the rapid evolution of technology. And we need to ensure long-term access to spectrum for current and future spectrum satellite services. So looking specifically at India, where we're today, the Indian new space policy has made significant progress in streamlining and centralizing space activities. And it is crucial that we maintain adherence to these standardized procedures, as they provide the certainty that the industry needs for investment, for growth, and for innovation. In recent years, the ongoing discussions around spectrum allocation, pricing, and availability have unfortunately created some uncertainty and delayed service deployments. And we're seeing, for example, some of, trying to reopen the already closed debate on the C-band, for instance, by reconsidering the 37 and 3800 megahertz, probably for mobile, in an industry that is already in an oversupply of spectrum. So such relocation really could have a negative impact on a vibrant and critical satellite and broadcast industry in India. It is therefore really an imperative that we provide clarity and that we help the industry move forward with confidence. So to unlock the potential of convergence, of NTN and TN integration, regulation and legislation should remove barriers and red tapes and become champions of convergence solutions, harnessing the strengths of all communications technology. So therefore, when we look at really the right policy eco-framework, it needs to be really looking at addressing all sectors of the industry. So to conclude, I just want to say that in today's world, where we need increasingly performant, ubiquitous, reliable, and inclusive connectivity, satellite communications can really make all this happen, because we can reach areas that would otherwise not be covered. And for this reason, we need an ecosystem in spectrum that is really going to enable satellite communications to thrive, and that is going to be able to help us all around the world and to help India deliver on the promise of universal connectivity for all tomorrow. Thank you very much.
Thank you, ma'am. We are truly honored to have the opportunity to hear your worthy words. Ladies and gentlemen, as we come to the end of the inaugural session, I request Dr. Satya N. Gupta, Secretary General IAFI, to kindly conclude with his vote of thanks. So.
Yeah, Thank you. Good afternoon. First of all, it's a great pleasure and honor for me to propose the vote of thanks on behalf of our foundation, for which I'm really thankful to our executive. Let me start with our chief guest, Madam Isabel Mairo, the Director General of GSO, who has just delivered her words of wisdom, actually, the helicopter view of the high altitude satellites, actually, and she really brought out the importance of the satellite communication, which is, of course, well known, but especially for the rural and remote area, to bridge the digital divide, and also for the disaster management, actually, requirement of which are there in our own country, actually, for that. And we are really thankful to you, Madam, for bringing out the new applications and also need for actually integration as well as recognizing the need of all the technologies, which include satellite also and Wi-Fi and the conventional telecom, terrestrial telecom, non-terrestrial telecom. Actually, mix and match of everything is required if you want the ubiquity of communication. Thanks a lot, Madam, for coming that far and sparing your time. And let me also take this opportunity to thank Mr. Alex B. Nadja from Germany, also bringing the various aspects of private networks. Actually, as you know, in the country, we are still struggling to find and allocate the spectrum for private networks. The debate is still there. But this example given by Mr. Alex, actually, in Germany, where it is really happening, actually, there have been a lot of harmonization, lot of allocation, and lot of success stories, actually, that comes a great learning for us, and especially the government decision maker, policy maker, and spectrum managers to take a clue from their best practices. Thanks a lot, Mr. Alex. Thank you, Mr. Hiko Rose, also for LS Telecom, for bringing artificial intelligence to the spectrum management, getting it automated, and also making it simpler. And not only simpler, actually, the great idea of outsourcing the spectrum and frequency allocation. In fact, more than that, your idea of that we as a user can allocate the frequency to ourselves, making use of the tools and artificial intelligence, a great thing. It can solve a lot of our problem in the country. We are also thankful to Mr. Parvez, our friend from APT, actually giving us all the process and all the organization and how we are collaborating and how there are more scope for participation there. Of course, Professor Raul Katz, I cannot thank you enough, actually. Your presentation on the economic aspect of digital technology and especially unlicensed spectrum, actually. It's a great thing, actually. You are the one who really, today you are actually basically an odd man out. Yesterday in a panel, it was other way around, of course. But the examples, empirical formulas, models, calculations, data, actually you have shown and you have found, you have given the options, actually. Actually, it is not either or. You can give your 6 gigahertz to every technology which makes best use of that, not only monetary but also solving the existing problem of digital divide as well as the high-speed broadband at the homes and feeding the Wi-Fi. And for the telcos also, you have really given that they are the more beneficiary through the producer, what you call producer gain, the consumer benefits, and also the main thing, the GDP contribution. Actually, that should be the benchmark by the government. They should see where the GDP growth is more, whether by unlicensing or by licensing. That, I think, can be a great learning from the professor. Thanks a lot, Professor. And Madam Revati, who is not there, actually, she really talked about this, showed us everything in a pictorial view, actually. As they say, picture is having 1,000 words, so everything became very clear, and her motto of clean and reusable spectrum, actually, that is what should have been happening. And we are really thankful to the madam also. And now I have to thank our chairman also, Dua Saab, who in the morning, he brought the great aspect of vital national resource. Till last day we are talking about scarce resource. Yes, it is scarce, but more than scarce, it is vital. Vital means it is needed everywhere actually, so it should be given to everyone, even if it is scarce. And actually with the technology, the type of technology we are talking, and yesterday dynamic spectrum allocation was talked about, Dr. Martha, and today also the professor's presentation, I think the scarcity can be handled through technology and everyone can be allocated. So that is what it came. And also thanks to our dynamic president, Bibi Saab actually, who has put it together and put it together here to get the best experts from all over the world. And I have to thank all of you, of course, and especially I have to thank Mr. Mario, the ITU-R director actually, who could spare their time, and for your presence, Dr. Mario. And we, of all of you, the whom we will call the right people actually, and the hall is of course full. Thank you very much. Thanks.
Thank you very much, Dr. Gupta. Ladies and gentlemen, on behalf of IAFI, I extend a hearty vote of thanks to all our esteemed dignitaries who spared time from their busiest schedules and joined us today. We really appreciate that. We have a small token of appreciation from IAFI. Please accept it from our behalf. Ladies and gentlemen, I request Mr. Bhatia to please present a memento to Ms. Isabelle Moro. Thank you, ma'am, for joining us today and gracing all of us. Thank you, Mr. Foradul Parvez. Can we have a huge round, ladies and gentlemen? I request Dr. Gupta to please do the honors of presenting a memento to Mr. Hiko Ross. Thank you, sir, for joining us today. And last but not the least, Professor Raul Cards. Thank you so much, sir, for the lovely presentation from your end. I thank everybody on the dais. May I request all the eminent speakers to please join for a group photograph. Thank you, everybody. Ladies and gentlemen, we are going to take a short break of 10 minutes. Please take your teas and coffees. I'll really appreciate if you all get your teas and coffees and snacks on the tables, because we're really running short of time. I would really like to start with the session 7 on spectrum issues in broadcasting, PMSE and other services in 10 minutes time. So really appreciate if you all get your teas and coffees back on the tables. Thank you very much. set of panel on the stage for a session on spectrum issues in broadcasting, PMSE and other services. Ladies and gentlemen, please join me in welcoming the session chair, Shri Viresh Goyal, Joint Wireless Advisor, WPC DOT. Welcome, sir. Mr. Goyal, an IRRS officer with over 28 years of experience in spectrum management and monitoring. He has worked in various capacities at WPC and WMO, contributing to projects like NRSMMS and attended many international meetings. Please put your hands together and welcome our speakers one after the other. Mr. Martin Broke, Senior Manager, Global Regulatory Policy, Shore Incorporated. Mr. Broke has more than 20 years of experience in operation and policy at UK regulator Ofcom, where he led the development of spectrum policy for program making and special events. He also served for several years as secretary to FMPT 51, the European Conference of Postal and Telecommunications Administration's project team for PMSE frequency management. Welcome, sir. Please put your hands together for Dr. Vinosh Babu James, Director, Technical Standards, Qualcomm. Welcome, sir. With over 15 years of experience in telecommunications, he focuses on radio standards, cellular systems design, and IP. He has held technical roles like chairman of 5G working group in TSDSI and is a senior member of IEEE. Please welcome Shri Rajiv Kumar, Director, Doordarshan. He has extensive experience in TV broadcasting and currently oversees spectrum management, ITU-R, ABU studies, and capital projects. Shri Kumar has contributed to national and international standards and policies, publishing papers on broadcasting and spectrum. He has represented India at ITU-R, WRCs, AIBD, and ABU. Welcome, sir. Ladies and gentlemen, please put your hands together and welcome Professor Yashwant Gupta, Distinguished Professor J and Center Director, NCRA TIFR. He obtained his MS and PhD degree in radio astronomy from UC San Diego. He served as a Dean of GMRT Observatory and Center Director. His research focuses on pulsars, the interstellar medium, and radio astronomy instrumentation. Ladies and gentlemen, I'll hand over this dais to our session chair, Shri Viresh Goyal. Sir, over to you.
Thank you, ma'am, for the brief introduction. And my senior officers from the Department of Telecom, Mr. Mario Morivich, Director BR, Mr. Kundo, Secretary General, ITU-APT, Shri B.B. Bhatia, President IAFI, Shri T.R. Dua, Chairman IAFI, industry delegates, foreign delegates, academia, ladies and gentlemen, thank you. First of all, I thank you IAFI for organizing such a fantastic event, a flag bearer event on the spectrum. They have put all the stakeholders on a platform to discuss and deliberate on the vital issues of the spectrum. Yesterday, we had the guidelines from Chairman TRAI, Member Technology, Member Services, and Wireless Advisor. Thereafter, we had got very engaging discussions and deliberations on WRC 27 preparations, spectrum roadmap for 4G, 5G, and 6G, planning of 6 gigahertz band, the hot topic, and spectrum pricing. In this session, we are going to discuss and deliberate upon the vital issues of spectrum in broadcasting, PMSE, and other services. So we have got distinguished speakers, subject experts, and we will request one by one to come up and give their talk for 10 to 12 minutes. If the time permits, and we will have a brief question-answer session. So first, I will request Mr. Martin Brook to present his talk.
It's always nice to see Sure equipment at the podium. Good afternoon. I'd like to thank IFI for inviting me to speak and your wonderful hospitality this week. I'm truly honoured to be here. Yesterday, my colleague Nada spoke about PMSE's enormous... sorry, can you move on the slide, please? Thank you. Yesterday, my colleague Nada spoke about PMSE's enormous socio-economic growth potential in India. Today, I'm going to make the case for including audio PMSE within India's spectrum regulatory framework so that India can harness that potential. Can you move on the slide, please? Thank you. It'll be Sure's 100th birthday next year, so I'd like to share with you a couple of documents held in our company archives, and their relevance will become apparent. The first, which is in the top right, the yellow document, is dated March 1947. It's from an engineering notebook in which Elmer Carlson sketched out an idea and circuit design for the first wireless microphone. The following month, another note from Ben Bauer, VP of Engineering, the note in blue down there, states, there are two things which concern us in connection with this matter. One is the patent situation, natural for a manufacturer to protect their intellectual property. The other is FCC regulations governing the operation of such devices. So even in 1947, Sure was thinking about radio spectrum regulation, and as an ex-regulator of 20 years, that gives me some comfort. Next slide, please. And we are still thinking about spectrum regulation, except now we're making audio PMSE's case for formal recognition within India's regulatory framework. Those efforts are bearing fruit, and we're delighted to see greater awareness of PMSE's socio-economic contribution to India and TRI's ambition to position India as a global content hub. If India is sincere in that ambition, it will need content. It will need spectrum for PMSE. And at this stage, I should draw the distinction between content creators, content distribution, and content consumption. They are not interchangeable terms. Yesterday, we also heard from several speakers about the importance of harmonisation, regulatory stability, and economies of scale. And it's no different for our industry. If you could just move forward, please. This was covered by Nada yesterday, so I won't spend too long here. PMSE is a defined term within the ITU-R terminology, and there was scale offered by the signatories in Region 1, for example, to Regulation Footnote 5.296. Just move forward. In addition to regulatory recognition, harmonised spectrum availability and harmonised standards have encouraged investment in the development of equipment. In combination, the result is a mature global equipment ecosystem for audio PMSE in the 470 to 694 megahertz band and 698 in India. I appreciate when I make reference to 694, it could equally be talking about 698. Forward, please. Thank you. And again, we heard already about, from several speakers about the announcement earlier this week, India formally entering the bid to host the 2036 Olympic Games. One more, thanks. The Olympic Games is the single biggest PMSE event on Earth, and you can see how important the core audio PMSE band of 470 to 694 is. The figures you can see on screen were produced by France's ANFR, their spectrum regulator, and show that 89% of audio links, which is over 12,000 individual audio PMSE channels used at this year's Paris Olympic Games, were within that core audio band. There's no other band that comes close. One more please, thank you. So recognition of audio PMSC is one thing, but how might it be authorised in India? The decision, I will stress, is one for India alone, but approaches adopted elsewhere in the world may prove useful. Audio PMSC is a low-power application that's been using the 470 to 694 megahertz band across Europe for decades. Most CPT administrations have adopted an unlicensed or license-exempt regulatory framework. Sorry, can you stick on that slide for me? Thank you. So, Germany's BNetzA, as Alexander will know well, moved to a general authorisation approach in 2020. Further afield, both the FCC and Canada's ISED permit both unlicensed and licensed operation of PMSC audio. But it's worth noting that in the US, some 94% of audio PMSC assignments are made under the unlicensed, which they call Part 15 Low Power Auxiliary Service, LPAS, unlicensed route. So for exceptionally large events, or for those of national significance, a greater degree of intervention is often required in the form of coordination to mitigate the risk of interference between PMSC users. So this could be undertaken by the regulator themselves or an appointed spectrum planner. One more. But authorisation does not have to be complex. And we've heard from Heiko Ross earlier from LS Telecom about some automation tools that are already available. I've included this slide. I was 20 years at the regulator in the UK, Ofcom, overseeing PMSC policy for a number of years, and it's an example of how the UK uses an automated self-service online booking tool, which accounts for broadcasting's use of the band as the primary service, and offers PMSC users visibility of spectrum availability at any time and any location. So it was a brief presentation, I hope on time, but just to wrap up, I'll make a final plea, which is that I ask you not to take PMSC or its spectrum requirements for granted. And of course, I wish India every success in its ambition to become a global content hub. Thank you for listening. Thank you.
Thank you. Thank you, Martin, for your insight on the PMSC and its requirement. Now I request Mr. Vinosh Babu from Qualcomm. He will talk on spectrum consideration for direct-to-device broadcast.
Good afternoon. Thank you, IFI, for getting me in here and then giving this opportunity to share our views on this broadcast spectrum and broadcast technology evolution. How do we actually have to plan it? So this concept is not new. So I mean, worldwide broadcast operators, they are actually migrating away from analog or old generation broadcast technology and going into new technologies. So for example, if you are taking Europe, it's a DVB nation. DVB T2 networks actually are in existence. There's a huge audience also for that. They are looking into their migration, right? And as a collective nation, they have already agreed that 5G broadcast will be their physical layer, on top of which DVB service layer will run, right? So that's sort of the approach they are taking. So if you see the screen, I have shown a mobile which is actually receiving broadcast content. And this was actually trialed during the Paris Olympic, which just concluded, right? So, so what exactly is this, and what exactly is the opportunity, right? And if you look into it, Bhattaji had nicely told that this is basically D2D, this is not D2M. Why exactly is that? Because the concept is not about getting broadcast delivered to your mobile. Because as of now, what is a mobile, what is a device, that is actually vanishing, right? So if you actually see the picture, your car dashboard, your iPad, your tablets, your mobile devices, even if you're talking about, emergency information which need to be displayed, everything is a device, right? Yes, it's actually getting powered by a mobile chipset or whatever in it, but it's all a device. So if you want to take broadcast content into those devices, then the question to be asked is, what is the most viable path, or what is the most affordable thing, right? I'll just step back a little in time. I'm actually seeing a lot of people who I'll consider advisors in here, including Duaji and others, who actually saw a generation where there was a fight between WiMAX and LTE. What exactly was that fight, and how did LTE actually survive? It actually survived because LTE evolved from what was there in 3G. It was a gradual evolution, and then the acceptance within the mobile community was high. So when a mobile OEM like Apple, Samsung, Xiaomi, or somebody wanted to implement it, they quickly thought that going the WiMAX way is going to be difficult, but going the cellular mobile way was easy for them. We are actually stuck in the same phase now, that there are conflicting technologies like DVB-T2, ATSC 3.0, or 5G broadcast. Common wisdom should tell that, hey, this is the most likely path we should go, right? And we are expecting wisdom to prevail, but in general, my position is to basically promote 5G broadcast as a technology. So what exactly is that technology, and what is the value proposition this 5G broadcast is actually bringing? The value proposition is you're basically reusing cellular hardware to enable broadcast. The very same way cellular technology was tuned to service IoT application, as in narrowband IoT or eMTC, or in automotive application, as in cellular V2X, or in other things like 3GPP technology is applicable for industrial automation and other related things. 5G broadcast is about leveraging the same silicon, same technology, to be operated in a downlink only mode, and then make it available for broadcast applications, right? And so why this and why not something else? So if you look into a country like India, today OTT is driving the market, right? So anything like a D2M or D2D is basically coming and trying to take away market share from it. So you may succeed, you may fail. Both possibilities exist. But what is the most gradual way for you to actually evolve is actually being in an accommodative mode, where it's like saying, okay, I will try to offload some of the content which is coming in OTT format, maybe like so many people are actually consuming, and then push it in this particular thing. So for that natural thing to happen, there should be a convergence of network in the broadcast and broadcast mode, and it should be seamless. 5G broadcast offers that path, and that's precisely the reason Europe is actually going that particular route. So these are like, the service aspects which are actually considered in the development of technology. So for example, if it is broadcast, it has to be seamless, it has to be receive-only mode, free-to-air content should be there, there should be service layer integration with multiple options. For example, DVB-I should be there, Dash should be there. If you are like an application provider, you should be able to ride a service on top of it, right? All those functionalities were actually taken by broadcasters to 3GPP, and they got it standardized. Right? It's not like the cellular industry drove that requirement. Broadcasters, specifically European and American, they took those requirement to 3GPP, got it standardized, fully realizing that that's the only way forward for me to enter into the mobile business. So again, it's not a European technology, it's not an American technology. The moment TEC adopted these standards into national standards, it became an Indian standard. Right? So the 5G broadcast which we are actually promoting is actually based on Indian standards. So in a very high-level summary, I wanted to discuss two things. One is, making D2M work in India, and then the second part is make D2M work for India. So this slide is on why and how to make D2M work in India. The way to make it work in India is to basically ensure a few things. One, you need to ensure seamless broadcast broadband convergence, which, because it's a 3GPP-based technology, it offers you naturally. It's standards-based, so what that will naturally mean is people will implement it, there will be ecosystem, so the moment they see an opportunity on top of it, similar to your Android or iOS experience, people will start writing application on top of it, like a DRM-based service. right? A Z or a Tata or somebody, they can actually start building application on top of it and then try to monetize, right? And then the moment you try to do it, you can actually bring in like other platforms on top of it. For example, if you are talking about emergency warning systems, it's a broadcast technology. You can leverage that, and then you can actually push in your emergency warning message, right? So it offers PPDR-like services, right? So the potential of leveraging a cellular technology to do a broadcast application is limitless, right? So that's what I meant by saying that making D2M work in India. How do you actually get it done, right? And then this is basically the product roadmap, right? So there is this nuance which is needed for me to conclude in the next slide on how to make it for India, right? So if you look into the European band, or to be more precise, what my previous speaker from Shure actually talked about, for them spectrum for broadcasting is 470 all the way up to 694. In India, that's not the case. Our spectrum actually stops at 582, right? So the European broadcasters have even more spectrum. So all the trials which is actually going on in there, using commercial grade devices, as you see in my screen, that 612 all the way up, it's still a European broadcast band. And in that particular band, we already have commercial devices from Xiaomi, OnePlus, Motorola, and one unknown person. Let's keep it that way for some more time. They are actually participating in those European trials, working with the EBU and other players in ensuring that they meet the timeline set of 2027 rollout of this technology, right? So that participation is already going on, and there is a committed roadmap in that part. So, hey, Qualcomm, what are you actually doing in India? What we are trying to do is, we are basically trying to leverage those commercial devices these OEMs are bringing in, tune it to work in the Indian UHF band, to be precisely, it is 526 to 582, which is actually what we are targeting. And we have what is called as reference devices. It's basically commercial grade devices, except that there is no OEM logo on top of it. We displayed that, we demonstrated that in the IMC. We actually went one step further. We told that, hey, getting a new device into a market like India, it's going to be very sensitive, right? So what do I do with my existing devices, all right? So to be more precise, there is an education program which is actually based on devices in India today, all those Wi-Fi based gadgets. So can you actually push broadcast content into them? So we went to the lab, we figured out that there is an Indian OEM called HFCL, who's manufacturing CPEs based out of India, which leverages the same chipset as we see in those devices. So we reworked with that, enabled that particular CPE to receive 5G broadcast, and then make the last mile available through Wi-Fi, which means all those devices which I'm using today will be able to receive this broadcast content, right? So we are actually making 5G broadcast work in India. But then it is still a topic for discussion. So what does it mean to make it work for India? And that is how this particular event comes in, because to make it work for India, there is a small nuance coming in originally through a TRI recommendation and then through a DOT guideline. DOT in 2021, based on 2022, I forget the year, what they basically put on notice is that spectrum in the range 526 to 582 will be considered for 5G and IMT services. There's a trick in here because originally it's a broadcast service brand where a broadcast service is anticipated to work. And then DOT is saying that we will actually use it for IMT, which is a IMT service or a mobile service. So here is a real catch. If we actually deploy a technology in that particular band, which is not compatible with mobile or cellular, that technology will then claim incumbent protection in that particular band. They'll be making it literally not available for IMT or mobile. Okay? So if 526 to 582 will have to become available for IMT in the future, then the only way that is going to be possible is to ensure that a technology which will be used in there is applicable to both the services. And when the service switch happens, if at all, right, the service switch will happen if broadcast is not viable, or it will stay in broadcast if IMT is not viable, right? I'm being neutral in here, right? Either service, whichever actually succeeds, will have to survive. But we don't know which is going to happen that today. And for that, we need to have a technology which is compatible. right? So if we have one recommendation which IFI will actually frame out of this particular conference, our recommendation is we capture this accordingly and then say that, at least in this particular band, to ensure that it is future ready, the technology needs to be compatible, right? With that, I will conclude my speech and then get back. Thank you.
Thank you, Vinoj, for giving us the 5G broadcast core features, possibility and roadmap for making D2M work in India and how we can proceed about it. Thank you, Mr. Vinoj. And now I request Rajiv Kumar, Director in Doordarshan. He will talk about spectrum needs for broadcast industry.
Thank you, Chair, and I thank IFI to provide me this opportunity, especially Bharat Bhatia ji and K.R. Dua ji, to speak in this conference, and which is very prestigious, and that is quite kind of respect to me to speak here. So, my topic is spectrum requirement for broadcasting industry, and I will try to make my point clear. What is the requirement of broadcasting spectrum in current situation? Mr. Vinoj had given a quite colorful idea why and how it is important to have terrestrial broadcasting and for spectrum for that. So I will like to introduce, as I am working in Doordarshan, which is part of our public broadcaster, Prasar Bharati, which has two arms, Doordarshan, which provides TV services, and Akashvani, which provides radio services. Doordarshan was established in 1959, and which is India's largest broadcasting organization. It has 36 TV channels, out of which 5 are in high definition mode. We have one DTH, that is Gigi Free Dish, which is in FTA mode, free to all, and no conditional access, which has 116 TV channels that include private channels as well, 36 Doordarshan channels and remaining private. And we have 48 radio channels of All India Radio also available on the platform. And we have an arrangement with another PSU to provide 302 educational channels under the umbrella of our DTH channel. In addition, recently we have started our service on South Asian satellite, which provides 50 educational channels through satellite to our neighboring countries in South Asia. Similarly, we have our subsidiary, that Akashvani, which was started well before the Doordarshan, and it has a motto of Bahujan Hitaya, Bahujan Sukhaya, which it is fulfilling since inception, and it is one of the largest organizations. It provides programming in 23 languages and 179 dialects. Now I want to come to the importance of broadcasting. That is reaching a wide audience. It can reach more people more quickly than any other medium. Informing the public. Public needs information on current affairs, politics, and social issues. Informed citizen is very essential for a healthy democracy. Educating the public, we can educate people about science, history, culture, and the arts. Educational programs can be especially important for the people who cannot have access to the formal education. This was evident during the COVID period, where no schools were running, and we provided quite satisfactory services to the people who could not attend kind of virtual classes or other things. Entertaining the public, that was the most important thing and most common thing when we provided music, drama, cartoon, movies. In that way, broadcasting sector is the cultural ambassador of the country and has given a unique identity to India. India's rich culture, heritage, and variable assets can be promoted and amplified by enhancing the broadcasting ecosystem. That is the bottom line. Again, further to expand the importance, the role of Prasar Bharati, which is public broadcaster of India, we have to provide a variety of programs catering to a wide range of interests, accessibility to all citizens regardless of their social and economic status. That we are fulfilling since our starting age. And importance of public broadcasting is very important to express here because we can express and encourage participation of citizens to participate in public life and to better understand themselves and the world around them. We aim to provide a space for all sides of an issue to be heard. You may recall that we provide opportunity to all the parties during the elections so that they can present their views, and that is our balanced coverage. Present accurate information that is unbiased and covering all the aspects of the information in an accurate manner, and covers underrepresented topics. That is very important, that many of the topics are not commercially viable, so commercial broadcasters do not provide that. And for example, agriculture sector. Doordarshan has DD Kisan, a dedicated channel for agriculture only. So we do that in our full capacity. Then I am coming to, I explained the importance of the broadcasting and public broadcasting so that I can express what is desired for broadcasting and what is the spectrum requirement for the broadcasting and why it is required. That I wanted to explain. TRAI has given recommendation to the Government of India for National Broadcast Policy. I want to mention some of the points mentioned there. Exploring the expansion of digital terrestrial broadcasting to television and mobile devices as a complementary broadcasting service to coexist with cable and satellite broadcasting. Enabling the delivery of TV content on mobile devices utilizing digital terrestrial broadcasting technologies, e.g. 5G broadcast, which Binesh Babu explained very correctly, and direct-to-mobile technology. Leveraging digital terrestrial broadcasting for uninterrupted service during emergencies. Now, that is very important and being highlighted by some of the issues at the global level. There were issues with the other kind of broadcast and rural disasters for public safety through television, radio, and mobile. Ensuring effective utilization of spectrum allocated for terrestrial broadcasting and earmarking globally harmonized spectrum for program making and special events, PMSE, that was brought out by our fellow speaker. Now, there are challenges for terrestrial broadcasting in UHF band. Historically, all television delivery was by terrestrial means. The delivery mechanism in place have evolved in subsequent decades. Use of spectrum is regulated by RR of ITU-R. The UHF band 470 to 694 megahertz is primarily and predominantly broadcasting band for terrestrial TV broadcasting across the world. I want to mention that in region 1, the band is allocated only to broadcasting service. How much important is broadcasting? That is very clear from this one. In region 2, only broadcasting service has primary status. And in region 3, this has primary status along with fixed and mobile. Further, this is governed by radio regulation footnote, that is 5.296A, that mentions the use of 470 to 698 megahertz band for use to IMT services, and there are certain countries which has been permitted or allowed or opted for this within the coordination of ITU-R. So those specific countries can use specified frequencies for IMT services in that country. And further to mention that most of the above countries which are listed there are willing to use 600 megahertz band, that is 610 to 698 megahertz. I want to present this survey done by ITU, and which is part of report BT 2302. The band above 694 megahertz is still used by 22 countries for digital terrestrial broadcasting. With the switch to digital in many areas with region and one, though not all, broadcast services successfully moved out of 800 megahertz band and 700 megahertz band. But still below that, up to 698 megahertz, they are using it. Their further details are there. TV broadcasting, 12 expressed a requirement of more than 224 megahertz. 83 require exactly 224 megahertz, and only 7 indicated a requirement for less than 224 megahertz. So that is where a spectrum requirement stands. In India, this situation is a little bit different, which has been mentioned by Mr. Vinos as well. The band 470 to 582 is available for terrestrial broadcasting in India. And that too, there is a restriction within the band 526 to 582. It is also very screenful, and we are constrained by limiting our requirements by identifying two parts of the band, 700 megahertz band and 600 megahertz band for IMT services. In addition, we were also told to release VHF band 1, 54 to 68 megahertz band, which has already been released. And very well said that a spectrum requirement is very crucial for planning of daily TV transmitters. Thus, and we request that the availability of frequency band 470 to 582 should be continued. Now I am coming to the second part of broadcasting, that is satellite broadcasting. Initial phase of satellite broadcasting was done much before our imagination. It was in 75 when, with the help of ISRO, Doordarshan provided educational kind of program or informational program to rural India. It was in 75. Nobody knows that. Nobody even expects that. These are huge cases where this is being used, very well known to everybody. Direct to home is satellite-based service without any intervention of any service provider at the ground level. Present scenario is that we have in India around 900 satellite channels besides Doordarshan's 36 TV channels. In addition, there are 4 DTH operators, one being provided by Doordarshan, DD Free Dish. Presently, it has 116 channels and other programs. Viewership of DTH is something around 65 million for paid DTH subscriber and 45 million estimated DD Free Dish subscriber. Now, I want to detail some problems we are facing at the satellite broadcasting end. Availability of sufficient transponders for broadcasting, that is a challenge. Broadcasters are trying to create new applications and services to provide enhanced experience to the viewers, like high definition and ultra high definition. For those things, we require more transponders. In addition, the second problem is that availability of sufficient spectrum for having more broadcasting transponders. So spectrum is basic criteria to decide how many transponders we can have on a particular satellite. For example, if we see C-band, as of now, 500 megahertz band which is available for uplink and downlink. And out of that 500 megahertz, we can have 12 transponders of 40 megahertz each bandwidth, and that is the requirement to establish the spectrum. Another problem we are facing from the, as the interference from the other users, with the advent of new technologies and newer and better services are evolving on a regular basis. In order to accommodate all such requirements, the guard band between various allocated services are being reduced. And in some cases, there is sharing of spectrum for 2 or more services. This increases the chances of interference among such services. Satellite-based services are most likely to get affected from such mutual interferences. Why? C-band, we missed something. So we are facing problem in C-band, which I already mentioned. C-band provides an all-weather transmission, which is more important for a very reliable broadcasting services. The C-band spectrum being utilized by broadcasters and MSOs in India and all over the world. Just the amount of utilization, I want to express certain facts. Cable and satellite broadcaster provide communication and terminal services to 200 million TV households. The sector consists of almost 900 registered TV channels, which are all transmitted through C-band satellites. Apart from the services which are being provided in India, there are other uplinks which are being uplinked from India, but being received at other countries. And similarly, some of the transmissions are being uplinked from other countries and we can receive here. In view of the socio-economic importance of the broadcasting sector, the satellite service operation in the C-band should be fully protected from any interference in this part of the band from any new services. Initially, we have got this allocation of 3.3 to 3.5, then 3.6, then 3.670, which made guard band of only 30 megahertz, and now 100 megahertz out of this band, 3700, 3800 is being asked for IMT services. This will impact our services very badly, adversely, and how to resolve this thing, we are still working out on that. We have two main reasons of having interference from the 5G and FSS, which operate in adjacent band. Number one is the immense disparity in signal level between the terrestrially based IMT 5G network and the faint satellite signals being received from the 36,000 kilometers. Very low signal is received at the PDA, and this high signal level of IMT services can saturate the LNBC or LNBF, and nothing will be available at the receiving end. Second part is, out of the band emission produced by 5G transmission, tests have shown that either of these interference mechanisms can result in complete loss of satellite signal. Problem is there, then solution is also there, but we can mitigate through certain arrangements. Mitigation by broadcasters. If that signal is, IMT signal is available, then we have to do certain modification to add filter to avoid the interference. If the guard band is less than 100 megahertz, tailor-made band pass filters are required, which will drive up the cost of the filter. Elevated insertion loss from a special enhanced band pass filter may require a new antenna to maintain 1 minute, sir, only 1 or 2 minutes. So insertion loss will be very high, and to maintain the same GYT, we may require to change the antenna as well, and that will avoid interference. According to calculations made by satellite operators, the introduction of the enhanced filter will reduce the throughput by over 30% in some cases. Mitigation by telecom operators, they have also certain tools which they can use for avoiding interference to the satellite services, use lower transmit power levels, install better transmit out-of-band emission mask, use MIMO technology to null the radiation pattern in the particular direction, whether earth stations are there, and deploy microcells near FSS earth stations, which have lower transmit powers. If they use this, because they are the new entrant, so there will not be any minimum requirement for the broadcaster to modify their existing infrastructure. I am coming to the very important topic, that WRC 27, where certain agenda items are there, where broadcasting services are contributing group. Responsible group is with most of the schedule 5-1, and in schedule 6, which is dealing with the broadcasting services, working party 6A has been assigned the agenda item concerning broadcasting. We are given almost these many agenda items where we can contribute 1.6, 1.9, 1.10, 1.11, 1.13, and 1.17. Out of which I think schedule 6 meeting is still going on right now. And just finish. 1.11 has already been dropped from the broadcasting. And we have, okay, I'll skip this. One agenda item, which is for the WRC 31, we are the responsible group, that is 2.14, which is again the sharing studies and regulatory action of 470 to 694 megahertz band. Studies are going on and meetings are in progress. Thank you.
Thank you, Rajiv, for bringing out the broadcasting setup, importance of broadcasting, try recommendations on the broadcasting policy, spectrum requirement for terrestrial TV broadcasts in UHF band, and satellite broadcasting. Thank you, Mr. Rajiv. Now I request Professor Gupta to talk about spectrum requirement for astronomers.
Hi, good afternoon. I'd like to thank IAFI for giving me this opportunity to present what I will say our view of the universe. So in case some of you are wondering that whether IAFI made an error by inviting an astronomer to talk in this kind of a forum, let me assure you that is not the case. We've heard lots of interesting discussions about issues for how to share the spectrum for all the man-made radio transmissions that we generate. But we don't know that there are radio signals that come from outside, far reaches of the universe, which reach us, and they provide very interesting tools to study the universe. And there is a case to be made for how to share the spectrum for this passive service, which receives some of the faintest signals from the universe. So I can use this, yeah. But before I take you to the far reaches of the universe, I'd like to just go back in time to remind all of us that this whole business of telecommunication that we talk about today is due to Acharya J.C. Bose, who demonstrated for the first time in 1894 how to generate and receive radio signals. He did this 1 year before Marconi did it in the West, and this is something that was recognized by the IEEE a few years ago and is recorded as an IEEE milestone in Kolkata. So, what is radio astronomy? Some 50 years after J.C. Bose made his pioneering discovery, we learned how to pick up these radio signals coming from the universe. And these teach us many different things about the universe. And as you can see at the bottom, there is a wide range in the radio window from about 30 megahertz to 300 gigahertz, in which the signals from the universe can reach us through the Earth's environment. And we study these by building what we call radio telescopes. So a radio telescope is in basic idea no different from your satellite dish, but there's a very big difference. The signals that we receive are extremely faint. So I think all of us understand communication technology. We are talking about power levels of minus 100 dBm is the typical power level that a radio telescope receives. So what this does is, and of course, as we all know, that any radio instrument has noise, intrinsic noise, which can corrupt and hide the signal, as well as extrinsic noise that comes from outside. And these two factors drive us to the situation where we have to build very large antennas, several tens of meters in diameter, much bigger than your satellite dish, 100 meters diameters. Not only that, we have to build arrays of antennas, where many of them of large sizes are spread out over several kilometers in size, and we collect the signal from all of them in order to get the best possible view of the universe. Furthermore, of course, we have to build low-noise electronics. Some of the best low-noise electronics that is built in radio astronomy, so that we can minimize the noise, so that we can see the faint signal. Also, one big difference is that, unlike our man-made transmissions, where we talk about bandwidths of few megahertz for the transmissions, many of these natural signals have very large bandwidths, hundreds of megahertz. So we try to observe over as large a bandwidth as possible, so that we can maximize the signal. So these two issues, one, the very faint signals which are very easily corrupted by any other source of radio noise, and two, the need of using large bandwidths so that we can optimize what we can get, are the 2 points that directly relate to the sharing of the spectrum with other services. And that is what I will come to in more detail as I talk. So here's some examples of the kind of radio antennas that we built. As you can see, some of the largest ones are 300 meters, and now there is the 500-meter size antenna much bigger than this. And you can see the arrays of antennas at the bottom, where there are several tens of antennas spread out over large areas working as an array. So just to bring the focus to our own country, we have quite a few different radio astronomy installations in the country. Perhaps the biggest and the most sensitive is the Giant Meter Wave Radio Telescope located near Pune, which works in the low frequency part of the radio window from about 100 megahertz to 1500 megahertz. So we work almost continuously over that entire frequency range, and it's one of the largest facilities in the world. And then we have a smaller facility at Ooty, which works around 325 megahertz, a facility near Bangalore, which works at lower frequencies. And there are other telescopes that are being planned, some which will go up to 10 gigahertz. There is also a sub-millimeter telescope, which is at frequencies which are of the order of 100 gigahertz, being planned to be set up in the Himalayas. So there's a lot of activity of radio astronomy in the country. And I'll just talk only a little bit about the GMRT. It is an array of 30 antennas, and you can see a picture showing some of the antennas of the array. Each is 45 meters diameter in size, spread out over a 30-kilometer region. And we collect the signals from all the antennas via optical fiber to a central processing system, and it processes up to 400 megahertz of bandwidth in any one chunk of observation. And it is something that is completely built in India, more than now 25 years ago, and been running successfully as an international facility used by astronomers from all over the world for the last 20 plus years. And we recently upgraded it just about 6-7 years ago to make it more sensitive and more versatile. And that, of course, brings the challenges. But before I go there, just a little bit of peek, because you may want to know what do you do this for. And this is just a list of kind of things about the universe that we can learn by this technique of radio astronomy, starting from understanding our sun and our solar system, but also looking for planets around other stars, and then many other different kinds of exotic types of objects, both in our galaxy, in other galaxies, and going out to the very far reaches of the universe, including asking the question, when and how did the universe begin, and so on. There is also one other interesting thing, which is this quest of mankind to know that are we alone. So the search for extraterrestrial intelligence is most readily done by looking for such signals in the radio window. So we build radio telescopes and equipment which is dedicated to try to pick up not the natural phenomena, but like us, if there was an artificial radio signal being transmitted by alien, then can we pick it up or not? And so just to tell you that the linkage to the IEEE milestones, that about 4 years ago, the IEEE recognized the role of GMRT as a global facility and awarded us the 3rd IEEE milestone in the country. Okay, so now I come to the actual matter That is, what is it that we have in terms of the requirements for the spectrum? So as you would have understood, since we are looking for some of the very faintest signals over large ranges of the frequency spectrum, then any other man-made signal can act as a potential interference for us. And we all deal with interference from other service providers, but here, since we are a passive service and we are looking over a large range of frequencies, any other service which is an active service which is broadcasting can cause us trouble, and their weakest signals can cause issues to us. So that is what is called the intentional radio frequency interference. As an aside, there is unintentional interference. There are many other objects which produce interfering signals, which we are not, we think of EMI, EMC for any equipment that we buy, but those EMI, EMC levels are very high. There is always some electromagnetic radiation that leaks from any equipment. Any sparking activity produces radiation, and all of that is very easily corrupting our signals because we have very sensitive facilities. So the point here then is that how do we manage under this situation where all these different intentional and unintentional radio signals can corrupt and spoil what we are trying to do. So, and I'll give you one example. So this is over the different frequency ranges that the GMRT operates, what are the different kinds of intentional transmissions that can affect us, whether it is air traffic control, fixed mobile, TV transmission, and various other kinds of broadcast services. So here is an example of a typical radio spectrum seen at our observatory. So you can see the main sources of interference. The point here is the quiet part of the spectrum is the power level at which we are operating. In fact, our signals are there and even weaker. And so what this shows you is the range, that is the power of the interfering signals being 30 dB, 40 dB above the levels at which we are operating. And that is what causes really the problem, that we are operating at very faint levels. So here is one example. The top one is, both are actually spectra taken with the GMRT telescope. The top one is in 2016. The bottom one is more recent, in about 2023 or 24. And what it shows is that operating band of the GMRT. On the right-hand side on the top are the mobile transmission signals, which we manage somehow with very strong filters put there to block them. But with the recent advent of strong, more of the mobile transmissions, including 5G and so on, you can see the lower spectrum, how much it is corrupted, and that we are not able to use and work over there. So what we do, of course, as I said, we build better electronics to try and shield and protect us from the man-made transmissions, but it doesn't always work. We try various signal processing techniques to remove the interference from the data as we process it. That also works to some extent. But finally, what we need to do is to coordinate with other users of the spectrum so that we can have a via media wherein we can coexist. And there are some plus points for us because what we are looking for are specific locations where the observatories are located and regions around the observatory where we can have this coexistence model where the spectrum sharing can be done in a manner so that the normal human activities can continue, but at the same time, we can also do our work. So that is the direction in which we go. And we'd really like to thank the Department of Telecom and the WPC for a lot of cooperation and help that they have extended to us in order to have the dialogue with all the other service providers so that we can find good coexistence models that we can all work together. So I'll just stop here with just a brief summary that radio astronomy, which really is one of the strong areas in the country where we are very strong, is a field where we study very extremely weak signals. And in order to do this as a passive service, we need to find the best ways of coexistence and sharing the spectrum with all the other active service providers that operate. Thank you very much.
Thank you, Professor Yashwant Gupta, for telling us about the radio signals, its requirements, the passive service requirements, the radio astronomy service basics, radio astronomy, GMRT, ORT facilities, source of interference, the mitigation, how to mitigate the RFI, and the way forward. Thank you, Professor Gupta. If the time permits, we can take 2 or 3 questions. Yeah. Yeah. Yes, please.
Sir, I'm Dr. Jagdish Shivhare, professor and ex-scientist. I have a general question. How are our spectrum issues and services different than international in terms of spectrum efficiency, targets, priorities, and challenges?
So, who is going to answer this question? No, it is such a broad term you have used in terms of the priority and efficiency and services. If you talk about in the mobile telephony or IMT kind of a services, we are very much at par with any of the services or the facilities available around the world. And in other part of the activity also, we are also actively working upon to meet the user's requirement and cope up with the upcoming technologies and incorporating them. Yeah, thank you.
Hello. I have a question for Professor Gupta. So, Professor Gupta, don't you use the Faraday's cage for protecting the things? That will serve a lot of purpose for you.
That's a very good point. We do use the Faraday cage, but if you think you can't put your receiving antenna inside a Faraday cage, it will not pick up anything, right?
No, that's
so
true.
We use the Faraday cage to prevent our own self-generated signals from our computers, from our equipment, to prevent it from reaching our antennas. But I can't put the antenna in a Faraday cage, then it will not get anything. So we use the Faraday cage, but we can't use this to block the unintentional signals coming from other service providers.
No, the thing is that you are using a parabolic reflectors.
Yes.
And once you are using a parabolic reflector, so the signals coming from different directions, at least you can case in that
no, but
in that particular direction you should not do.
Yeah, no, but the antenna moves and looks in all directions of the sky.
Oh, it's a movable
Yeah. So these are steerable antennas because you are looking. So so we can't have a movable Faraday cage. That's not practical.
They need to look the entire sky. Anybody else, please?
Yes, just one question also to Professor Gupta regarding radio astronomy. On one side, you said the protection is a national issue in India, and on the other side, how do you see then the maybe international cooperation in that direction of radio astronomy? Because protecting a radio service is one part, but protecting the side is the more important part for you.
So you're right. So my aim today was to just focus on the national aspect, but it is one of the biggest international challenges to astronomy globally is man-made interference. Even optical astronomy is suffering because of a large number of satellites now in the sky. So satellite interference is very strong. So yes, there are bodies which are set up and they interact very actively. So there are radio astronomy delegations that participate in WRC and put up the case. There are regulations, there are regulations which attempt to safeguard radio astronomy services, but they are not quite sufficient because of the issues that I mentioned in terms of the need to use larger and larger bandwidths. So yes, there is an active national and international level engagement by the astronomy community to try and have, so some of the big radio astronomy sites have protection zones, regulatory protection zones around them in physical area.
Thank you, Professor Gupta. Thank you for your
that
presentation.
will be the last question, yeah.
So basically, my question is a child's question, basically. So as you said that you are able to observe the solar system and systems, other galaxies of the universe, and at times you can also observe the signals coming from the aliens. So my question is whether you observed any signal coming from aliens in the past.
Yeah, no, so we haven't had success there. If we had had that, you would have heard about it for sure. But the quest goes on. Some dedicated facilities are built just to specialize to hunt for these alien signals, but nobody has yet claimed a detection.
Thank you.
So it means still we are alone. Of course, as it's not seen or it's not proved that we are alone. On that note, we can conclude this session. Thank you, the esteemed presenters, and thank you, audience, for the patience hearing. Thank you very much.
Thank you very much, Shri Viresh Goyalji, for conducting this session so smoothly. Ladies and gentlemen, I would like to thank our esteemed panel for their time and sharing their expertise with us. I request Shri Viresh Goyalji to please present a memento to all our panelists on the stage, starting with Mr. Martin Brooke. Ladies and gentlemen, please put your hands together. Thank you, sir. To Dr. Vinosh Babu James. Thank you, Dr. James. Shri Rajiv Kumar. And Professor Yashwant Gupta, sir. Thank you, Professor Gupta. I request Mr. Bhatia to please join us on the stage to hand over a memento to our lovely session chair, Shri Viresh Goyalji. Thank you so much, sir. I request the panel to please pose for a group photograph. Thank you, gentlemen. We'll now break here for a networking lunch. I request you all to please join us back in half an hour, sharp at 2:15, please, so that we can start with some thrilling sessions back to back. We have a very, very amazing mini workshop right after the second last session of the evening. So ladies and gentlemen, please break here for lunch. I'll see you right at 2:15. Thank you so much. due to some unforeseen circumstances, Mr. M.K. Patnaik won't be joining us today. This session will be chaired by Shri Amit Gulati, Senior DWA, WPC Wing DOT. Having vast experience of more than 23 years in spectrum management, including spectrum monitoring, he holds a bachelor's degree in electronics and a master's in business administration. Shri Gulati is responsible for key policy issues related to frequency assignment and satellite network filing for existing and new satellite networks. May I request Shri Gulati to please join us on the stage. Welcome, sir. Ladies and gentlemen, please join me in welcoming our special guests, the speakers of this session. Dr. Laura Roberti, once again, Senior Director, Spectrum and Market Access, Global Telesat. Welcome, ma'am. I request Dr. Puneet Rathod, Lead Technical Standards, Qualcomm, to please join us on the stage. With over 15 years of experience in wireless R&D, Wi-Fi, 4G and 5G, he has contributed to standardization efforts at 3 GPP, IEEE and ITUR. He is a member of the Indian delegation for ITUR, WP5D, and is passionate about developing innovative technologies for improved communication. Please join me in welcoming Mr. Vinay Paliwal, Assistant Director, PMAD in Space. Welcome, sir. A BTech chemical engineer from IIT Madras, having expertise in solid propellant motor processing for satellite launch vehicles of ISRO. He has interest in development and scale-up of high burn rate propellant formulations. Currently, he is engaged in coordination of requirement from various NGEs engaged in space sector for launch vehicle-related supply, developmental testing, technology transfer support from various ISRO centers, and launch-related authorization for launch from India. We'll be virtually joined by Shri H. Rayappa, Director, Frequency Management, Satellite Communication Program Office, ISRO Headquarters, India. He specializes in satellite communication planning, applications, and ground segment development. He played a key role in establishing gateways for high-throughput satellites and implementing satellite communication networks for telemedicine, teleeducation, and disaster management. We welcome him. We'll be joined by Shri Arun Agarwal, DDG Satellite DOT. He's having vast experience of working off the USOF. Shri Agarwal holds a Bachelor's of Engineering degree in Electronics Engineering and an MBA. He is an ITS officer of 1990 batch and has about 32 years of experience in various areas of telecom, such as planning, installation, standardization, rural telecom, USOF schemes, etc. I'd like to hand over the stage to the session chair, Shri Amit Gulati ji. Over to you, sir.
Thank you so much, and thank you very much, ITU-APT Foundation of India and Shri Bharat Bhatia ji, and a very good afternoon to everyone. I'm excited to be here for this session on non-spectrum issues for non-terrestrial networks. It's a critical area of focus for the world as we continue to expand the satellite services and make it ubiquitous for the people who are unconnected. As we know, radio frequency spectrum and associated satellite orbits are valuable and limited resources. And with the increased role of satellite networks, particularly the GSOs and with the recent trend in NGSOs, there's a growing need to understand and manage how we share and allocate these resources. So what exactly is NTN, non-terrestrial network? So NTN are basically networks or segments of network that use, anything above the ground. So except for the drones, anything which is above the ground and connecting the user terminals on Earth, they categorize as non-terrestrial networks. So they could be anything, anywhere between 8 kilometers to 50 kilometers, or perhaps the LEO constellations, or even the GSOs they classify as a part of the NTN. Our discussion today will cover, a host of critical topics, from providing connectivity to the unserved areas to the integration of the direct-to-device technologies, which obviously hold, promise for delivering mobile services to handheld devices through satellites, or perhaps high-altitude platform stations. Now, before I go further, one of the agendas of the World Radio Communication Conference, which will happen in 2027, is agenda item 1.13. So that's precisely the aim, is to study a possible new allocation to mobile satellite service into a band which is not allocated to mobile satellite service. It is currently allocated to mobile services, the same handsets that each one of us use. So the agenda item is for direct connectivity between space stations and IMT user equipments to complement the terrestrial IMT network. So the whole idea is to complement it, not remove a service and transition to another service. So that genesis of all this started from the 3GPP release 15, and right now we have release 18 also here. So I will specify a few frequency bands which are which are part of the NTN framework. Obviously, not catering to the IMT user equipments. The mobile services band. So release 17 came out with 2 frequency bands, N255 and N256. These two are the bands for IMT user equipments. So N255 is refers to 1626 to 1660.5 megahertz Earth to space, and with a complementary space to Earth frequency of 1525 to 1559 megahertz. Now, this frequency band is currently being used by Inmarsat. So just imagine your equipment, which is N255 enabled, has a capability of transmitting or communicating directly through Inmarsat. I presume this frequency band is also being used by one of the others regional player, Thuraya. And another frequency band which was released by 3GPP release 17 was N256. This is pretty interesting band. So the Earth to space component is 1980 to 2010 megahertz with a corresponding frequency of 2170 to 2200 megahertz. A lot of experimentations have been happening all throughout the world. A lot of countries have taken lead in that. Saudi Arabia is one of them. So, but we are here to address more than just the technology. We also face complex regulatory and licensing challenges. The risk in satellite launches, particularly the recent trend in NGSO constellations. We're not talking about 100 or 1,000, we're talking about tens of thousands of satellites being launched and put into orbit to give service and provide broadband through sky. So having said that, we must work together, industries and regulatory bodies, to ensure sustainable space practices. This means preventing orbital overcrowding, mitigating risk from the space debris, which obviously will come in because these space stations, they fight a lot of drag, and certainly the lifespan is about 6, 7, 8 years at the max. And they come and they burn down towards Earth. So the whole aim is to ensure a spectrum usage remains efficient, fair, and interference-free. So efforts have been happening. The first effort which happened was at the ITU Plenipotentiary Conference 2022, where they came out with 2 resolutions. So the one resolution 218, which was in fact driven by one of the UN agendas. So it was, UN agenda was a Space 2030 agenda. So, and another resolutions of the Plenipotentiary ITU Conference 2019 was toward sustainability of the radio frequency spectrum and associated spectrum orbit resources being used by space services. So taking note of these two resolutions, Radio Communication Assembly, another organ of ITU, which met in November, they came out with resolution ITU-APT 74. So it is about activities related to sustainable use of RX spectrum and the associated satellite orbit resources. So this resolution actually invited the ITU-R Study Group 4, which is about satellite services, to develop and finalize. So they're talking about three things here. So you will end up developing a handbook on the best practices being adopted by various operators and nations on how to have, sustainable, how to create the sustainable use of radio frequency spectrum, what best practices has been done. So perhaps when the whole ITU Study Group 4 cycle ends in 2027, we would be in a position to publish this handbook. And other aim of the resolution 74 is a new recommendation to provide guidance towards safe and efficient deorbit strategies. So we'll be coming out with a recommendation. And the third is creating a website which will have a compendium of links. So anyone desirous of finding out more about sustainable use, being an operator or being a regulator or being a general enthusiast, can look forward. This website has already been published. So not going any further, we have an expert panel here, and I also welcome Mr. Raipa, who's joined us online. So our panelists represent a cross-section of industry and a regulatory perspective, right from, of course, Dr. Shri Raipa. We have a representation from an NGSO service provider, although not a service provider as of now, but looking forward to it very soon. Dr. Laura Roberti is there from Telesat. We have on my left is Dr. Puneet Rathore. He's a lead technical standards from Qualcomm, so chipset manufacturer is also there with us. And we have Mr. Vinay Paliwal. He's Associate Director in Space. Together, our panelists, they bring about a wealth of insight into how we can navigate these challenges and maximize the potential of satellite communications while safeguarding the space environment for future generations. I'm pretty sure we look forward to an engaging discussion on these critical issues, and I encourage all of you to think how your work can contribute to sustainable, harmonized, and connected world. I would like to take the opportunity now to invite Dr. Raipa to present if he has anything, and the floor is yours, sir. Thank you.
Thank you. Good afternoon. Thank you, Mr. Gulatiji, Session Chair. At the outset, hope I am audible?
Yes.
Okay. Thank you. At the outset, I would like to express my sincere gratitude to IAFI and in specific Mr. Bharat Bhatia for giving an opportunity to share a few thoughts on the subject today, the spectrum issues for satellite and non-terrestrial services. So it's a greater opportunity to be among the experts from various domains. So it's a learning as well for me. So initially to touch upon, I have a few slides to go through. Can we go to the next slide, please? As it was introduced by the session chair, the non-terrestrial network, the definition itself brings that use of technology, which are to reach out to the people where the terrestrial networks have not reached adequately, or there is a gap in reaching out the terrestrial network to avail the technologies from space and from different platforms like HAPS or HIPS, and so to ensure the global ubiquitous connectivity, thus go towards bridging the gaps, various gaps, whether it's a gender gap or economic gap or a digital divide. So thus bringing the benefits of technology to everyone. So far we have seen that the systems, satellite systems and the terrestrial systems have been operating as a specialized independent domains, Even as per the ITU radio regulations, we see the services are being classified differently for these domains, like FSS, BSS, MSS. Similarly, for terrestrial side, FS, MS, BS, etc. So the NTN mainly addresses making a hybrid of these things, making a hybrid network using various technologies, particularly using the satellites from different orbits, like LEO or MEO or GEO, and use the satellites as a platform to extend the terrestrial connectivity. That is more specifically extension of the cellular connectivity. Again, we hear the developments in terms of direct device and direct connectivity using the mobile satellite services. This also brings a significant opportunity to bring these domains and erase the hard line between the domains and make it more softer, and thus gradually make it invisible, so that the end user will get the services irrespective of the location and time, and irrespective of the technology behind the service. So it will be a service-oriented domain in future. In order to address that, there are many technical challenges. Broadly, there are technical challenges, spectrum issues, and regulatory license issues. I would like to briefly touch upon these things. Can we go to the next slide, please? Yeah, in terms of technological issues, today we are seeing from various news domains from the various platforms, trials and tests are already being undertaken, and some of the capabilities are demonstrated from the LEO platforms as well as the GEO platforms for transmitting the messages and also voice using the current systems. So thus demonstrating the maturity of the technology and trying out the technology. But however, giving the projections of bringing the broadband services using this technology in the near future. Again, the challenges to make it the service reach out to all the levels seamlessly. So there are challenges. Again, there are constraints, I should say. The user terminals, IMT user terminals, should be used as it is without any modifications. And again, the services should not create any interferences to the existing satellite services and existing terrestrial services. And again, when it comes to the satellite payloads, again, there are different thought processes, whether to use satellites as a transparent devices, so that there will not be any processing on board in getting down to the basic signals or basic user traffic. On the other side, use the satellites as a regenerative platform, so that decode the signal, go to the basic user packet data, and try to decode and try to switch it, try to do that, so that the network will be more efficient. But of course, there are also challenges. This needs to be clearly addressed, either this way or that way, or a mix of both. Again, in terms of dealing with the continued connectivity and handover, the Doppler shift from the space systems is a major concern. It has to be addressed. When it comes to service levels, again, there is a challenge of ensuring a synergy between mobile network operators and satellite network operators. Again, the authentication, security, the use of spectrum resources. The spectrum resources, when it is addressed from the space systems, it may vary from country to country and region to region. The network and the technology should address these challenges. Coming to the next one, please. Next slide, please. Yeah, the spectrum, in terms of spectrum issue, again, the basic issue is whether to use the spectrum identified and allocated for IMT services for the NTN services, or identify more MSS and use all MSS as an augmented capacity for IMT. This is the issue. This is a major issue. And in order to ensure economy of scale and efficient use of the spectrum and the global networks, it demands the spectrum harmonization at a regional level and global level. This is another challenge. Of course, WRC 27, agenda item 1.13, has undertaken studies to for the NTN in the frequency range from 694, 698 megahertz to 2.7 gigahertz. And the ITU RM 1036 provides some of the basic parameters for addressing the technological challenges. Again, there are issues related to the technical and operational characteristics which are required for the newly identified MSS from the GSO platforms and NGSO platforms. And also the technical characteristic may be required to be revised or evolved in the incumbent services, and the protection criteria need to be defined so that the spectrum is used efficiently and there are no interference between the services. Of course, the Working Party 4C and the Working Party 5D are very active in discussing these issues. I think as we move forward, we'll see more clarity on these subjects. Next slide, please. Coming to regulatory issues, again, the regionally, globally, the identification of the spectrum, the consensus are required. Once there are different band segments, suppose if we end up in different band segments for different regions, then there is again the system, space system particularly, need to have the capability to dynamically switch to different frequency bands depending on the area in which they need to support that. Again, of course, there are supplemental coverage from space. This is an idea to identify an independent band, neither from IMT nor from MSS for the initial tryouts, whether that will give a lead to move in a different direction to identify a spectrum for NTN. Again, NTN will remain as a different service, or whether it will remain as a satellite service, or whether it will become a truly an extension of IMT. These are the challenges. Mainly, it will be driven by the technological advancements and the industry, the path which the industry try to lead. Of course, when it comes to cross-border different countries, the satellite system catering to different countries, the cross-border coordination and cross-regional coordination is an important regulatory thing which needs to be addressed. Again, coming to national licensing and national regulators, of course, as I was telling, whether, again, it becomes an important point, whether everything will come under a telecom service, or whether everything, the NTN will become a part of SATCOM service, other whether they have to continue as a different layer. These are the clarity required in terms of licensing nationally. So I see from this perspective, this is just beginning. There are a lot of clarity need to emerge in this. But as a technology, NTN has a lot of potential and a lot of applications to provide ubiquitous connectivity everywhere. Thank you for giving an opportunity. Thank you.
Thank you, Raipaji, for an enlightening presentation. He's talked about three things here. Technical challenges, Okay, I remember about a few technical challenges. One he mentioned is the Doppler shift, right? So you have a satellite which is moving at couple of kilometers a second, and imagine the kind of Doppler shift happening in your handset. And another probably an important one, couple of them, latency is one of them. So you have a communication happening through satellite. So what kind of latency you expect will be bearable for a user? And another would be, the kind of battery life that you expect. So you would not like to have a handset which dries out of juice in an hour. So one of the other challenges would be this. And he's also looked at the spectrum challenges, right? So already being addressed at the ITU level to begin with. And then you have the regulatory challenges. So, and where exactly do you, allow this service to? So we had a trial during the India Mobile Congress. So BSNL being one of, not one, the only authorized operators to give Inmarsat services in India. They carried out a trial during the recently concluded India Mobile Congress. So they showcased the NTN application where you can send in an SOS message to a server somewhere in UK, where you have an agreement with that operator, and using the Inmarsat constellation, and your SOS will be handed over to the nearest rescue coordination center, and you can seek help. Now, where exactly should you actually be, giving the service, inside Delhi or perhaps outside? So that's one of the regulatory challenges that would, be there. Thank you again, Mr. Ayappa, for an excellent presentation. I would like to request Dr. Laura Robertino to now take over. Ma'am.
Good afternoon, and thank you for this opportunity to express Telesat views on some spectrum issues for non-terrestrial networks. And in particular, I will focus on recent satellite regulatory activity in India. So as a start, Telesat, and I believe the rest of the satellite industry, really wishes to congratulate the government of India for its decision towards administrative allocation of spectrum for a variety of satellite services. This reflects the physics of the link by which the same spectrum can be shared by all satellite operators and is fully aligned with global practices. In addition to that, there has been quite a lot of activity, in particular by TRAI, with several consultations that are of relevance for satellites. One in July and then one in September, for which there was an open house discussion just this morning, and then one that is still open, and if they don't postpone the deadline, will close next week. Overall, after all this ferment of activities and discussion, I think we're getting to a point in which it would be timely for regulations to be finalized. But let's address these three consultations one at a time. So the first one was for framework for service authorizations to be granted under the Telecommunication Act of 2023. One of the proposals that was aimed to a simplification of the service licensing framework under the unified license was for a merger between VSAT, Closed User Group Service, and GMPCS. While the idea of simplifying is certainly a good one, at least as Telesat, we are of the view that GMPCS and VSAT are very different services, with the former being more focused on MSS and the latter on FSS, and also GMPCS typically uses much lower frequencies. So there are really significant differences between the two, and it would be more appropriate for the licenses to keep separate. However, there are other ways to simplify. So, for instance, the services under VSAT should really be categorized as a public, allowing also services such as backhauling and in-flight maritime connectivity to be provided. Excuse me. Furthermore, VSAT licensees should also be allowed to provide internet without the need for an additional internet service provider license. In relation to the second consultation, terms and conditions for assignment of spectrum for certain satellite services, while the consultation was excellent, very thorough, and very well thought of, we also noticed that there was a focus on non-GSO, which was not so clear why that was the case, and why were we puzzled about it. While it is true that LEO is undoubtedly an emerging technology, especially when it comes to microwave frequencies, non-GSO FSS systems will provide similar, if not identical, services to GSO FSS networks. And this is also proved by the fact that now multiple user terminal manufacturers are building and already making available now user terminals that can operate in multi-orbit systems. So in other words, the same terminal can operate with the GSO satellite, and then when there is no GSO coverage, for instance, it can switch seamlessly to the non-GSO satellites using the same frequencies. So again, based on this, there should really be no difference between method allocation and spectrum pricing. Furthermore, we don't see really a need for additional provisions at national level in order to protect, for instance, other satellite systems and/or terrestrial systems. And why? Because satellite by nature are multinational or even global. So these type of regulations and frameworks are decided on a global basis at the ITU, and there are already suitable provision in the radio regulations. Finally, there is really no need for fixed distances between gateways of non-GSO systems. And why? Because the characteristics of such gateways vary from system to system. So this is something that is best left to the non-GSO operators as part of their overall coordination. And not having fixed distances also prevents the risk of scarcity of non-GSO gateway sites, especially in a country as big as India. And that's it. Oh, okay. Okay, now I can see. In terms of spectrum charges, which was another topic under the same consultation, we fully support, for instance, the proposal from TRAI of 1% of the adjusted gross revenue in terms of spectrum pricing. It's not the only way. There can be other way, for instance, per megahertz or a fixed amount. However, what is important and essential is that the fees are kept to a reasonable level, also taking into account that the modern GSO and the non-GSO systems, for instance, operating in Ka band, they can use more than 1 gigahertz for the uplink and the same for the downlink. For instance, the formula that refers to the royalty multiplied by a bandwidth coefficient would give rise to astronomical amounts, and as such it would not really be suitable. Overall, it makes sense when there are a multitude of similar terminals for them to be covered under what we call a blanket license to avoid cumbersome individual terminal by terminal licenses. In any case, the most important thing really is that there is no unwarranted differentiation between method allocation and spectrum charges for GSO and non-GSO systems offering essentially the same type of service. And while this is not on the slide, I would like, because again, I was listening to the discussion this morning, the open house organized by TRAI. And an argument that was put forward, and it was also mentioned in one of the sessions last night, is this idea of level playing field between terrestrial and satellite, and these concerns that some mobile operators have of direct competition by satellite. We don't believe this idea of level playing field to be valid for a variety of reasons, because the scope, the volumes, the technology is different. But I think it's enough to ask how many among you or the people you know use or are planning to use a microwave satellite user terminal for everyday connectivity. It is most likely that the only time that we use it is when we board the plane where in-flight connectivity is allowed. But then again, this is not direct competition to terrestrials. In other words, we are of the view that satellites are not, and I'm referring both to direct to consumer or for ancillary services such as backhauling, are not in direct competition with terrestrial mobile. They are and will be and will remain a complementary service. The other point that I wish to mention is in relation to the 28 gigahertz band, because one of the questions in the consultation was about spectrum. 5-6 years ago, there was a lot of enthusiasm with the terrestrial mobile community in relation to these frequency bands, even if it was not identified for IMT by the ITU. But after 5 years, I think now we have acquired experience in actual deployments. And we can see that in the few countries where the spectrum has been auctioned for terrestrial mobile, the actual deployment has been very, very scarce and really only focused on highly populated centers, leaving the spectrum unused in all the rest of the country and preventing the spectrum to be used, for instance, for satellite services. So I think this is a useful experience that needs to be taken into considerations by the regulators and the policymakers. Final and last, the last consultation, the one that is still open, terms and conditions of networks authorizations to be granted under the Telecommunication Act. In these consultations, questions are being asked that, if I remember correctly, were already addressed in a previous consultation. And one is, for instance, in relation to the satellite gateway license. At least as Telesat, we fully agree that it should be a separate license from the service provision, and that the gateway licensee should not be allowed to provide the services as such. However, there are some points that may be worth reconsidering in terms of recommendation. First of all, for instance, in terms of installing the baseband equipment, there should be flexibility, because again, this is something that really can depend from system to systems in terms of who does what. Another point was the recommended disclosure of financial terms of the agreement between the gateway licensee and the service licensee. We are of the view that this is commercially sensitive and should not be public. Also because there can be variation, for instance, from country to country based on the characteristics of the local economy. And finally, last slide, in terms of spectrum licensing in relation to the gateway, it may be best first to wait until a general decision is taken on how to license and allocate spectrum to the service providers. There is the risk that the same gateway may need the same antennas in the same gateways may need multiple licenses if there are multiple service providers. And that's something that may be best avoided. But again, that very much depends on the decision that will be taken in relation to spectrum license for the service providers. In any case, I would like to highlight what I think is an important aspect. is that the gateway owner, the gateway operator also needs some sort of authorization in order to operate the gateway. And this is not to provide services, but it's purely for operational purposes, for instance, for testing the antenna, for TT&C, and so on. And with this, I thank you very much once again for your attention, and I conclude my presentation. Thank you.
Thank you so much, Dr. Laura Roberti, for summarizing, and a lot has been happening in the DOT recently. I'm sure very quickly we'll come out with the things that you have summarized here. Thank you so much. And I'd like to request Mr. Vinay Paliwal to please take the stage. Thank you.
Good afternoon, everyone. First of all, I'd like to thank IAFI for having me here along with the senior DOT members and the industry stalwarts, as well as my mentor, Shri H. Rayappa from ISRO, Director SATCOM. This is a privilege to be here and to discuss. As already highlighted by the session chair, as well as by Rayappa sir, there are major three issues which we are looking for the satellite as well as the non-terrestrial network. Basically technical, the spectrum, as well as the regulatory. Dr. Laura also highlighted some of the regulatory aspect which is specifically related to spectrum. In my session, I'll limit to the space segment and the regulatory certainty that has been there for the space spectrum with respect to various reforms that has been introduced. Just giving a quick recap about in-space and the current space reform that has happened so far. It started with the reforms introduced in the 2020 with the announcement of in-space and the intent to introduce private sector participation in the space sector, then the constitutionalization of in-space, and the key event being the Indian Space Policy 2023, which has become the guideline for the regulatory activities within the country. The FDI policy, revision of the FDI policy for the space sector, announcement of VC fund, and the yet to or in the pipeline, the Space Bill and Act are the current events that are leading. Not to be missed, which is not mentioned here, is the Telecommunication Act of 2023, which has paved way for the assignment through administrative measures for the spectrum access for certain satellite-based services, are the key events which will be which are given some certainty. All these reforms were introduced with an intent to enhance private sector participation, and for the space segment alone, in-space has been constituted as the regulatory as well as the approving authority for the space activities within the country. Though we do have a dual role of authorizing as well as promotion of the space activities. Recently, as it was introduced by our chairman, Dr. Goenka, that the space law or the first draft of the space law is also ready and it will be open for consultation by the end of this financial year. Till that happens, the space policy is what governs the activities today. And InSpace has brought out the norms, guidelines, and procedures for implementation of the Indian space policy with respect to authorization of space activities. This is this government document was brought out after consultations with various industry associations, including IFI and various other industry members. Further, various government departments have given their views, and it contains the list of space activities which need authorization, the criteria followed for granting the authorization, the entire process, as well as the conditions and guidelines which has to be adhered to by an applicant. Further, it has the certificate which gives a template of the certificate which is the indication to the conditions imposed post the granting of authorization. Just highlighting, as this already known, only an entity which has intent to carry space activities from Indian territory or within the jurisdiction of India or within the economic zone should apply to InSpace seeking its authorization with respect to the particular space activity that it intends to conduct. Salient provisions that we look for while authorizing are mentioned here. You can see on the screen. And there are further things in the NGP with respect to third-party liability, the space object registration, and the ITU filing under which the space object operation will happen is one of the key aspects that is considered while authorizing that activity. I'll just highlighted the major activities which need authorization from in-space. Though to this community, I believe the number one, the establishment and operation of the space object is of interest, more specifically for the purpose of rendering communication services. I'll delve more into that. Just for the completion's sake, this is the overall process that is followed. Everything, the application to the process has been made online. The applicant approaches through an application on the InSpace digital platform, accessible our website. We do a preliminary assessment and acknowledge to the application on the acceptance of application once complete information is received. We help them with an advisory note for him to enabling them to seek ITU filing through WPC. Further for the DGFT export licenses also, if necessary for launch or any other activity. The timeline also is brought out in the document, which is varying from 75 to 120 days based on the activities involved while we review the application. I'll come to the specific point for the authorization for the SATCOM related activities. Basically, this for simplicity's sake can be categorized into two activities. One where the services are rendered through an Indian satellite, and the other where the services are rendered through a foreign or non-Indian satellite. In both the cases, we have permitted the utilization, the ITU filing from the Indian administration or the other administration can be done. In case the satellite is Indian, it will be registered as an Indian space object also, and it is normally mandated that at least one mission control center should be within the Indian territory, and the validity of authorization will be till the end of the operational life of the satellite. Whereas there is a minor difference in case an authorization is sort of provisioning of satellite capacity of a non-Indian satellite. Though he may, obviously it may operate under the non-Indian filing, and it can be very well welcome them to operate under Indian ITU filing also. In such case, the validity of authorization can also be extended to the life of the satellite, which will usually be restricted to 5 years. Certain key aspects which are there for this activity are the protection from interference to the existing services. The new prospective new entrant should be mindful of that, and we encourage that they collaborate, negotiate, and enter into frequency coordination agreements among each other, such that to ensure there is no harmful interference. We also permit in-orbit procurement or acquisition of a satellite, and once the authorization is granted, the further resale or subleasing of the capacity is permitted. There is no need to approach to InSpace further for that. Now, the essential aspect, the ITU filing, which enable all that, is any NG, Indian entity, can have an access to the orbital resource by way of two means. Either they can go for a fresh ITU filing, new ITU filing. I have just highlighted the process which is followed for that. They can approach InSpace with the frequency parameters under which they need to operate. After preliminary examination, InSpace will be issuing them with an advisory note, with which they can approach WPC, and I believe DOT has brought out their own guidelines and procedures for the submission of satellite network filings, which detail out the process from thereafter. Once all the activities, the milestones as defined by the ITU are achieved, the applicant enjoys the rights of use as long as it continues to operate the satellite with the corresponding ITU filing. All this happens with the coordination of WPC, obviously, and the applicant can further approach InSpace for seeking suspension or relinquishing or surrendering of that particular orbital resource, which is then recommended by InSpace to WPC for their action. The other way to access this ITU filing will be through an announcement of opportunity hosted by InSpace. In certain cases, few of the unutilized or the available ITU filing will be made available to Indian NGEs having Indian management and control only will be eligible for that, and they can participate in this announcement of opportunity. There is already a predefined selection criteria mentioned in the IDP, and we already have one such announcement of opportunity running for one KA band filing, for which evaluation is under process, and we may have the evaluation completed shortly. This is the two things. Thank you.
Thank you so much, Vinayji. Thank you for also telling us that the draft of the space bill is actually pretty near to be announced. So, and we'll be very excited to go through what the space bill looks like. And one more thing which you mentioned here, I would like to reiterate it once again. About a couple of days back, we came out with the guidelines and procedures for Indian entities who are desirous of using the space resources. So what guidelines or procedure, what kind of conditions are there? So this is a good summary of list, and you can go through the DOT website, you will find them. Many countries have these kind of guidelines and procedure, and we thought of doing the same, so we have it. Now I would like to invite Dr. Puneet Rathod to take the stage. Puneet ji.
Thank you, IFI, for inviting me and share some thoughts on the topic of non-terrestrial networks and the satellite spectrum-related topics. Thank you to the distinguished delegates with me on the dais who have shared very valuable information and insights on a lot of elements related to satellite spectrum and satellite usages, including the new initiatives for using the satellite resources from India. I would like to touch upon 2 or 3 topics which we have not yet covered from the perspective of using the satellite services directly from a device, including the new WRC agenda items. We did have a lot of discussions about the new WRC agenda item of new MSS allocations and also the direct-to-device. I would try to focus more on the 3GPP developments and the technology-related aspects, which could then have some consideration on how do we take a look at these developments. So from the non-terrestrial network point of view, 3GPP non-terrestrial networks, they have been under standardization, and as of release 17, it does have 2 broad flavors, and they are also part of the satellite component of IMT discussions within Working Party 4B as well. And the one on top, which is the 5G NR NTN, which can provide the EMBB kind of services from satellite to connect traditional broadband kind of usage to laptops or terminals, automobiles, and so on. And the other kind of technology development is also about IoT end-to-end, which is about trackers or sensors and small data kind of communication. And the importance of both of these would be that when we look at it from the perspective of the new agenda items, there are 3 different agenda items within WRC 27, and 2 of the agenda items, which are agenda item 1.12 and 1.14, they have some relationship to how these technologies may eventually come into usage in those new allocations for MSS, if those agenda items do end up identifying those additional bands for MSS. Just to bring into perspective, when 3GPP utilizes the term non-terrestrial networks, there is a slight difference in how 3GPP interprets the same term, because it is a body which is outside of ITU, so they have their own terminology. And when 3GPP tries to utilize the term non-terrestrial, anything above the ground starts getting called non-terrestrial networks. So from an ITU perspective, 50 kilometers and above is non-terrestrial. 3GPP starts utilizing even for drones and HAPS. From a technology point of view and 3GPP perspective, it is non-terrestrial. So sometimes when we try to look at the 3GPP documents and references, there may be some ambiguity. So we may be mindful of that terminology reuse across, say, ITU and 3GPP. But when eventually from the 3GPP perspective, the traditional networks were designed for a communication between a mobile phone and a base station, which is both on the terrestrial, on the ground, and the typical distances, few meters, few kilometers, and in the order of kilometers. The moment we start talking about this non-terrestrial, so then whether it is drone or a base station on a HAPS platform, or going further up on a LEO, MEO, or even GEO, the base station starts moving further and further away from the end user terminal. So 3GPP towards this technology journey started looking at the impact on channel models, what would be required to eventually enable such communication where the distance between the user terminal and the base station increases. And then towards that, it started developing technologies to make these communication links possible. And one additional part which was mentioned by Rayapaji as well, which was about Doppler. So I just want to highlight one additional element which we may want to pay more careful attention to is especially in the topic of direct to device. When we discuss direct to device, we can have a more legacy kind of interpretation, which is the devices that we currently have in our existing networks, the existing legacy LTE or legacy 4G or 5G NR devices, which are what we have today, which is release 15 or before, which is before 3GPP started developing all of these NTN related technologies. So that is one way of looking at it, that the newer potential MSS allocation should be able to give connection to the existing user devices which are already deployed in a wide scale. But when we consider the impact of Doppler and the impact on whether the traditional legacy devices were designed to be able to communicate with the base station, which is so far away. So a lot of pre-compensation, a lot of processing, and a lot of baseband related compute is being done on the base station side or on the satellite side. And as a direct impact of that is that even if it is a LEO satellite, the satellite footprint is quite large. So directly in the middle of the cell of a 200 kilometers radius cell, at the center of the cell, all the pre-compensation that is done at the satellite side, that will be more accurate. As the user starts being towards further away from the center of the cell towards the cell edge, or it is not truly a cell edge, but it is further away from the center of the cell in a very large footprint of a 200 kilometer radius, which is very, very large as compared to a traditional base station where we are talking in order of kilometers. The pre-compensation will start having more errors in terms of inter-symbol interference. And those kind of artifacts then have a direct impact on the kind of capacity that the network could have. So when we try to look at these agenda items of enabling direct connectivity to the device, we should also not rule out the potential of enabling future development or future enhancements in the technology itself, where the device is aware that it is talking to a base station which is several kilometers in the sky. So that is one perspective which is which may be very important consideration, along with the other topics which are truly part of the agenda. And what I was trying to mention, that of the three agenda items, 1.12, which is about IoT, NTN in the satellite bands, L and S band, 1.13, which is trying to enable direct to device, which is where we need to consider whether existing legacy devices or have the potential of keeping this open for allowing more innovation, technology enhancements, and the device being aware of the satellite being the main transmitter or the base station. And then agenda item 1.14, where it is more about enabling broadband kind of applications. And a few key issues which we have been already discussed, which is there are a few regulatory issues about the satellite footprint and where the footprint of the satellite may cross country boundaries. So when we try to talk about the protection of terrestrial IMT systems, there are some considerations about the regulatory parts as well. It is also about the protection of IMT systems. We had an example in the previous WRC in agenda item 1.4 when we were considering the HIBS agenda item. And a few mechanisms were considered for the protection of IMT systems, and few of those are alternatives being considered. How to go about looking at protection to the terrestrial IMT systems. Will it be PFD per satellite system, aggregate PFD, EPFD? So those are considerations, and then we have the terrestrial IMT bands from 1036, which are part of the agenda. And in the recently concluded Working Party 5D meeting, there was a dedicated session which truly helped in having a very frank discussion between Working Body 5D and 4C on the work split, so that it is very clear what kind of work will happen within Working Body 5D on the topic of regulatory analysis and the protection for the terrestrial IMT, and then Working Party 4C remains the main group where all the sharing and compatibility studies are done, including the development of CPM text. So with that, I would conclude my short presentation, and thank you so much.
Thank you so much, Dr. Puneet. Indeed, we have come a long way from IMT 2000 to IMT Advanced to IMT 2020, and now we are looking at IMT 2030. And we are not now looking at integrating the IMT with satellite. So interesting times ahead. So I'd like to start a panel discussion by asking a question to Sri Raipa, who has an excellent contribution to telemedicine, tele-education, search and rescue. And so what are the potential benefits that we're looking for, especially when it comes to consumers for direct-to-device satellite communications? Sir. Can you hear me, Raipaji?
Yeah, I can hear you. Hope I am audible.
Yes, please.
Okay. The question now, we see that there is a lot of gaps between particularly in India, rural India and the urban India in terms of access to quality education, quality healthcare. Those are the social aspect. And thirdly, when there is a disaster event, the first casualty will become the power connectivity and the digital connectivity. So in order to undertake any relief works or rehabilitation works and then reconstruction works, the resilient communication backbone is important. So in that sense, this technology coming from space will be more reliable and more, we'll be able to roll out quickly in terms of time, and it will be more portable as well. So the NTN technology will be a boon to address these kind of things. Coming to the economic activities, still there are a lot of opportunities in the rural India, be it a market access, be it a financial access, be it in any other tourism, etc. So in that sense, again, the connectivity plays an important thing. NTN with the user devices being the ubiquitously proliferated devices in the hands of the people. So you don't have to worry about switching between the technologies, the constraints on the applications. So this will be a major potential and major boon to reach out everywhere.
Thank you so much. I know the use cases, the sky is the limit now. You never know what kind of new applications might come up tomorrow. I remember when the 3G came, it was a lot of talk about giving data. It was sea change from 2G, but what happened was ultimately in India especially, it was, people were using it more for voice clarity than using data. So you never know what kind of use application might come tomorrow. Now I'll come to Dr. Puneet here. So being the chipset manufacturer, Qualcomm is the leading manufacturer. How the chipset design evolving on to support compatibility between both terrestrial and satellite networks, and what are the spectrum challenges do you see for chipset manufacturers?
Thank you. Specifically related to the enabling communication directly to the satellite, both terrestrial, NTN, and others, the technology development is very much there, including recently in the concluded IMC that was concluded recently. Qualcomm did have a few demonstrations of in the L band, where there was an NTN demonstration from a mobile phone directly jointly with BSNL and Inmarsat. So from a technology point of view, it is very much there for several applications. Obviously, truly from an integration point of view, there is a constant development within 3GPP on from release 17, 18, and beyond, where more enhancements are being added both on the physical layer and the signaling part, and also on the core network integration part, to truly enable more better communication capabilities. There is already a 3GPP candidate technology which has been submitted to Working Party 4B for the satellite component of IMT. So there have been consistent technology developments within 3GPP and also within the ecosystem. So not just Qualcomm alone, but within the ecosystem there has been wide interest. And just one additional part which I wanted to bring up was that in general, like as we look at the complementary nature of this non-terrestrial communication, it will be very important going forward from the ubiquitous connectivity point of view to be able to connect beyond the urban centers, suburban, or even the traditional rural, where in the far or difficult to reach areas. And this complementary nature of coverage was also brought out yesterday in many panel discussions, where there are very difficult to reach terrain or extremely sparse areas where this non-terrestrial communication directly to the device may be very instrumental. Thanks.
Thank you so much. We're really running short of time, but Partiji, please allow me one last question. So a quick input from Vinayji and Laura, and what best practice should be adopted globally to ensure fair and sustainable use of the spectrum resources? Please, quick.
I'll keep myself brief as we are running out of time. As you told, the certain best practices we have while granting authorization, also at the aspect of registration, we do mandate that the positions of the satellite are given back to our Department of Space, such that an active catalog of the space object is maintained with us and effective space traffic management is conducted. Further, the collision avoidance maneuver and are accounted well in advance before we even allow them to launch or establish the object in space. But as you told, if these precautions are not taken a priori, nothing can be done once it becomes a debris. So that's the brief. Thank you.
One last input from you, ma'am.
Okay. Okay. Yes, no, just to add that we think what is urgent and important is that final decisions are taken in terms of finalizing the rules for satellite spectrum and spectrum assignment, so that the uncertainty is removed and services can be deployed. Thank you.
Thank you so much. And I'll like to thank our panelists, Shri Raipa from Bangalore, and all the three panelists over here. Thank you so much for joining in, and the audience as well. Can I take a question, or should I conclude? Thank you so much.
Break for sure. In the networking tea coffee break, we can take the questions offline. Thank you once again to all our lovely panelists for joining us and sharing your viewpoints with us. Ladies and gentlemen, this is time for all of us to take a break. But before that, I'd request our session chair, Mr. Amit Gulati, to please hand over the mementos to our panelists. Firstly, to Dr. Puneet Rathod. Thank you so much, Dr. Rathod, for sharing your viewpoints with us. I'd like to thank H. Rayappa sir for joining us virtually. A request Mr. Amit Gulati to please hand over a memento to Mr. Vinay Paliwal. Thank you, sir, for joining us. And I'd request Mr. Bhatia to please hand over a memento to our session chair, Mr. Amit Gulati. Thank you, sir. May I request you all to please pose for a group photograph? Thank you, gentlemen. Thank you, ma'am. Ladies and gentlemen, it's time for a teeny mini tea and coffee break. I'd request you all to please come and join us back in time in 10 minutes. I think that will be more than enough for all of us to refresh ourselves. Would request you all to join us back for a fiery mini workshop on 6G, which will begin in 10 minutes time. So please bring in your coffees to your tables and we'll see you at the last session of this evening. Thank you very much. Ladies and gentlemen, may I request you all to kindly join us back on your seats as we are about to begin. Everyone's requested to kindly come back to their seats. Welcome back, ladies and gentlemen. Get ready to be a part of a fiery and a power-packed mini workshop on 6G. Let me quickly introduce our panelists and invite them on the stage. Ladies and gentlemen, please welcome with a huge hand our session chair, Shri R.K. Upadhyay, Chief Executive Officer and Chairman, Project Board CDOT India. With over 31 years in the telecommunication industry, he has held key positions in CDOT, the Department of Telecommunications, and other government bodies. His contributions have earned him prestigious awards, including the J.C. Bose Award and National E-Governance Award. Welcome, sir. We welcome the coordinator and the moderator of the session, Shri R.K. Pathak, DG, Bharat 6G Alliance. Shri Pathak is a seasoned telecom expert with over 33 years of experience, has previously held key positions at the Department of Telecom, overseeing international cooperation, standardization, and telecom experts. Shri Pathak's expertise in spectrum management and policy is invaluable to India's 6G development efforts. Please welcome our speakers on the stage, Dr. Sendil Kumar Devar, Director, Standards and Spectrum, Ericsson. Welcome, sir. Dr. Devar holds PhD degree in electrical engineering with specialization in wireless communication from IIT Madras. Currently responsible for standardization and spectrum engagements in India and works closely with the national, regional and global working groups related to standards and spectrum matters. Please welcome Mr. Luigi Ardito, Spectrum Group Chairman, GSA UK. Welcome, sir. Please welcome Dr. Vinosh Babu James, Director, Technical Standards, Qualcomm. Welcome once again, sir. Please welcome Dr. Stuart Cook, Senior Director of Future Spectrum, GSMA UK. Welcome, sir. With a huge round, ladies and gentlemen, please welcome Professor Radhakrishnan Gandhi, IIT Chennai, specializing in wireless networks, stochastic geometry and information theory. He develops analytical and stimulation tools to study large-scale wireless networks. Professor Gandhi is a respected academic known for his expertise and dedication to teaching and mentoring. Please welcome Shri Prashant Kumar, DDGCA, TEC, DOT. Dr. Prashant is a highly accomplished bureaucrat with 33 years of experience in the Indian government. His career has spanned various ministries, including tribal affairs, road transport and highways, law and justice, and communications. He has extensive experience in policy planning, project implementation, and international relations. Welcome, sir. Please welcome Professor Paresh Saxena, Associate Professor, Birla Institute of Technology and Science, Pilani, Hyderabad. He leads several research projects funded by various organizations, including Axiado, DST, SERB, and TCS. He has also been involved in European Space Agency projects and has worked as a visiting researcher in Canada and France. We'll be virtually joined by Professor Rajiv Shore, Director, IIT Surat. We welcome him. We'll be virtually joined by Professor Monisha Ghosh, Department of Electrical Engineering, University of Notre Dame, Adjunct Research Professor, University of Chicago, Policy Outreach Director, Spectrum X, NSF Spectrum Innovation Center, and also we'll be joined by Mr. A. Jishnu, Principal Product Architect, Tejas Networks. He is widely active, engaged in contributing to development of standards at the ITU-T, SG15, ITU-R, WP 5D, and 3GPP, RAN1, SA2, and successfully coordinated TSDSI efforts for inclusion of TSDSI's 5GI in IMT 2020 at ITU. He has filed for 16 patents and is currently focusing on 5G, ADV evolution, IoT, and network slicing. Ladies and gentlemen, please give it up for the panel, and I'll hand over the dais to our chair, Sri R.K. Upadhyay, sir. Sir.
Good afternoon, everyone. Pathak ji, distinguished panelists here, and the distinguished panelists who have joined us online. Leaders from the industry, Bhatia ji, other experts, ladies and gentlemen. I think it is an honor and privilege to be part of this event, which is very timely, 6G. I think the topic is that how do India take leadership in 6G? I think I'll repeat the words of our Honorable MOC Minister, who said that we followed the word in 4G, we marched with the word in 5G, and we will lead the word in 6G. I think that path looks very, possible. It was not possible earlier because we actually never thought of, we continue to be the consumer of the technology rather than the developer of the technology. And good news is, as the softwareization is happening, it is easier for us to get into the 6G. Because if it was primarily hardware, I think there are still a lot of shortcomings, a lot of supply chain issues which need to be taken care in terms of developing technology. But as the softwareization is happening, I think India has a great chance in becoming a good force globally. And why do we say so? Just to update the August audience here, India has become the 5th country in the world to have its own 4G and 5G. Our 4G and 5G is already deployed in BSNL. Today, it is radiating 60,000 BTS, and handling around 7 million customers simultaneously. and transacting a data of 1.7 petabyte per day. This is under launch stage, and I think going forward in few months, the complete pan-India rollout will happen. So since we have developed 4G and 5G, we got a good understanding of the technology, and therefore India has a good chance to be one of the leader in 6G. What we need to do, we need to all work together. We need to participate in the standards body very regularly as a united force, because typically in 3GPP, when you go in the standards making, you need a good, cohesive, position, which is from academia, which is from industry, which is from R&D, which is from government, and push together, and also take along the countries like Bharat 6G Alliance. I think we are, having agreements with other countries, taking everybody along, and make harmonized standards in a manner that is not only benefiting India, but it benefits the whole world. So I look forward for an engaging discussion over this conference, and it is very timely. Just to tell you that the Government of India actually has taken a lot of initiative. One quick initiative, I'll let you know that we have a Telecom Technology Development Fund, under which we have already funded 111 6G projects. So money is not an issue. If there are startups in this room, please, we'll be very happy to put money on 6G. We have also funded a test bed to Samir, around 70 crore fund we have given, and the terahertz communication link was showcased in IMC, demonstrating a bandwidth of 630 MB. I think it was 630 TB. It's a very good bandwidth what was demonstrated. We have also funded advanced optical, because we also know that a lot of work will happen on optical side. We have funded a project to 170 crore to IIT Chennai, a consortium of 10 members. So going forward, I think India is, the various building blocks, what are necessary for success. These works are happening, and we look forward for, joint working with academia, industry, startup ecosystem, so that the country can progress well and in this technology. So I hand over the floor to our moderator, Pathak Saab, to conduct the proceeding. Pathak Saab, over to you.
Thank you. I think let us give the big round of applause to Dr. Upadhyay, because we are the 5th country, so I think he has taken that role. With this, I think let me thank organizers ITU-APT, and let me say that perhaps in this room I met my very first Bhatia sir in my old assignment in DGTD. So I think I joined in 1987, so I know him since then. I have a very distinguished panel. I am sure that they will be discussing a number of issues. They submit at ITU Working Party 5D, it may be at 3GPP, it may be at different forums within the country, outside country. But what is my thought process that as was shared by Dr. Upadhyay, we have a lot to do in 6G, and I remember when we asked the questions from ourselves as individual that what is 5G, and we could not get the right answer. We came up with a report called Making India 5G Ready. Spectrum, regulatory aspects, consistent participation, technology trials, R&D were some of the task force recommendations. And we have a lot learned in this process of 5G, that still we have the connectivity part. We have exploited, leveraged the connectivity of 5G technology, which was never intended. It was the other two buckets, which were basically, one can say, a revolution part, but that we missed. And in this process, when I was, going through the 6G and 6G stories, attending seminar, then I realized that it was not the story of India. It was a story of entire world. They missed the use cases. So perhaps even in 6G as well, we have to work together with all the ecosystem partners, vertical industries, in this development of use cases, applications, and if we be able to give them the message that they have to work together in 5G, 5G advanced, and then only 6G will come. Then I think we will succeed in 6G. As far as India's Bharat 6G Alliance is concerned, from where I belong, it's one can say a research, a one-year research alliance. We are bringing together in this country TSPs. We feel that TSPs has to lead the technology development. They should not be just mere user. And then startups has a lot role to play in case of use case development. And India being the third largest ecosystem for startups, we have a lot to give in this so-called 6G and related technologies. Why I'm saying related? Because once you say 6G, then India told that we will do the affordable connectivity, sustainable connectivity, ubiquitous connectivity. So perhaps I think AI roles come, quantum roles comes, whether this AI will be in the network or it will be in the verticals, in quantum. So I think from the very beginning, we have to work together in communications also. We should not say that some other will be working on the AI or ML and applications and will be just concentrating on. So I'm sure that in 3GPP, these are being discussed and my colleagues, they will be sharing these thoughts. Dr. Upadhyay told about the collaborations part. In fact, he is in charge of outreach committee, and I'm happy to say that in recently concluded my first 6G International Symposium, we exchanged MOU with the 6 global partners, and to name 6G Forum Korea, 6G Brazil, NGMN Alliance, 5G ACIA, UK, India, Future Innovation Network, and UK team. It appears that I'm missing someone. So I mean, NextG Alliance, 6G IA, 6G flagship. So we have brought all together wherever the 6G work is going with the like-minded partners. So now we have to work, and as I told by Dr. Upadhyay, that government has in place in Department of Telecommunication, TTDF, in same way AI mission in MIT, which is another ministry, and quantum in Department of Science and Technology. And I think we have to work together. In fact, even ISRO has also 1,000 crore startup fund for the working in TN and TN. So I think we have to work on that part as well. So I'm sure with this background, I will just request my panelists to be very brief, and they should not exceed 5 minutes. And I won't be asking any question as a moderator. But I think I will prefer that let the questions be from the audience, because I think let them be connected. So very first, I invite Mr. Sandil Kumar, Director Standard and Spectrum, Ericsson. Over to you. Might exceed 5 minutes. 5 minutes. Don't exceed.
Okay, I have a very strict timeline, much shorter than the 6G timeline that we have. I'll try to see if I can do it in less than 6 minutes. Okay, so basically I would want to share some slides basically to look into the timeline that we have so that we know what is our opportunity that we have from today to the 6G development. So that will also help us saying how do we prioritize our activities, and so that we can demonstrate our leadership in the 6G development. More from standards part, as well as also having the right spectrum available, and then in a similar fashion that we did in a 5G HLF activity, right? So can we do something that will ensure that we are also launching 6G in the right time? Can you go to the next slide, please? Yes. So this is something which I shared yesterday also. This is like having a high-level overview of vision, what every company has. We need to have administrations, everyone looking at what do we want to do with 6G in that right time frame. So from Ericsson perspective, we think cyber physical world is going to be a real expectation that we'll look into 2030 time frame. And then we come back from the retrace back saying to do that, what is it that we need to do? If you can go to the next slide, please. So we did, I mean, this is something which we have been developing and talking to so many operators and other industry members and other application developers. So there are more than 320 5G networks which is already deployed now. So when we say 320 networks, at least Ericsson has more than 170 networks in which we have a network either in RAN part or the core part. So at least we try to hear to those operators and see what is it that they would want to see happen in 2030. So this is how we try to categorize them. When we say many operators, even in the B6GA report, you would see one of the key things that the operators, the inputs have been saying, from now to 6G 2030 timeframe, we see that from video calls to levels of immersive calls or maybe 3D video calls, and then at 2030 we should be able to see that can we do XR calls a reality. So that's a progressive effort that we are looking at that will really happen. And then we want to see that how do we introduce those features which we can, I would say, operator can commercialize it, offer it so that it is not only in small pockets but in a macro network. And then global broadband is something which is there in ITU. It's called ubiquitous connectivity. But then this is also a wish list from a lot of administrations. Satellite operators are there. Even terrestrial operators are saying, can I ensure that my customer is always connected? But then what you offer with that connectivity will vary because of your capabilities of terrestrial network and what NTN networks can deliver. So from a 3GPP perspective, we want to ensure that we are able to talk to those satellite networks. But when it comes to ITU, the requirement of evaluation, everything will have a different perspective. So we need to see how do we drive in those two forums separately and still achieve the goal of having a global broadband connectivity. When we talk about massive merged reality, it's not just eMBB. Someone would say, okay, we already have a 100 Mbps or a 200 Mbps capability, but if you really want to do XR, what exactly is XR? Is it just the throughput, or it is about ensuring a right latency and jitter when some user is operating and then he's talking to environment and then the projection of the content that is coming in? So can we merge some kind of a channel adaptability to the channel conditions? Can we do some kind of a sensing of objects moving around it? So it will be mix of multiple technologies which will help to make that massive reality coming in 2030. Next slide, please. So this is something what we are looking at is not just the standards evolution, but also we are looking at how network deployments will also evolve, because the moment when we say, okay, 2030 the specs are available, it's not that the operator will say, okay, today we have 5G, let's replace 6G in 2030. So we also need to say what operators will deploy from today and what features they will introduce by the time when we have the baseband radio and core deployed by 2027, 2029. And then when we launch 2030, 6G around the 2030 timeframe, we are not expecting operators to just replace the radio equipment or the core to put a 6G thing there. So they would want to see that there is a smooth migration and minimal investment to start offering 6G services. So this has to be taken care when we say what features or what we want to drive in 3GPP. So it has to see what 5G Advanced or Release 20 will have, and then what new features can we drive into the new release of 3GPP. So it is well tied with the business market, how it will grow around that time frame, and then what features are we trying to introduce into the existing deployment that will happen at that time. Next slide. So what we have been looking at is we will try to leverage 4 key pillars that we will be doing when we start developing the 6G radio access technology. Energy performance is on top priority when it comes to all vendors, whether network side or device sides or even operators. Everyone want to ensure that energy performance is on top priority, and how do we design and also in the specification, how do we show that there is a optimization done to improve energy consumption. That's on top priority. The second part is we'll continue to do evaluation over existing features and capabilities what 5G Advanced would have, what deployments would have already happened. For example, India's input from B6GA to 3GPP SA was India has just started rolling out NB-IoT or other IoT technologies now. We don't want them telling the market that now when we have 6G, please replace those IoT and we'll have a new IoT 6G technology. So they would want to ensure that when we launch 6G, it will continue to support existing IoT technologies. So that's again the way we need to see how we write 3GPP specification for 6G. The third important pillar part is the spectrum utilization. With every generation, not necessary, we'll also always try to introduce only in the new bands. We should be able to introduce 6G in the existing bands also. We have 3.5, which is a premier 5G band today. Over now to 2030, there'll be other bands added. So when we introduce 6G at 2030, can the 6G technology or a 6G waveform, whatever is being transmitted, can the operator launch in existing 5G bands also? So that is another fundamental design that we will take care when we start developing 3GPP. The fourth one is uplink performance. We have always been focused on delivering good eMBB, downlink and everything, but then operators have realized even industrial application they are looking at, there is also an important way to improve uplink capacity as well as performance. And this actually necessitates saying, is there a way, when there is an opportunity because we are jumping from one generation to another, can we try to change some kind of a signaling and other methods where we can improve uplink performances in the design of the 6G? So these are 4 pillars around which we'll try to look into this standardization effort in 3GPP. I'll have to rush. Can you please go to the next slide, please? Yeah. So this is the key principle that I was focusing on. So if you want to lead, this is how industry has been evolving over the last few months of discussion, talking to operators, other vendors, and see this is kind of some principal guidelines that we want to follow. If you would want to lead and contribute in these areas, it will be important that we try to see our innovations are happening to improve in these lines. The focus of 6G RAN would be to have a standalone architecture. So we need to see, are our research focused on existing 5G and non-standalone approach? Maybe then we are moving in the wrong direction. We'll have to see, can we innovate to ensure that 6G can operate in a standalone? So these are some guidelines which I would want to share so that from a research perspective or contributions that go into 3GP are a little bit aligned with what operators or industry is looking forward. Go to the next slide, please. Yeah, so this is again the important part that you could see. Global efforts are needed so that the new band that we are looking at is globally available, and then we focus our research into those areas. And one of the important part I would say is the commercial is in 2030, but already standardization effort has started in Q3 of 2024, starting from 3GPP SA workshop. That's a queue that what kind of services operator wants to offer. And similarly, in the next March 2025, it'll actually, we will be more close to what 3GPP specifications will look like. So those are places where we need to be very closely watching and contributing it if you want to lead in driving the 6G standards of it. Next slide, please. Yes, and I would want to say that how do we demonstrate our leadership is the first part. If you look at 2024, this is an Ericsson's view, how we will drive it. So around end of 2024 is place where we are actually trying to showcase some of the very pre-standardization test beds. And then there is a time frame around 2026 where we would want to actually show technology trials about new bands and all those capabilities. This is something which we need to see how much of these is happening within our country and our stakeholders who want to take leadership. I think we need to promote those activities. This is something which B6EA and Upadhyay just mentioned about the funds available, and also see that we have a lot of activities happening in those 2 tracks. Last 2 slides, yeah. So this is WRC 23. During November, we actually did some assessment of saying if we want to do 6G in a macro in a centimeter wave deployment, 7 to 8.4 gigahertz, we did an assessment saying how much of coverage is possible. And then in parallel, we started developing a baseband radio, which actually operates in the 7 to 8.4 gigahertz. So that kind of early activity is needed to show our readiness when we have by 2030. And this is a 6G UE that we have, which is in a small card compared to the one which we had in IIT Delhi during the pre-5G days. Yes, and this is another demonstration that we have been doing in MWC. Similarly, in IMC, we also demonstrated, we know AI is going to be a key integral part of designing 6G. We showcase that how do we minimize that AI computation power in a baseband if you want to use it. It uses a brain-like model to minimize the power consumption. So those are aspects I think we should not leave out of sight when we do contribute and lead in 6G, not just in standards, but also how do we implement them in our products that we want to build for 6G. That's all I have for the presentation. Thank you.
Hello. Thank you for sharing in the brief the various use cases. I think evolve, one of the message I can learn, and I think that is for the information of all, that is evolve 5G core, and there will be a lot of open interfaces. So I think we'll be going for something like open RAN, will not say right now, but something like that only. So thank you. Next speaker we have, and I think since Bhatia sir has given us just 1 quarter out of 2 days, but still we have the Spectrum, Mr. Ardito, Spectrum Group Chairman, GSA UK. So I think I'm inviting you, and please give us that what is specific to 6G. You have the message. For here, we have some startups also into India. Thank you. Welcome.
So thank you, and good afternoon, everybody. So first of all, I'd like to thank once more time IAFI for inviting us and organizing this excellent India Spectrum Management Conference. Actually, here I'm on behalf of the GSA. The GSA is the Global Supplier Mobile Association, and in particular here I represent the Spectrum Group, which has over 200 professionals worldwide. We are represented very well also in India. Actually, we have an India group of the GSA, which is led by Jitendra Singh from Qualcomm, and also we also have other colleagues, from Qualcomm that are doing a lot, and from Ericsson and from Nokia that are doing a lot for India. And actually, GSA would like to support really as much as possible India in taking really the leadership for the 6G development and deployment. We do think that really, like we were said before, India is very, very well positioned now to take the leadership and to guide basically globally on 6G. So we are very, really happy to be here, and we share the previous messages, on the participation on R&D, standardization. There are all the ingredients really in this big country, to be the leader on 6G. So let me just basically share a few messages, I just have this slide. So we see from worldwide, the research and development it is ongoing. The target is really to have a deployment around 2030. We know that, ITU is working on it. We know that organizations like 3GPP are working on it, they are contributing. So we do encourage really India to basically play a key role in that process, and we do think that it is already playing a key role there. In terms of important part of the story, the successful story to be realized is actually to enable spectrum to be actually deployed. And spectrum needs, 6G will need spectrum. There will need a combination of frequency band. Here we want to put the attention especially on the mid bands. And those bands, at least we would need in those ranges at least 500 megahertz per network. So that is really important to be achieved, and India, of course, has been supporting that quite a lot. The way to get it is, of course, through a WRC process, where there is an agenda item 1.7. There are 3 ranges which are important. GSA is really supporting for an MT identification the 3 of them, but we do really think that the priority for the industry is the 7.1 to 8.4 gigahertz. That will really be, the stepping stone, for having a great 6G deployment around 2030. And there will be also additional bands that can be considered. And those bands, they are not necessarily going through or will be going through a WRC process. They might be outside the ITU WRC 27 process. The standardization, of course, it is important. Like previously said during this conference, when we start approaching bands in the 7 to 8.4 gigahertz, there will be incumbents. Some of them will be a little bit more tricky to live with. So we have the huge opportunity in the standardization process to have the design of the new systems so that some coexistence, some sharing could work with those incumbents. So we are basically sharing a message along the lines of the previous colleague from Ericsson. What needs to be done? What are our recommendations for India? So really, we appreciate a lot India launching the 6G roadmap through the Bharat 6G Alliance. We really recommend to implement a 6G spectrum roadmap as soon as possible. This will give a clear signal to investors, stakeholders, to industry, actually, on the bands that will need to focus and to be implemented in R&D. The other important part is we really need to incentivize, and India would need to incentivize the creation, of a wide ecosystem. So all the policies and industrial initiatives that could serve that purpose would really be very important for India. And last but not least, we need to keep it to some extent simple in terms of technical complexity, and also we need to expand the business opportunities for 6G. So defining the policies from the government here to enable, to keep down the technical complexity and increase the business opportunities for those guys that are going to launch 6G is going to be vital for everybody. So, and with this, I mean, I would like to thank again for your attention, and thank you.
Thank you. Next, we have Dr. Vinod James, Director of Technical Standard, Qualcomm. I think he represented the device side. So whether you make any standard, I think we are dependent on him.
Yeah, thank you, Bhatia ji and Pathak ji, all for having me here in this afternoon. So as I rightly mentioned, I'm going to bring in the device side of the story, explaining, from a device vendor perspective, how we see it. But then I think if you focused on what our colleagues from Airtel and Jio pointed yesterday, they wanted it to be G agnostic, right? I think one of our colleagues was brutal saying that, this should be the last G. Going forward, there should not be any G, right? So lessons learned, what I did was I called it next G challenge. So you talk about any G, this is going to be, can you go one step back? Back. You talk about any G, these are going to be the challenges which will have to be addressed. There is coverage, there is capacity, there is the QoS which need to be met, deployment economics, spectrum, new spectrum, old spectrum, reforming spectrum, sustainability, link budget, new applications, monetization, right? These problems existed perpetually. The only thing was the electronics at that time mattered, the economics at that time mattered, the customer at that time mattered, and the use cases which need to be addressed mattered. So even if I solve a 6G today, 10 years back, when Bhatia ji hopefully calls me in this stage, I will show the same slide and say that I'm seeing the same problem. Right? So that's going to be unfortunately the reality, because the problems never change, right? So even when we are talking that, I want to do 6G, the main thing that comes is, what are you going to do different? Right? Apart from broadband, are you actually targeting new use cases, which will actually qualify for a G? So yes, as my colleague from Ericsson also pointed out, that we are talking about immersive applications. We are talking about ultra-wide area connectivity, all those things, XR, AR, VR, wireless edge, AI, right? All those things, which we are exploring today. Well, if I don't tie it to, what I had heard over the last 3 days, that, India 6G, it's about affordability, sustainability, and, other elements, it doesn't help. So what is Qualcomm's philosophy on how to make things affordable, right? What market economics teaches us is, broadband is the one which actually yields revenue. So if you are innovating in that space, focus on broadband, because you have a customer in there and you will be able to address that customer. So the commercial innovation part should be targeted towards that particular effort, right? So if I think the theme itself is, what should be India's approach to it? India's approach, in our view, is focus on 2 things: commercial innovation, focus on harmonized global standards. Why? Why? Because, India, the aspiration is not only to serve us, it's also to export. And the only way that is going to happen is harmonizing the standards. Second thing is, hey, Vinosh, what happens to all those societal things I want to do? Right? Because that's key. That's the whole thing, the India 6G program is all about. No worries. Ensure that when you do this commercial innovation, package stuff into it so that your societal aspirations can be met using a commoditized technology. That is key. Because if the technology is not commoditized, you are not going to be able to offer it at a price point which people from the global south or even the less affordable from India can actually do. Right? So those are key things in our view. Next element. What is the sustainability element? right? How do we ensure that, our things are sustainable, more elements come in, all those things? Qualcomm has a diverse set of options which we are looking in. One of thing is about spectrum sharing, right? Several flavors, can you use the same spectrum across services? Or can two operators actually share spectrum to basically deliver stuff, right? Second stuff, can I actually do infrastructure sharing, right? Because one of the key things India has also committed to is ensure that it will go green in a few years. But if you are actually doing a mad deployment of networks, then you are not doing green. You should actually find out opportunistically how to share infrastructure so that you meet the targets, but also meet the energy targets. And then these energy guzzlers are necessarily all those macro base stations we are talking about. So one of the areas which Qualcomm is actually working on is, can you actually miniature cells, and if needed, densify things, so that you'll be able to offer those stuff, right? So our sustainability challenge is about these diverse set of thoughts on how we do it. Is that all? Even in terms of on-device energy savings, we understand where we are today, right? Again, as Senthil was pointing out, when we move from 5G to 6G, we are not going to dump existing equipment, dump existing devices, and then go into a new batch. You'll be doing a gradual transition, which means 5G networks will be there, and you have to go into 6G. So you have to evolve thoughts, assuming that there is an existing network. So the areas in which we are currently exploring energy efficiency is, can you actually look into the protocol layers? Can you optimize them so you actually bring efficiency into the system, which will actually make things energy efficient as well. The next thing, it's about the deployment challenge, mapping it to the ubiquity thought, which India is actually pursuing. For us, it's not macro alone networks. It will have to be integrated, multi-tiered, multi-layered networks. There will be macros, there will be small cells. You have to integrate that with your Wi-Fi inside the home. You have to integrate with satellite if you want to offer connectivity. So Qualcomm's view of ubiquity is, you are making the cell separation disappear. Of course, you are having a lot more smaller elements coming to the network, but ubiquity is possible only when you integrate all this stuff, create one large cell. And in that large cell, your cell coverage, your average spectroscopy, everything disappears. So what is our thought for India on this thing? We are offering so many customer-centric services, right? So Vikram is in here. If you ask him, if I want to offer reliable UPI payment service, how much data rate is needed? So from a ubiquity perspective, the question that needs to be asked is, if I want to guaranteedly offer such a service, what is the minimum data rate needed? And with this marriage of several different technologies, can you ensure that that data rate can be provided with the latency so that your connection is not lost? That is how we are actually seeing this particular perspective. The other thing is, from a coverage perspective, again, we have done a lot of experiments. So this is from a New Jersey lab. What they did was they actually tested things on the 6 to 15 gigahertz band, specifically around the 10 plus band. And what we have proved using technology which is available today is, you can still deploy larger massive MIMO systems and meet the same coverage as the C-band which is operational today. So for us, coverage is assuming that the existing network isn't there, and assuming that you can only get more spectrum in the higher frequency band, how do you meet the same coverage targets, right? So that's where we are spending research and effort into that part. Moving further into it, integration of cellular and non-cellular. So we have a clear roadmap, at least within us, on how 5G Advanced and 6G evolves vis-a-vis NTN or satellite technology. And we are very clear that this interworking, integration or whatever need to be a day one feature. And what needs to be done so that it becomes part of the same device which we are able to offer. The last part is the timeline which we propose. So there is a spectrum timeline, there is a ITU timeline, there is a 3GPP timeline, and most importantly, there is an India timeline. There are just 4 asks we make so that India can lead that effort. Spectrum managers, please ensure that you identify spectrum and then make available experimental spectrum for anybody who wants to develop 6G technology. So that when they make it, they also tell the world that I'm making it available in this particular band. So if you have a bid, come to me. Second thing, you have societal problems which you need to target, As I mentioned, those societal problems need to be piggybacked into something which is commercial. ITU is a good place for that, yes, right? But you need to have those things listed today so that it becomes part of the, I will call a mill, right? If it's not part of the mill, you're not actually churning it out. The most important element is on the commercial innovation part, please, please, please facilitate partnerships. Don't discriminate. Don't say that, ye videshi hai, sudeshi hai. Enable partnerships, enable cooperation, and ensure that R&D is done in a competent manner. And the last part, similar to what we did in this year's IMC, offer them enough platforms to showcase talent. Go to IMC, go to MWC, go to, even if it is MWC Shanghai, please go. Show that you have talent so that you provide market opportunities for them. With that, I will conclude and I will look forward to looking at the panel. Thank you.
Thank you, Vinus. I think you have shared nicely, in fact, my Bharat 6G vision document itself, affordability, sustainability, and third part is ubiquitous. But I think that is your thought process. For India, I think we are looking towards something, ARPU, how can a technology facilitate less than $5? And then same time provide us connectivity and wide, like covering the rural part of India. Plus, I think an spectrum, if you ask me, because I am a non-technical person in spectrum, at least I don't know, how can I write my agenda for WRC 31? Because harmonization means someone has already written and someone is saying that India should harmonize. I will say that I will say make agenda and let the word harmonize. So I think we have to come to that stage if you want to be innovator or leader in 6G, otherwise again we will be follower. But that's a separate issue. I'm sure that it's a subject of Bhatia sir, so I think he will be taking it forward. We have heard, and I would like to thank first Mr. Ardito. I think I could not thank him. And one of the message was that India should incentivize the creation of 6G ecosystem. So thank you, sir. So we have heard this GSA part. Now the next we have GSMA. So I invite Dr. Stuart, Senior Director of Future Spectrum, GSMA UK, and I think he will share his views that how he feels that world is going and what is important for India. Over to you, sir.
Good afternoon, and thank you once again for having the GSMA participate in this event. A few weeks ago, we heard from the Honourable Prime Minister about India's leadership in driving the fastest rollout of 5G, but more importantly for this panel, about leadership and India's ambition to be a leader in 6G. I've been around since the days of 3G, and I must say it's remarkable what's happened here. In '95, right, the first mobile call, we're now over 1 billion subscribers, 640 million 5G subscribers predicted by the end of this decade, a 50% annual growth. It's remarkable. And now, the data speeds going from 300 to 243, now we're beginning to see some constraints in the network and the spectrum, which is, if we look back over the 30 years of development, that is quite a remarkable feat of political, economic, engineering technology. As we evolve from 5G through 5G Advanced into 6G, and I was a bit concerned we saw 7G on Qualcomm slides. We go from 100 megahertz in the mid-band, maximum channel bandwidths, we go up to 200 megahertz and possibly even 400 megahertz. So what is the plan? What is the spectrum roadmap to enable that opportunity? The Bharat Alliance and their recent spectrum report, I think, illuminates and paves the way for unlocking the spectrum plan. That Spectrum Alliance Spectrum report, it talks about, I think, a wonderful phrase called the golden bands. And if you want to have a look on page 38, that's where it is. And so I think they offer the key in the Barrett Spectrum Alliance report. Can we expand the 3.5 gigahertz band? Is that possible? What about the 4.5 gigahertz band? The potential to provide additional 100 megahertz carriers. It's tough, depends on the existing users, but is it worth examining those ranges? What about the 6 gigahertz range? We hear a lot about 6 gigahertz. That offers the potential for 5G advanced and its evolution towards 6G. It offers the potential for 200 megahertz carriers, for example, to future-proof that band as we move into 6G. That's another option. The WRC 27 bands, the 7 to 8.5 gigahertz range, that also offers a potential for 6G, IMT 2030. Depends on the usage of the band. If there are users there, how would we might be able to share that spectrum? And what requirements do we have on the technology to build in that sharing capability? And so we would look and recommend some of that spectrum is assigned in the second half of this decade, the 6 gigahertz or part of the 6 gigahertz, for example, to meet that capacity demands, but also let's plan for 6G spectrum. So what does success and leadership look like? Harmonization of spectrum, the harmonization of the standards, harmonization of the launch windows, of the regulations. I think that is a critical element to success. There's massive economies of scale and providing opportunities and a launch pad to go address those opportunities, not just here, but around the world. Not just hardware, but software-enabled opportunities as well. So against all of that, let's not forget some of those really other important issues. The coverage gap, the usage gap. Let's not just focus on data rates and latency. Let's focus on the consistency of the user experience across the network. And I am confident, the GSMA is confident that together, operators, the vendors, the universities, the governments, we can work together to achieve that thriving digital society. And I hope we can deliver the task that your Prime Minister set you and all of us to achieve that goal. So thank you very much.
Thank you. I think important message was that we should cover 100% with the 5G advance and then go towards 6G. Thank you, sir. I think I'm sure that this message is very clear and this is very close to government itself, because we are utilizing connectivity for 1 trillion digital economy. So it's a part of digital India. I'm sure that this will be achieved very soon. Next, we have a young scientist, I will say, because I think he has been even awarded by the President of India, Professor Radhakrishnan Ganti. I think claps should also be there. So, and we have proud of him. He's from IIT Chennai and really contributing a lot from the country. So,
first I'd like to thank the organizers, Bhatia ji, for having me here, Pathak ji and Upadhyay ji. So the 5 minutes allocated to me, 3 minutes I'm going to talk about technology, and 2 minutes I want to talk about leadership. People have been talking. I have my own views, a little bit stronger views. So 6G is coming. I mean, there is no denying it. We have just finished 5G. It's very airy to see that 6G is coming. We have to work towards it. There's a lot of hype at this point. There's a lot of hype and a lot of confusion also what 6G is going to be. But the more I talk to people, what I understand is there's a lot of law of inertia is kicking in, mainly because of the monetization of 5G I mean, it's from a monetization perspective, 5G, I mean, I don't know exactly, but what people feel is that 6G cannot be a very, very radically different from 5G. It's going to be upgrades of 5G. So one thing is 5G networks, for example, mainly, even now, are mostly dependent on broadband for monetization. Effectively, the money comes from broadband. If the same thing happens in 6G, I don't think there's going to be any difference between 5G and 6G. Okay, there's enough data speeds here. Of course, you have to add more users. More users is equal to more spectrum. That's a given thing. There's no innovation in that. The question is, how do we open verticals? How do we open verticals is what we have to focus on. 5G promised MMTC, URLLC in a large scale. For a lot of technical reasons and other reasons, it's not so successful. We have to understand why those failed, and that is what has to be enabled in 6G. We have to understand, we have to work towards enabling these verticals from the beginning. So if you look at ITU, what is happening at this point is ITU is defining KPI for 6G, key performance indicator. So again, the same fights are happening in ITU, whatever happened in 5G. People are trying to come together and come to a consensus of what should 6G be. Out of this, of course, a few things stand out. I mean, everyone wants AML to be part of it, including me. There's something called integrated sensing and communication. Of course, newer frequencies are going to come about, and energy efficiency. I'll just spend a little bit of time on each of this. So AML is pervasive. I mean, you can't have a conference or you can't have a talk without AML not being mentioned. It's going to come. There are two parts of AML. One is how AML is going to help 6G. Okay, so how it's going to better our communication, how it's going to improve our efficiency. The other part is, how can networks enable AML? That is actually a more interesting topic. If networks have to make money in 6G and you are going to have AML everywhere, how do you make sure that networks are tailored to support AML kind of QoS requirements? Okay, so a lot of work has to go in, and from now on, we have to start talking to the telco operators and other people to understand how this should be enabled. Integrated sensing and communication. One of the main key requirements for a lot of people is positioning, understanding your environment, okay, having a map of your environment. So this is absolutely, absolutely important. So one of my favorite topics is energy efficiency. Just now, one of my colleagues from, I think, Vinosh pointed out increasing the number of antennas from 256 to 1024, okay, at the base station. So what are the energy implications of this? Do you require a nuclear power plant for every 10 base stations? Okay, these are the questions we should ask. Okay, there's a lot of exciting work to be done in this regard in India and across the world. I mean, it's just not that we generally take blindly 5G, put more new frequency bands and paint it and call it 6G. I mean, that's not exciting, that's not exciting. Okay, it's just like, it's just a rebranding of 5G to 6G. That's not what we should be doing. We should look at fundamental problems. We should look at fundamental problems of energy efficiency, coverage. We should tackle them head on. That's when 6G is going to come. Otherwise, it's just going to be one more DAD-G. Yeah? Okay, so this is on the technology parts. I also want to talk a little bit about the leadership. What does it mean for India to be a leader in 6G? What does it actually mean? Does it mean that we just deploy 6G in 2030 and clap and pat among cells and say that, oh, we are leaders? Okay, I don't think that was the intention of our honorable Prime Minister or anyone who's speaking about leadership. It means that we should have a significant stake in 6G. Okay? When are we leaders? When we have companies that produce our own equipment in 6G. When we have chipset companies that come from India and we supply them globally. So 5G, I mean, 4G BSNL is a very successful thing. CDOT, Tejas networks have deployed BSNL networks. So we now have expertise in building networks. Our own homegrown networks from scratch, from base level. We can build 5G radios, we can build 4G radios. They have demonstrated it. So what is the thing? So I think in what we should do as for 6G, at least from an Indian perspective, we should all get together. We should have a roadmap on how we should have products by 2027. For the spectrum should be identified. Government should enable that in India, this spectrum is going to be in 6G. By 2027, we should have an idea. It cannot be done in 2030. That's not the right time. 2026, 2027, we should have a clear idea of what spectrum is. We should then start building devices. We should start building network equipment for that. Indian companies should be doing it. Okay? So in 5G, in 4G, we have BSNL. One third of the operators are now at least Indian equipment. Hopefully in 6G, we see at least 50% of the operators using Indian equipment. I think this is absolutely necessary. Some people may disagree with it. I think that's when we become leaders. I don't think we become leaders by deploying 6G on 2030. I don't think that's the correct way of looking at it. So for this, spectrum is a very important requirement, and we should have clarity on this as soon as possible so that we can start thinking about how to build our devices, our networks, and take this forward. Thank you.
Thank you, Professor. I think you have explained that by 2027 all should be clear about the spectrum and I think other bucket. Now I think I come to, should I take one VC or VC at the last? Okay, I sent the VC. Then I think Mr. Jisnu, he is a principal product architect Tejas Network. And I think he has also, along with the TCS, CDOT, so Tejas is also given this, that they are the largest one can say are one of the 5th in the world in case of 4G and subsequently 5G will also be there. So I'm requesting Jisnu that you please also limit 5 minutes. I think then we can have certain, at the end, the questions.
Thank you, sir. Thank you, Bhatia sir, for inviting me. I'm sorry I couldn't join in person there. Thank you, Bhatia ji and Pathak ji for calling me for this session. So I would be covering basically how India is taking leadership in a standards place. So I would also in between tell what Tejas is doing as a company in some of these verticals. So can we go to the next slide? So we started with in the standards to sort of come out with the framework document. So I think in this same panel, Radha was there and Professor Kiran from IIT Hyderabad. So few of us had been participating even from 5G, and so this helped so that we were much early this time, right at the time of framework, we were able to provide contribution. We are very happy to align the IMT 2030 with the India 6G vision. With our effort, we could get ubiquitous connectivity, at least in WP5D. Here, it's mostly from a terrestrial perspective. This was added as a usage scenario. And in addition, in the new capabilities, which you can see on the right side, we had added coverage. This was one aspect we had mentioned even in 5G days. Maybe had people listened to us that time, we may not be having such a whether we need other G. So we couldn't do at that time, and hopefully this time the global ecosystem would listen to sustainability and ubiquity. So ubiquitous connectivity is added as part of the usage scenario. Coverage should basically allow, mostly if the handset uplink coverage, this is the major issue. So if the uplink coverage can improve, hopefully the cost of the equipment would come down. We have also added interoperability. So maybe multiple vendors can work together and reduce the network cost. So both of this should help in the affordability aspect, though it's not mentioned as a like from a standards perspective, it is not mentioned separately. Third thing is sustainability, as the key pillar there is energy efficiency. So we also try to quantify it as part of the standard. So hopefully we will see more of it as we discuss the minimum TPR number. So the key thing of affordability, sustainability, and ubiquity is part of now the IMT 2030 framework document. So that was the first leadership which India did in the standards. From Tejas' point of view, we have been working, as was mentioned by other participants in the panel, along with CDOT and BSNL. We have started rolling out 4G and we have started the trials on 5G also. in Delhi. So if you may be connected, if you are having BSNL SIM, right now it's not public in the sense you may be even able to connect to a 5G from BSNL. So we have done the initial deployments of 4G, 5G is being rolled out, and hence we would now take the leadership from a 6G perspective. Here we have also done something parallelly. It's not specifically with the IMT or 3GPP based technology. We are rolling out the largest, maybe the world's largest IoT network based on satellite. So this is being used by fishermen in the sea to connect through an ISRO satellite to connect to the NOC center in Hyderabad. So through this, the fisherman would be able to contact the Coast Guard in case of any trouble. We have also implemented within that a mechanism whereby whenever they cross the border, they would get alarmed in the sense they would get a beep voice, so they don't cross the border. So if you are from India, you would know this is a big issue both at the Pakistan border as well as at the Sri Lanka border, which actually causes fishermen to be shot at. So this is one issue which we have tackled, and we have been using a satellite technology thanks to ISRO. We have been able to roll it out. This is not for commercial purpose. This is non-commercial. And this is one of the key part of the ubiquitous connectivity, which we would hopefully see on the non-terrestrial part of it. The terrestrial, we would like to improve the coverage. So one of the technologies which we have been keenly working on, and I know IIT Madras also is working on, is what is called the reconfigurable intelligence servers. So initial trials were done. In the IMC, we have even shown it as in part of our booth. So there are some improvements. So we would have to see how good it can be in future. We are working on integrated sensing and communication. So there are some initial deployment cases which are being discussed in 3GPP. On the AI and communication, we have been seeing whether we can sort of switch on and switch off AI, because there are a lot of concern on the ethical part of AI that we also want, at least in the first release, an ability to switch on or switch off AI, just to show that, like, yeah, just to make people comfortable with AI in the network. On the second part, on network for AI, I think there has been a lot of discussion earlier also. So that would be enabled, but we are also looking for AI for network. Specifically, what we are seeing is when we are doing CSI compression, which is the channel state information, we are seeing significant improvement. And as was mentioned, I think earlier also, the one way of increasing capacity is to go for higher MIMO. So we are also seeing how can you do higher MIMO, but in which case your channel state information becomes a lot more. So we are seeing how to compress it. Other issues with respect to how to, one of the thing which Professor Radha also mentioned was positioning. Can I use AI for positioning? So this is another aspect which we are looking for. And even beam management is quite complicated in 5G. So can we offload this problem also into AI? So these are few things from Tejas' point of view we are looking. On the sustainability part, energy efficiency is a big thing for all the equipment vendors. As was mentioned by Ericsson, it's a key problem for Tejas and for anybody, all the people who are on the panel from the network side. It's also a device problem, but in the network side, we are just seeing if you are scaling up the MIMO, how can you still be energy efficient? So this is one. So there are efforts to see whether I can do on-demand SSB, even the initial pilots or the SIP messages, etc. Can it be made on demand? So this is another thing which from Tejas side also we are looking into. So we are just seeing both at 3GPP and ITU just to see that all of this would enable an affordable system. And finally, it is ubiquitous everywhere. Can I go to the next slide? Yes, specifically coming to what had happened in the last 4 meetings. Meeting 44 approved this vision document, which was the key to palette diagram and the wheel diagram was shown in the last slide. Coverage capability was added and the framework itself was approved. Meeting 45, we had submitted the first draft for the technical minimum TPR document. We had suggested a table on how to map the usage scenarios and capabilities for the evaluation purpose. 46, we have started, we are looking at specific test environment, including one test environment from India. So we have suggested what is called a rural UC test environment, rural ubiquitous connectivity. This again, because it is in WP5D, this is with respect to the terrestrial. So we have suggested one test environment. We have given initial metrics on positioning and sensing. We have suggested both this aspect, which was also mentioned by Radha, on AI for network and network for AI. So that discussion is ongoing. In the last meeting, meeting 47, we have given the evaluation document also started, effort has started happening there. So we have provided test environment there, which is the rural UC case, and then few more test environment for ISAC, both rural ISAC and an urban ISAC. We are also mentioned a table, which is to say with or without AI, how does it work? And this is as part of the AI and communication vertical. And we finalized the process. So there is that document anyhow got finalized, and in part of it, that all the timelines are sort of clear now. So hopefully by 2030, there should be standards, deployments, and spectrum as part of that process. Can you go to the next slide? Yeah, so this I think was mentioned by others as well. So we have a standardization window which is from 2024 to 2030. So this would involve two levels of work, one at ITU, which would be driving the administration level, what are the requirements, especially with respect to the ubiquitous connectivity, AI and ISAC. The other thing in parallel, I think many of the people from India this time has been participating in 3GPP. At least from Tejas, we have close to now 30 contributions happening right now as we speak. So I think I see multiple other universities, whether it's IIT Madras, CVIT, IIT Hyderabad, Kanpur, all of them have participated in it. So the participation in 3GPP has also significantly improved. And the quality of contributions have also quite significantly improved. And hopefully, at least from the standards, we would be able to lead. And hopefully, as Radha mentioned, leadership also means like we eventually have a lot more of deployments of Indian equipments, both in India and globally. And we also make significant improvement from what we have today with respect to the KPIs to what we would envisage as part of 6G. Thank you.
Thank you, Jisnu. I think this is I just want to say that even within 3GPP also, there are more than 55 members from India participating. So earlier it was just some in single digit or maybe just maximum 12 to 14. And same is happening at ITU Working Party 5D also. So I think that will be perhaps one of the lessons that how can we further more increase it and make it a consistent participation. Now let's, I have Mr. Prashant Kumar, DDG from TEC, and he is also known for his voice, which is I think is specific to some reforms. So let us listen him also.
Thank you. My thanks to IFAI for inviting me, and thanks to everybody in the panel. My friends, I think I will be I'm taking you to your thought process, to a divergent view, not exactly on technology, but something else. Like, first of all, I would like to talk beyond funding R&D. Everybody thinks like, just we need to spend a lot of money on R&D so that we'll become a global leaders in 6G, 7G. Is it true, or is it just a fascinating idea that is troubling us? So basically, my scholarship is on governance. So policy nudging, wealth creation through policy nudging. This is a very beautiful subject, actually. So we have to create a policy. We have to create opportunities for the finance guys, institutions, and research scholars. That is how R&D happens. Everybody is keeping a pile of money in their pockets and waiting for good opportunity to put their money because they want to earn money. At the same time, there are a lot of innovators, scientists, fascinating, and they are very eager to create something new. But we just have to join both of them, make them sit together. How will they come? Unless we meet their interests. So as a government, I really appreciate the new India that under the leadership of Honorable Prime Minister. Like once upon a time, it was like a ice-maddening bureaucracy, very strict, honest, like we don't want to talk to private guys. But today it is changed, like a lot of us sitting here with you and seeking your opinions. So it's a tremendous change in the Atmanirbhar Bharat, all these things. Anyhow, so now if I just made some kind of comparison I'll share with 6G Alliance guys. I did some kind of a small research through going through some kind of documents available in the public domain. So now, if we have to become a leaders in the 6G, what we should do, where government should invest, where institutions. The strengthening of institutions is the fundamental reason for any development of any technology. For any nation, for that matter, we have to strengthen institutions like for standardization and standards development. It's really improved in India. We are doing lot, especially in DOT, many things. As I appreciate Dr. Upadhyaya and his sincere efforts. Testing and certification. See, like, unless we will be able to, I just made some comparison, like, to the different nations. I picked few nations like India, USA, South Korea, and, like European Union and China, how really they are effectively doing. Where are they in 6G? Leave apart other innovations. So another thing is IPRs and SCP facilitation. Unfortunately, presently, we don't have lawyers to draft FRAND agreements. There are no lawyers available in this country. This is where actually we have to invest. Government has to invest, We'll have to create legal professionals. And then environmental social governance, nobody bothers. We are designing, but environmental social governance policies, are we ready with the environmental social governance guidelines for 6G? And are any kind of, especially in telecom sector as a whole? And we will have to evolve with the global needs. Today, environmental social governance are putting everybody into litigations. Tomorrow we are emerging into product passports. I designed a beautiful product in India with CDOT does. They are very capable. But if it doesn't have a product passport, he can't export. Tomorrow the governance, the trade governance is changing, global governance. So are we aligning with them? So like that. And supply chain resilience, logistics, and intersectoral innovations. We should work, 6G is, when we claim it's ubiquitous, we should work right from the local government bodies. Like, how are they going to use the 6G for them? It is easy to transform the civilization. We are emerging into new civilization. I really like the way our Honorable Prime Minister says, like in India is AI too, because as artificial intelligence, aspiration India. So it's really, we are all aspiring at village level to grow. So we'll have to collaborate with the local governances and, social reformations to utilize the available technologies for the social equilibrium in the society and happiness. And then simplified legal structures. Why not we think of creating technology courts? Because when there is a technical disputes happens, if we keep on struggling, even judiciary won't be able to understand the level of AI, the level of trade intricacies that happens within the technology innovations. So I think you all know how the FRAND is creating trouble entire the world, Entire world, the SCP, Standard Essential Patents, are creating trouble. It's creating a lot of legal litigations. So where are we? Like, why can't we create a special courts for that? Like family courts, we create a special commercial court we create. Why not we ask Supreme Court to create a few benches for only technology courts? And geopolitical alignment, it is something MEA has to do, like really it's very, very important. Without that, we'll not be really leaders in 6G. And semiconductor dominance, I think Professor Ganti was also mentioning, like, from material science onwards. And social development preparedness. So we will have to, when we want to embrace the new civilization that is coming across the globe, we should be prepared socially and industry preparation, like trade relations. So these are the places I just did some kind of study on this. I think these are the places where we'll have to involve and suggest government to come up with a policy nudging. That is how the wealth creation happens. That is how the innovations happens. Thank you so much. It's a little bit divergent. I'm sorry for that. Thank you.
Thank you. I think Ajay told that he will be sharing his thought process, and which is more reforms oriented. Thank you. I'm sure that you are still within the government, so you can do a lot. We are now outside. So thank you. Next speaker, we have Professor Paresh Saxena, and I just noticed that I think he has done not only just been professor, but I think earlier also he has industry experience. So I'm sure that I think he will share his views, how India can be a leader in 6G. So now over to you.
Thank you, Pathakji, to introduce me. I would also like to thank organizers and Bharatji to invite me here. And as per the closing remarks of the last session, where Gulatiji said that if you consider integrated satellite and non-terrestrial networks, sky is the limit. I'm going to present one of the use case or one of the applications talking about the edge computing and how the distributed intelligence or AI and ML can help in achieving goals. So I'm from BITS Pilani. We have 5 campuses, 4 in India and 1 in Dubai. I'm from Hyderabad campus, from Computer Science and Information Systems Department. And I head the group who works in intelligent networks. So our research group works on the integrated satellite and terrestrial networks, as well as looking into the application of artificial intelligence and machine learning on that. So I will skip this slide since all of my colleagues have been discussing about the 6G vision and the KPIs, and lucky to be at the end so that I can move fast on the topic. I would be discussing these 3 key technologies, starting from multi-access edge computing, integrated terrestrial networks, and artificial intelligence. So there are, of course, several key technologies to enable 6G, but I will cover these 3 of them in this my presentation. Now, talking about multi-access edge computing, if you see on the left side on the top, if you're sending a data for computation at the cloud, there is certain latency involved, and just with some rough calculation, you'll see that 30 milliseconds may take roughly. But if you can bring that computation closer to the device, closer to the end device, it could reduce up to 10 to 12 milliseconds. That is almost half of the latency with the help of edge computing. And edge computing is one of the technology that can help 6G to achieve its vision. At the same time, what you see on the second part is integrated terrestrial, non-terrestrial networks. And we have a last very good session on that. So I will just introduce that. This is network of networks where you have satellites, UAVs, HAPS, and terrestrial networks that can together work for several applications. And the important thing is that when we talk about the intelligence, intelligence cannot be limited to any specific element. It has to be distributed, and all of the different elements have to take care of it. When we talk about the distributed intelligence, that means all of these different elements have to integrate, have to pass information, and there have to be protocols to be developed. There have to be technologies to be developed so that integrated networks can work together. And finally, talking about the machine learning and AI, and specifically reinforcement learning, this is one of the key technology which can work in the unknown environments such as the SATCOM and UAVs, and we can have a distributed, efficient allocation of the resources in this integrated networks. So moving on the slides, I will quickly cover that edge computing does not bring only the computation benefit, it also brings both caching and communication benefits. So bringing computation closer to the device does not mean that only computation can be assisted, but you can also have low latency communication as well as caching services. And computation is required. So when we talk about AI and artificial intelligence and machine learning, we need computations. This computation is required, and we need to identify the locations where these computations can be done. I listed a few of the benefits, including reduced latency, increased availability, enhanced security, and as well some of the use cases which are being very, where MEC or edge computing can be used. Talking about the specifications, 3GPP, there are already technical specification document in release 17 talking about the MEC architecture, application, security, and other things. So MEC as a field, as edge computing as a field, is growing. Coming to the second one, non-terrestrial networks, that includes both the spaceborne and airborne, that means the satellite networks and the UAV networks, as well as HAPS. And non-terrestrial network brings the benefit of not only the connectivity, but also scalability as well as non-real-time responsiveness. In the context of 6G, I've also listed few of the key roles where NTNs, or a key role for NTNs to enable 6G. And talking about the standardization and market growth, there are a few numbers which say that there has been a CAGR of 9.5%, which is expected from 2022 to 2030. So that shows that there's a lot of growth in these two verticals, edge computing and non-terrestrial networks. So idea is, can we bring this together? Can we bring these two verticals together for the efficient communication and reliable communication? These are 4 figures which you will see that how NTN elements can help in the context of edge computing. So it is not only about computation, but you can see that NTN elements can also relay the information to the terrestrial networks or to the cloud centers. Because again, talking about the introduction of AI and ML, the computation is required. And hence these locations are also important to identify. I will skip this 2 slides. This is more specific to the algorithms. And if you're interested, we can, of course, talk after this session. These are more regarding the algorithms and what are the distributed approaches that exist where all these elements can be brought together for efficient decision. And these are also of some of our work where we have shown with the initial simulations. You see that horizontal line is something what is happening right now. And these are our publications which is listed, which have shown by simulations, of course, that using these distributed approaches, we can achieve, theoretically, of course, a higher cost, a lower cost, that means a good latency, a good combination weightage latency as well as computation. So just my last 2 slides. So I would like to also mention the challenges and opportunities which are there. Of course, the implementation of these new technologies comes with a price. It is very important to understand how the data can be collected. Now, this is unknown space where the data is not there, and if the data is not there, it is not that straightforward to use machine learning techniques or artificial intelligence techniques. As well as, we also need to understand that when we talk about the SATCOM, satellites, the UAVs, they are resource-constrained devices. So how you can optimize these algorithms to work on this is also a key question. There are, of course, several emerging use cases of integrated satellite and terrestrial networks using edge computing in smart cities, blockchain, smart agriculture. I've also listed our paper here in case you need to know more about it, you can go through it. And my last slide is on that we are going to have a Wireless World Research Forum in February from 18th to 20th, chaired by Nigel and vice chaired by Bharatji himself. We invite you all to attend this event. We bring industry, government officials, and academicians from wireless field, and we'll be very happy to see you there. Thank you very much.
Thank you, Professor, for, I think, sharing. First time, I think I saw that from academia, you are moving slowly towards, one can say, closer to industry. So I think I'm inviting you that you join and bring similar, some mindsets that we can work this TN NTN integration in so many products. So thank you, and I think if you give more details, then I think we'll be joining your events in Feb. Now we comes to the next speaker, Professor Rajiv Sore, and he has been a good friend of, I think, most of the persons here. And right now, he's a director of Triple IT Surat. So, sir, I think we would like to hear your views also. As a director, I think what is now your, in a new role, how can you see that how India should take this position towards 6G?
Yeah, thank you so much, Pathak ji. I hope I'm audible.
Yes, sir.
Yeah, I hope I'm audible.
Hello. Yeah, sir, you are audible.
Yeah.
Very much.
Okay, thank you. There's been a network issue here. Thank you so much. At the outset, I'd like to express my sincere thanks to Pathak ji, Upadhyay ji, and of course, Bharat ji for the kind invitation. Unfortunately, I had to miss this because of pressing engagements in Surat. It's just overwhelming. But so unfortunately, I really missed the, meeting good friends and thought leaders there. But I'll certainly try to make it some other time. What I'll do today is, we've heard in the last, since the beginning of this very interesting session that I've been making my notes very religiously. I think we heard some wonderful, trends and landscape and technology, thanks to Vinoj, thanks to Radhakrishna Gandhi, Jishnu, and many other colleagues of ours, friends. So they've given a wonderful technology overview in 6G, and I think that's really something that is, there's a lot of learning over there. I'm not going to repeat whatever has been said earlier, so I thought I'm going to probably talk about aspects which are different from a different perspective, from a different angle. So my thought was to look at the use cases and something that we are doing over here and that we envisage implementing in course of time. So next slide, please. So if you could please move to the next slide. Thank you so much. So, I think I'm not going to repeat this, but a lot of great, talks today in the 6G technology, 6G enablers. So one of the things that is very clear is that 6G, with this plethora of features and characteristics, is going to really, enable a large number of, it's going to really cut across a large number of verticals. In fact, I don't think there's any vertical that we know that are not going to be, by 6G, whether it's transportation, autonomous being, whether it's manufacturing, healthcare, education, and the list goes on and on, right? So what is clear is that every vertical that we can think through, and if we do a deep dive, we'll see that there are a lot of, features or characters of 6G that are going to really ensure a high performance of that particular set of applications in that vertical, right? So let me talk about two specific use cases. I'm sure all of you will appreciate that at the end of the day, we really have to see the application layer and let us see what are the key enabling use cases. Many a time we actually grapple with what are the relevant use cases for industry, right? That will really fetch ROI, that are going to give us a lot of visibility and traction. And that's also where there's a lot of challenge, because the lower layers are getting developed as the standard is evolving. But I think it's also very important concurrently to look at the higher layers. So if you look at the next slide, I'm going to focus on two specific aspects very quickly. So the one is education. I'm going to talk about very quickly, but I think it's a very important sector for all. And I don't think I have to convey this to my eminent colleagues in the room there. But the other thing I really want to mention is we've just begun to work on Industry 5.0 from the point of view of 5G and 6G technology, right? So I'm going to throw some highlight on smart manufacturing enabled by 6G. So I think that's where I'll spend about good 4 to 5 minutes. But let's very quickly look at the education sector and how 6G is going to really make a big difference there. Next slide, please. So if you look at what I tried to do was on the left side are all the 6G, the key characteristics, if you will. And on the right side are some of the, and I repeat, some of the important use cases in digital education, in education as of the future, if you will, right? Now, if you look at the right side, right, whether it's XR-enabled learning platforms or whether it's infrastructure for distributed administration, we've seen a lot of hiccups over there in the last few years, or compliance management, and of course, immersive and interactive classrooms of the future, accelerated quality and adoption of immersive learning. And then, of course, now a lot of even startups are talking about personalized learning experiences. It's kind of very clear that the 6G characteristics, whether it's not just about high speed, high bandwidth. It's also about many other characteristics that you see over here. Energy, in fact, a lot of our colleagues were talking about sustainability and extremely low energy costs and minimizing the energy footprint. Whether it's that or extremely high reliability or extremely low latency, massive connectivity and large coverage, what we will see in the future is that you are really going to enable global distributed pedagogy classrooms, right? And that will be in real time, because if it is not in real time, we're really going to not enthuse our population, the learners. Now, how do you enable a distributed real time, call it a test bed, education test bed, where you have, let's say, subject matter experts from all over the world, for example, over here now, talking about not just talking about technology, but also demonstrating their POC online. And I think it's clear that 6G is going to play a very, very important role over there. We are beginning to see POCs coming out, not in 6G, but in 5G, of course. And I think it'll be anyone's guess as to what are the additional use cases over here in education. But I personally trying to ensure a very smart institution going forward. As many of you may not know, that the number of IITs and triple IITs that we have in India now is just, the numbers are so large, and everybody is struggling with trying to ask, what can we do to make a global impact? And again, I want to echo what my eminent moderators and chairs mentioned, that one of the key objectives of the Honorable Prime Minister is internationalization of education. And so that's something which will also be enabled very efficiently by 6G. So here is just a very high-level peek at what 6G can do, enable, how can it enable smart education. But let's go to the next slide, where I'll spend just a few minutes on what we have been looking at. I'll start with Industry 4.0, and I'm not going to talk much about it. I think all of us, all our eminent speakers and colleagues are aware of what Industry 4.0 is. The takeaway from this slide is that there are a plethora of diverse technologies that enable Industry 4.0. But what Industry 4.0 did not realize was that it's also about human-computer interaction. It's also about the human element, number one. It's also about the sustainability, which is actually critical now because of all that is happening around us and has been spoken today also. And it's also about resilience and robustness, right? So as we moved ahead, I mean, if you look at the last few years, and that's the next slide, you will see that there's a lot of, look at the next slide, please. Yeah, so it's kind of clear what the key benefits of this whole revolution of Industry 4.0 was, right? We wanted to increase the end-to-end efficiency. We wanted to maximize the performance. We really wanted to also ensure, to some extent, very high levels of flexibility, customization. But primarily, the three key points were the three key enablers of Industry 4.0 was maximizing performance, efficiency, and minimizing the cost. Because today you go to any industry, the first thing they'll ask is, well, we love Industry 4.0, but can you show us some tangible benefits in terms of cost reduction? So we've seen that even in our own test bed that we had built earlier, that clearly if you deploy these technologies very efficiently, and you think through, for example, how many, where, and all that, of course, is a given, but you have to eventually show the benefits in terms of performance and efficiency maximization and cost minimization. So that we have seen, right? But this has now evolved to what the next slide shows is Industry 5.0. So if you look at that slide in front of us, the 5.0 is where we are now. We're talking about human-centric, paradigm. We're talking about resilience and sustainability in every sense. Because without that, I don't think, whether it's government credits or whether it's even the long-term, success of industry, it's going to depend a lot on can we quantify sustainability. So the 5.0 is really a very, very interesting paradigm for 6G. And that's my next two slides, and I'll wind up after that. So if we look at the next slide, you'll see that what we did was that we have a factory floor, it's an assembly line, or it's a manufacturing plant, and we are trying to map the 6G features and characteristics to the select use cases in 5G, Industry 5.0, right? So we are mapping the 6G characteristics to the Industry 5.0, and we call it a 6G as enabler of Industry 5.0. So whether it's speed and efficiency, which of course is, thanks to the 6G characteristic, or whether it's human centricity or sustainability, you'll see that 6G will play a huge role over there. What we've done then is in the next slide, we've listed specific interesting use cases on the right side, just like the earlier slide. And on the left is, of course, 6G characteristics and the features. And we try to map them on the right side. So if you look at the right side, clearly you'll find those, those diverse use cases in smart manufacturing, which is really 5.0 now. And that is all the way from enabling industrial automation to high performance and high precision manufacturing to asset tracking. Digital twins, as we all know, have been there, but I think they're becoming more and more complex. They're becoming complex because the current factories are complete, there's automation, there is intelligence. And so having a digital twin which scales, number one, number two, which has superior features than the legacy digital twins is again ideally enabled by 6G. And then of course, it's known that immersive interactive technologies like our XRs, the holographic type communication, and so on and so forth, which 6G brings to us, are going to play a very, very big role in smart manufacturing. And I think this is not surprising to anyone, because I really want real-time feedback in my smart manufacturing plants and assembly lines, so that the process is absolutely very nicely automated. And finally, we are now seeing the advent of cobots, collaborative, arrays of robots in a smart factory. This is not, this is something which is, we are seeing that in the large plants, whether it's Germany or Japan, and even over here in the car manufacturing plants. So we are seeing the advent of cobots, and therefore there's a lot of distributed computing and communications going on over there. That again is going to be immensely impacted by 6G and the features that 6G gives us. And finally, sustainability, and whatever we do over here has to be a sustainable solution. But I think a lot of us talk about sustainability, but the time has now come to really quantify the metrics over there, the critical metrics in sustainability, as even Radhakrishna pointed out, whether it's minimizing energy footprint, communication energy, computing energy, various other aspects, and ensure that 6G indeed does that, delivers that. So in summary, we are starting a center of excellence over here in partnership with very, very large conglomerates, global conglomerates. It's early days, but the objective is exactly what you see in this slide, to look at 5G, 6G, and see how they will benefit Industry 5.0. That work has started, and I'm very happy to share the progress going forward with all of you in the room. My last slide, please. Next slide. So my concluding remarks are that it's clear that 6G is going to be leveraged by almost all the industry verticals. And I don't think there's any vertical that will be left behind for obvious reasons. But I think more importantly, I want to highlight that it's critical that not only we define use cases, that of course is a given, but how do you map the features that 6G brings and what do we map, how and what to the use cases? At the end of the day, we really want to reap the benefits, right? And not just use it for the sake of it. So I think that mapping after defining very clear use cases in any vertical is critical. There is, of course, as many of you mentioned, dire need to define use cases in the Indian context. In fact, that's this is also the topic of this session, India's path towards a successful leadership in 6G. But I'm sure that, if you look at even our Bharat 6G Alliance Mission document, there is a lot of discussion in that document and other documents about rural, semi-rural scenarios with limited connectivity, limited spectrum, very cost effective, very, very cost sensitive. And how do you enable 6G there? Finally, I'd like to mention that there are a lot of challenges. There are good things. It's a great time for all of us, but there are a lot of challenges that are open research, open research challenges. One of them is cybersecurity. I think it's very important that many of us look at the security aspects of 6G, including privacy. Because if we find that the attack vectors and attack surfaces are large, then that is going to really be, a sore point in the 6G ecosystem. So I think there are many open research problems over here, but one of the things that really concern and also excite us is cybersecurity in the 6G ecosystem. I'm going to stop here, but I'll be very happy to take any questions now or later on. Thank you so much.
Thank you, Professor. I think you have explained very in simple words, smart manufacturing education. That was even education for me also. And concluding remarks. Now we have the last speaker, and let us welcome Professor Monisha Ghosh. She has been waiting. I'm sure that it's the good morning, perhaps. So good morning, Professor, from all of us. And I think we are grateful that you are still connected. And we would like to listen from you, what is your thought process on India's, I think, 6G march, as well as how you see the global vision.
Okay, can you see my slides?
Not yet. I think please put her slides.
Okay, no, I have them.
Yeah,
can you see them now?
Yeah, we can. Yeah, no.
Okay, thank you very much. So thank you, first of all, for inviting me to speak at this session. As the very last speaker, it's always hard to know what else you can say. We've heard some really nice thoughts, lots of ideas about technology, use cases, spectrum. I'll talk a little bit about what I see as a big gap and I think Professor Ganti mentioned it a bit. How much have we really learned from our experience with 5G? We are rushing off. 5G is beginning to be deployed. In the US, it's been deployed in many flavors for a while. But why should we be doing more MIMO? What should we be doing that makes 6G different and useful, right? So one of the things that we've been doing in my research group for a few years is my students actually go out into where 5G has been deployed, and we make very detailed measurements. So these are not just throughput measurements. So all you see about in the press as to how good 5G is somebody runs a speed test. In fact, somebody told me recently that the killer app for 5G is the speed test app, because everybody just wants to see 5G, okay, how much speed am I getting, right? But as technologists, as researchers, we really wanted to understand how are all of these features we put in really working. So we've come away with some really good lessons, which I think should inform what we think 6G should be. One of our main conclusions so far, midway through the 5G deployment, is that most of the improvements we are seeing in throughput is just coming from bandwidth. The advanced features such as MIMO, multi-user MIMO has not been deployed yet. has not really materialized. The spectral efficiency on this curve over here, what you will see is the spectral efficiency measured in throughput per bits per second per hertz per stream. These are all the different bands we measure. These are the NR bands, LTE bands. And you'll see that NR, except for this one case, which I will talk about, hasn't really made much difference over LTE, right? So what did we actually achieve with 5G? This particular case is T-Mobile. They are deployed in 2.5 gigahertz. They are much better for two reasons. They are actually employing all of the beamforming capabilities that 5G has. Verizon and AT&T are not. And they have deployed very densely. So the number of base stations per unit area, and these measurements are from dense areas, Chicago and Minneapolis, two big cities in the US. So when I hear, Qualcomm or Ericsson or others say that when you go up to 7 gigahertz, you're going to get the same footprint as in 3.5, I say no, that's not possible, because I see over here N977 is 3.5, N41 is 2.5. There's a big difference in spectral efficiency. So one of the main conclusions is that let us not try to believe that we can go up to 7 gigahertz and we won't need to densify. We have to, especially if we want to deploy advanced features like MIMO. The bars over here show you the relative usage of things like MIMO levels. Somehow the labels got mixed up over here. But 4x4 MIMO modes. Most of the time, what you'll see is you have two. You barely get 4x4 in a very, very, very few cases. So again, why are we trying to increase MIMO modes? Why are we trying to go beyond 4 streams? You can go to bigger panels, but let's not try to push this beyond 4 streams, because there are limitations on the UE side. Your phone is not going to have more than 4 carriers. So I think we should really pay attention to understanding better as to how 5G is working. And now what I'm showing over here is 5G in the US. I would strongly urge academics and others to do this kind of work in India, because the propagation conditions, your deployment conditions, your powers, your heights of antennas are all very different. So let us try to truly understand where the advancements lie. The other thing I want to talk about is, if there is one technology that was really, really well done in 4G, it was channel aggregation. What that allowed you to do was not be constrained by the bandwidth of a single channel. And moreover, it was not constrained to using only exclusively licensed bands. So this curve over here, where you're seeing this throughput over LAA, this is from 4 years ago, okay? This is 4G, and 4 years ago over 4G, one 10 megahertz licensed carrier, which is this purple here, and 3 unlicensed 20 megahertz channels and 5 gigahertz, we were getting 100, 150, and this is actually an average. Peak rates were almost 200 megabits per second, right? So you didn't need a new technology. You didn't need 5G to get 200 megabits per second. Yes, the range is low, but this particular base station was deployed right in front of the college bookstore. In front of a college bookstore, there are a lot of people who gather outside. Wi-Fi outside is really bad. You want more bandwidth right there. So understanding how to use capacity where you need it is supremely important. This curve on the right side shows measurements from this year, and this was in South Bend when University of Notre Dame is. And we did very detailed tests on 2 modes. Verizon is one of the carriers here, using C-band. So this is the 3.7 gigahertz band, 60 megahertz channel. And then Verizon also, from that same base station, they're doing LTE with carrier aggregation and using 5 CBRS channels. So CBRS in the US is a shared band, which is shared by incumbents. So it's lower power, it's not exclusively licensed. It is opportunistic. If there is nobody else using it at the time, you will use it. Look at the difference in throughput you get. With 4G using carrier aggregation, you get almost 300 megabits per second. C-band, 5G, you get 55 megabits per second. And these are many, many points. It's not just one. So this is why I show a probability distribution function, because we took hundreds of measurements to create this plot. So again, it's the bandwidth that matters. Technology is actually secondary. And so given what I have learned from these studies, I really feel that when we look at 6G, we should be looking at something which I call sharing native, which is how do you define 6G? Not more antennas, more fancy features, all of that, but how do you make it work better? Because even though those throughput numbers were very good, there were a lot of problems that I don't have the time to go into details. We have to address the fact that mobile data demand is growing, but the growth is predominantly indoors. So some of the really nice use cases that Rajiv mentioned, factories, robots, Industry 5.0, large percentage of those applications are indoors. 6G, especially if it's in 7 gigahertz, is absolutely not going to be able to serve those use cases, right? The network we have today is primarily a legacy outdoor network. We've talked about energy efficiency a number of times. The worst thing that you can do for energy efficiency is put a megawatt transmitter outside to try and get that signal to overcome 20 to 30 dB of building loss to serve all of your indoor needs. This is extremely, extremely inefficient. Spectrum, if you're looking at sharing native, we've heard 7 gigahertz band mentioned a few times. Nobody has talked about the incumbents in that band, at least in the US, and I believe in NATO, in Europe, and maybe in India too. There are many incumbents there already. There are satellites there are federal incumbents, there is earth sensing. It is not a clean band. It is not just waiting to be auctioned off in 500 megahertz segments. That is absolutely not the case. So if you want to reuse that band for high power, exclusively licensed, maybe you can do it, but you're not going to get 1500, all of it. Maybe you'll get a few hundred megahertz. Why should we not try to think about how we use the rest of the bandwidth inside in a shared environment where you're basically doing spectrum reuse. You use the same spectrum outside for your incumbents, spend it inside. In the US, we are seeing neutral hosts develop a lot using CBRS. So when you walk into a building and your cell phone drops, if you have a neutral host which is deployed inside the building on a different band and your phone just seamlessly transfers over to that band, you've done two things. First of all, you have as a consumer, your performance improves because you're connected to an indoor network. It's a cellular network, it's not a Wi-Fi network. Two things, you've released resource blocks that now can be used for outside users. When you move indoors, your signal strength drops, you end up using way more resource blocks than when you were outside. That's a very, very, very inefficient use of spectrum. Now, does this all mean that you don't need high power exclusively licensed spectrum anymore? Absolutely not. We absolutely need this spectrum because that is the tether. But the question which as an academic, I am really trying to address is if I look at the mix of spectrum available, how much of this kind of spectrum do I need? So for me, the 6G challenge, and I think this is especially true for a country like India, where you have so many use cases, so many different applications, let us look about 6G to be seamless, ubiquitous, and use all kinds of available spectrum. And for this, I believe it's not just about looking at the physical layer or the MAC layer. We have to do a full stack rethink, from the architecture. How do we do small cells inside, large cells outside in terms of spectrum and handovers? The other thing I would really advise people to do is separate the technology from the frequency. No matter how many people say it and how loudly, I do not believe that 6G or any G at 7 gigahertz will solve the rural connectivity problem. If you're thinking that is going to happen, you can forget about it. Rural connectivity is not dependent on technology. It is dependent on picking the right frequency and deploying the base stations. If you're at a lower frequency, you will need fewer base stations. And now you talk about some of the methods I mentioned. You go into a smaller place. where you need data, where you need more capacity. Deploy small cells over, say, unlicensed band where you don't have, new bands. The biggest drawback, especially in India, is backhaul, okay? This should be totally independent of G. It should not matter what G is being carried over a backhaul link. The spectrum needs and system needs of a backhaul system are very different from access. 5G tried to do integrated access and backhaul. That has not been deployed. It has not been a success. I think somebody mentioned today that there was some other mention in some other section, and I had these slides already made. 6G, I believe, should be the last G. There is no reason in the era that we live in today, where everything can be made scalable and upgradable through software and firmware, that we need to completely develop new technology every 10 years. I understood that if we come up with something, so we have to be a lot more discriminative, Do you put in a technology in 6G and just call it 6G, or do we really think that that technology is going to make a huge difference? People talk about 5G not being a success, and we have to ask ourselves why. There really weren't any big technology advances in 5G. It was OFDM, it was MIMO, they put in multi-user MIMO, but it hasn't really been deployed. Very little that has been done that's different. 5G, for example, should not have stopped at just specifying 100 megahertz channels. Why? It's a specification. Let it be. Maybe today we just have 100 megahertz channels. Tomorrow we have more. Why do you not make the numerology scalable? And new features we should try, and with the Open RAN movement, and India, I think, is really doing a good job in that. Let's try to make 6G as much software upgradable as possible. And I mentioned the channel aggregation. The final point I want to throw out there that people don't really talk about that much is TDD synchronization is a good thing. TDD channels is good, but in the US, it is emerging as a bottleneck. Because if you're deploying a nationwide network using TDD, you can only do one uplink downlink split without causing interference between adjacent users. Now, 3GPP has defined, I think, 70 plus TDD splits. What's the point? What's the point of just putting something in a standard without doing the careful analysis as to how that feature is actually going to be used? Many of the use cases mentioned are uplink heavy. Most of the deployed 5G networks are downlink heavy because you cannot switch between uplink and downlink that easily. So let's think about much more deeply, instead of at the very high level with these nice figures about what 6G is going to be. Let's really think about how these systems are going to be used. So I would actually go back and reevaluate FDD channels. They have inefficiencies, but can we really come up with ways to address some of those? I think that's my last real slide. I'm happy to share my slides. The next two slides have a list of all the papers that we've done. We focused a lot on measurements. So we've done CBRS measurements, 6 gigahertz sharing. And at this point, I'm happy to stop. And as the last speaker, I guess we can now open it up to questions. Let me stop my sharing.
Thank you, Professor. I think very informative that I think you have shared what is your US experience and what should be done for the India. So now, sir, we have finished the presentation part. So it's for the organizer. If you feel that we can open the questions, I'm not going to ask any questions. So it will be by you. Yeah, please. And you just mention your name and to whom you want to ask the question also.
Sir, I'm Dr. Jagdish Shivare, professor and ex-scientist ISRO. This is a general question. What are the risks of 6G network in terms of physical tampering, potential drawbacks, uncertainties, and delays in implementation?
I think this is a question only I can ask. So since we don't know what is 6G still being defined, so let us, I think, try that we can do best usage of 6G for mankind. People all say that I will, Japan say that with the 6G I will solve my problems. I mean, each one is thinking in a different way. So I'm sure that it's the first time we are thinking to develop a 6G which will be best for the mankind. So let us not say that drawback. It has all advantage, and I'm sure that once we work together, entire world, with collaborations, so I'm sure we can solve this problem.
Thank you.
Anyone else? Tewatiya Sahab, he can't ask question, he should supply answer.
Well, thank you, very interesting presentations. So the challenge, you see, every time we are developing a technology, telcos do not develop use cases. You know, there is this popular thing both in DOT and on. The use case is to sort out your efficiency in agriculture, in sewage management, in smarter cities. You know, my suggestion is we are talking to each other too much within the telecom fraternity. You need to talk to other people who will use this, whether it's the automobile sector. You know, you had that education presentation, I think one of the professors, I don't know if he's still online. I attended a Panchayati Raj conference in Lucknow. One school principal said, yes, very nice, I've got a TV, I've got software. She says, my syllabus is still governed by what is specified by the Education Department of Uttar Pradesh. So this technology actually doesn't help me. So even in DOT we had, sorry, it's getting a bit longer, but in DOT we'd set up a committee which had minimum joint secretary level people of other verticals. So I think as part of Bharat 6G Alliance or within DOT, let us set up other verticals where we can talk that, okay, what is it that the education sector wants and which can be enabled by 5G or 6G or whichever G. The automobile sector, yes, has been doing some work, but maybe, you know, the smart city people or any other vertical, whether it's water management. You know, one of the things I worry about, the two things, we are talking of sustainability, we are talking of all this. How can we build a use case scenario to enhance your cleaning up Delhi's air? Right? What kind of sensors, what applications, and see what kind of use cases. The other is, the world is going to have water wars, water management. And we don't talk to the water department as to how you will take, you know, the benefit out of a network which is already available.
So I think I fully agree with you, and that's, I had my practical problems. I mean, this is what I think experience in being in DOT at that time. Whenever we were approaching to health or it's been smart cities, they were never listening that why DOT personnel is coming to me. But I am sure that I think over these 3-4 years, there is a lot of development. And let me tell you that we have included in Bharat 6G Governing Council space, defense, railway, MIT, DST. So about 6-7 ministries are there as a part of Governing Council. Purpose has been that they have to drive. It's nothing to do, I think we can't alone, we can't do anything. And same way hyperscaler, cloud, you are referring to automobiles. So they have to come there and discuss there. And that is a platform that there is no government, I mean, you can just whatever you want, you can discuss. So that's the ideal situation when all the user department centers should come together and say that what is required from the government for their use cases. And still we have time. I am sure that we will do it.
Can I answer that question? Can I address that question a bit?
Sure, I think.
Okay, so I agree very much, and I think the difference is, again, as I mentioned, there is technology and that's how it's deployed, right? At least in the US, the kind of applications that the gentleman talked about, private networks for schools, private networks for smart cities, private network, those are all happening with 4G. Actually, a lot of it is still 4G and 5G technologies, not deployed by telcos, deployed by private networks. So today, it is actually very, very, in fact, in our university, we're going to be deploying a private network with 5G equipment, but over different spectrum. And so the tie-in with spectrum policy is very important. A lot of use cases cannot be served by the telco deployment. They just cannot. They need their own deployment inside a factory. Maybe you need all uplink. How are you going to do that with a telco? Maybe in a school, you need many more devices. Your telco provider is not going to be able to do it for you. So I think one of the key things as we're looking forward to, whether we call it 5G, I mean, I think that that ecosystem maturity of using a technology outside the telco environment is absolutely essential if we want these different use cases to flourish. Agriculture, the telco is not going to do that application for you. But suppose you made it available for a farmer to very quickly put up a satellite backhaul link, put up a 5G base station in the field where he needs coverage for his automatic tractor or whatever else he wants to do. That is what we want to enable. So I absolutely agree that we should move the discussion of the Gs. It should not only be telcos. It should be every other vertical should be empowered to deploy their own networks.
Yeah, I think you just wanted to supplement, please.
Thank you. To your question, I think it's an excellent question. And in my experience, it takes time, right? Taking automotive as an example. The discussions between the cellular 3GPP IMT community and the automotive community have been going on for many years. And I was involved in those initial discussions. And when you bring two ecosystems together, you don't understand their timescales and their product requirements. And the automotive, I remember in meetings saying, our product lifestyle's about 30 years, right? So could you just provide us a chipset that lasts 30 years? That's a bit tricky, right? And so there's all those understandings that you need to get to. And then you need to introduce the requirements into the standards. And there's a whole lot of training and iteration involved. And education, I think that's fascinating because I remember Qualcomm did some work in the US trying to engage younger people through the mobile device and through the mobile operators network to engage them in education. And it was remarkable, successful. So the young person wasn't at a desk in your home, they were outside. And it was just with the phone interacting and asking questions and doing a bit of homework and the interactivity. So that complemented the classroom. So I think it's a fascinating question and opportunity. And the broader issue around education is, around the world, the emerging middle class, right? And they want private education after the kids come home from school. They want tutoring and all that kind of stuff. So there's huge opportunities there, not just inside India, but exporting that globally. So I think that's a fascinating point. Thank you.
Thank you. I think one more. That will be the last question, please.
Yeah, hello. Heiko Ross from Alice Telecom. I'm from Germany. There was a presentation this morning that in Germany we have been giving spectrum to private networks since 2018. And I've been involved since the first month. And I've been talking to the automotive sector, to the chemical sector, to you name it. And the biggest setback that we still face today, it's not the availability of 5G technology, it's not the availability of spectrum, it's applications, use cases, and it's devices. The devices that are needed in the vertical sectors are mostly only Wi-Fi enabled. And the number that are 5G enabled is very, very limited. That's why it just doesn't find the adoption. The other thing is that you have telco on the one hand side, telecommunication, and you have OT on the other side. So there are, there's 5G ASEA and other organizations that bring these things together. But it just hasn't happened yet. I do believe now that there's going to be a change right now, because there's a big industrial powerhouse, or an industrial automation powerhouse going into this, which is Siemens. And Siemens, when you talk to them, they have a completely different thinking about this whole story. They are forced to go into this because so far the whole industrial automation has been based on Wi-Fi, but they see that they have to have a product that can also do 5G. And when you talk to them, it's not about 5G or 4G. That's not, they don't care about that. It's all about realizing industrial automation use cases. And they bring also devices along with it. And that's maybe the big difference that will change the things to what we initially thought of it would be already today, to where, yeah, we were going to hope it would be today. But right now, it's still the challenge. And again, I hope that this introduction, or with Siemens now really pushing into this, that this will change things. Thank you.
Thank you. I think that was the excellent advice. And that's why I think it comes to, again, the first, that India's startups has a lot to deliver, whether it's 5G or 6G. So they have to be part and parcel of this development, and government has to think that they have to fund the applications use case development from India, not for the only India, but for the world. With this, I think I would like to thank first my chairman, Dr. Rajkumar Upadhyay, who is, I think, with us in Bharat 6G Alliance also. And we both are member secretary and member treasurer. So we are the founding from the day one why such association is necessary. And I am sitting in the same campus in CDOT. So we are same close, I think we are sitting together. So I would like to thank you, sir. And same time, other panelists, those who are over VC, and especially Professor Ghosh, she has become, for her, it's the early morning. And all my panelists, they are from the semiconductor, from OEM, from academia, and government. So thank you all. Sir, you would like to say something?
Thank you, Pathak ji. I think it was a wonderful presentation from all the panelists. A lot of work has to be done on spectrum, on devices, on chips, on sensing, use cases. Professor Ghosh talked about, a new perspective of, she gave that what is happening on 5G monetization, sharing of spectrum, how do we use unlicensed and licensed shared spectrum. I think a lot of new things will come up. It is still in debate stage. ITU is also working out. And over the time, as these debates happen, these conferences happen, more things will crystallize. And I look forward for, a good collaboration amongst the academics, industry, R&D, and the government, so that India, as a country, we move forward very well in this direction. So thank you for all of your presence here. I think together all these brilliant minds will come together and have good solution for our country and for the globe. Thank you so much.
I think back to you.
Thank you so much, sir. Thank you. It indeed was an amazing and interactive session. I extend my sincere thanks to all the panelists on the stage and online. You shared your expert views with all of us. Thank you so much once again. Ladies and gentlemen, this concludes a remarkable 2 days mindstorming sessions of ISMC 24. I request my panelists to please remain seated. I request Mr. Bhatia to kindly give the closing remarks. We'll do the mementos first. So request the chair of the session, Shri R.K. Upadhyay, sir, to please present the mementos to our speakers. Firstly, to Professor Radhakrishnan Ganti. Professor Ganti, sir. Thank you so much, Professor Ganti, for sharing your views with us. Shri Prashant Kumar. Thank you so much, Shri Kumar, for joining us. And last but not the least, Professor Paresh Saxena. Thank Thank you, Professor Saxena. I request Mr. Bhatia to please present a memento to our chair and the session coordinator and moderator, R.K. Upadhyay, sir. And Shri R.K. Pathak, sir, for moderating the wonderful session on 6G. Thank you, everybody. May I request you all to please pose for a group photograph?
I think I want to give this our first report of Bharat 6G Alliance on spectrum and others 4 reports we have. Spectrum, applications, I am sure it's huge case and more important is revenue stream and sustainability. And these are all available on Bharat 6G Alliance.
So you can use the mic as well so that the people at the back can hear you. Thank you so much, sir. May we request all the panelists to kindly pose for a group photograph. Thank you so much. May I request Mr. Bhatia to please give the closing remarks, and everyone on the panel can please remain seated.
Thank you very much, and thanks Dr. Upadhyay and my friend Pathak ji and all the eminent speakers, panelists. We had, I think, very hectic last 2 days. Yesterday we started from morning and it went on till late night. I think some of the delegates had to be pushed out of the room after 10 o'clock, but we were still active. Very, very hectic parleys, discussions, and we covered a number of subjects. We talked about WRC, we talked about spectrum for 4G, 5G, 6G, we talked about private networks, we talked about PMSC, we talked about every possible subject, even spectrum management organization, even some new systems. LS Telecom, Mr. Ross is here. He brought some very innovative ideas as to how, whether the users can themselves allocate their own spectrum, and a lot of innovative ideas came up, and really, really pressing to see. One more thing that happened this time, we had experts not only from the telcos or from 4G, 5G, but also from other areas like broadcasting, radio astronomy. You know, we have the GMRT in Pune, which is one of the largest in the world. 45-meter antennas across 30 kilometers of space. It can even sense galaxies around the world. So we covered practically every subject. And I think this was a great knowledge sharing. And particularly this last session, this session that you chaired, this session was very interesting because I think as India, we were lagging behind in 3G. We didn't do 3G. We a little bit lagged behind 4G. We are leaders in 5G, at least in deployment. And in 6G, we want to be a leader in technology. So I think this was a very good, befitting concluding of this 2-day session. So thanks so much to everybody. I must thank all our participants. I must thank all our sponsors. All this would have been possible only with the support of all the industries, and I see a number of sponsors here. So I won't name each of them, but you can see. And with everybody's help, we were able to put together this mega conclave for 2 days on spectrum, and thankful. And we will be back next year around same time. The date will be announced, but we would have the 5th Spectrum Management Conference in October, November 2025. So keep looking for that date. And hopefully we will have much better, maybe 3 days. 2 days is not enough. And we have a lot of learnings from this conference that we will put to use and try to do more interactive sessions. So with that, before I close, I think it's a good idea if we can all join for a picture here. So I can request everybody to come up here so we can take one big picture photo of the people who are here. Yesterday we had more than 250 people in the opening. But we still have a large gathering here, so kindly join us here.
So everyone on the floor? Can we have everyone here group photo? I request everyone to please join us for a group photograph. Everybody on the floor. I'd like to thank our speakers, distinguished delegates, our guests from overseas, the organizers, the conference partners, and everybody involved in making this conference a grand success. Thank you, everybody. I thank our gold partners, Airtel, Ericsson, GSMA, GSA, GSOA, LS Telecom, Eutelsat OneWeb, Shore, Telesat, Qualcomm, our conference partners, CDOT, Bharat's 6G, Wireless World Research Forum, our media partners, Communications Today. Thank you, everybody. All our delegates, thank you so much for joining us for this wonderful 2 days 4th India Spectrum Management Conference. Thank you, ladies and gentlemen. I request you all to please join us for a networking tea and coffee. We request you all to please join us for tea, coffee. And looking forward to see you all next year. Thank you so much. Have a wonderful, wonderful evening ahead.